Hello everyone, welcome to PrepFusion. So in this video we are going to start studying about Fourier series. So we have completed our first two chapters, basics of signals and basics of system. Now Fourier series we are going to start, and it is one of the best chapter not only for signal system but for your whole electronics, because your whole electronics just revolve around Fourier series. So it is a very important chapter. Okay. And in this particular video, in this first video, you need to have your full patience and full concentration. Otherwise, you will not be able to understand the basics of Fourier series. So have the patience and have the concentration as well. And by the end of the lecture, you will understand every single thing about Fourier series. So this first video is very important. Now, before starting this particular lecture, you need to watch orthogonality of signals. So you need to go to our marathon 2 and watch this particular video, orthogonality of signal, which is of roughly around 1 hour 20 minutes. Because if you don't understand the meaning of orthogonality, if you don't understand the meaning of orthogonality between sinusoids and cosinusoids, then you will not be able to understand this particular lecture. So this is very important. So just go to marathon 2 and study about orthogonality of signals, then only come back. And if you are following right from the beginning, then you just need to revise your notes and then come back to Fourier series. So now we will start a Fourier series. Okay. So what I was having a periodic signal with me. Okay. This is the input signal. This is one signal that I am having. This is the periodic signal that I am having. This is a square wave, right? With the time period of 2 seconds. Here I can see that the time period is 2 seconds. Now I was in the lab. In the lab, I saw there is a box, and on the box Fourier series is written. Okay, on this particular box Fourier series is written. Now this box is having some input port and some output port. Basically, on this box you can apply some input and you will receive some output. So to the input of this box, I applied this xt signal. To the input of this box, I applied this periodic xt signal. So at the output, I will receive something. This input was given to the input of this box, and at the output, I will receive something. So what this box did? This box broke down this input signal. This box broke down this input signal in some sinusoids. Basically, at the output, you received these sinusoid. A lot of sinusoid you received. You received infinite sinusoid actually. Okay. When you gave this particular signal as the input of the Fourier series, at the output you received a lot of sinusoids. What does that mean? That this particular input signal was the addition of these sinusoid. When you add these sinusoid, 1, 2, 3, 4, 5, in the screen you can see only 5 sinusoid, but actually you received infinite sinusoid. So when you add all these sinusoids, what do you get? You get this particular signal. What does that mean? That inside this particular signal, a lot of sinusoids are present, which you actually cannot see. By the Fourier series, by using Fourier series, you will get to know that inside this a lot of sinusoids are there. Now we need to care about the frequency of these sinusoids. Okay, so first let's talk about the time period. So what is the time period of this particular sinusoid? You can see that this particular sinusoid is having a time period of 2 seconds, right? I am calling it T01. What about the time period of this particular signal? Sir, time period of this particular signal is till this point. You will say that, sir, it is till this particular point. But we cannot tell, right? We cannot tell how much is this window. So what we can see is that in 2 seconds, you are having 3 period. 1 period, 2 period, and then 3rd period. So in 2 seconds, you are having 3 period. That means how many seconds will take for 1 period? How many seconds will it take for 1 period? So in 2 seconds, we are having 3 period. 3 period equals to 2 seconds. 1 period equals to 2 by 3 seconds. That means time period is 2 by 3 seconds. So this guy is having 2 by 3 second time period. Right? What about this one? 1, 2, here 1, 2, 3, 4, and 5. So here how many cycles are there? 5 cycles are there. That means what will be the time period? 2 by 5 seconds. Here time period would be 2 by 7 seconds because 7 cycles are there. And here time period would be 2 by 9 seconds. If I call this as omega naught, why I am calling this as omega naught? Because my time period was t naught. What would have been my omega naught? 2 pi by 2. Sorry, 2 pi by t. That means 2 pi by 2. That means pi second. So my omega naught would have been pi second. right? Fundamental frequency. So this particular signal was having a fundamental frequency of pi second, not pi second, what I am doing, really sorry, pi radian per second, pi radian per second. So this particular signal was having a fundamental frequency of pi radian per second. Then when we broke it down, we got to know that it is having a sinusoid of omega naught. That means it is having a sinusoid of pi radian per second. Along with that, it is having a sinusoid of 3 omega naught. Because what will be the omega naught 2 here? What will be omega naught 2? That will be 2 pi upon pi by 3, 2 pi upon t naught 2. What is t naught 2? 2 by 3. So 3 will go upward. That is 3 pi. And what is pi? Pi is equals to omega naught. So this is 3 omega naught. What is this? This is 5 omega naught. What is this? This is 7 omega naught. What is this? 9 omega naught. After that 11 omega naught, 13 omega naught, 15 omega naught, that will come. As of now, I am not talking about this amplitude. I am not talking about this amplitude. What is the peak value? I am not talking about this peak value. I am not talking about this peak value. One thing you can see that peak value is continuously going down. One thing I can see that the peak value is continuously going down. This is somewhat greater than 1. This is somewhat greater than 0.25. This is somewhat greater than 0.2. This is somewhat less than 0.2. This is somewhat greater than 0.1. So peak value is continuously going down. But as of now, I am not talking about the amplitude. I just got to know that when I broke down this particular periodic signal, in this periodic signal, I was having a sinusoid of frequency omega naught, 3 omega naught, 5 omega naught, 7 omega naught, and 9 omega naught. So what I can do? That my xt can be written as, it will have some DC value, okay, any signal can have some DC value, but here I can see that DC value is 0, because what is DC value? DC value is simply the area of one particular time period divided by the time period. So what is the area of one time period? That is 0 only. So here I can see that DC value is 0, DC value is 0, this value is 0. Along with that, I am having a sinusoid of omega naught frequency, right? Whatever the amplitude is there, I don't care. Along with that, I can have the sinusoid of 2 omega naught frequency as well. But here what do I see? That I am not having the sinusoid of 2 omega naught frequency. That means this was 0. Along with that, I can have sinusoid of 3 omega naught frequency as well. Right? A3, 3 omega naught frequency. Then I got to know that I can have sinusoid of 4 omega naught frequency as well. But when I saw this particular signal, I got to know that 4 omega naught frequency is not there. That means A4 was 0. A4 was 0. In that manner, I was proceeding. So these kind of sinusoid I was having. But when we saw this particular thing with other signals, we got to know that it can have a cosinusoid as well. If it is having sinusoid, it can have cosinusoids as well. Basically, it can have B1 cos omega naught t, cosinusoid of omega naught frequency, cosinusoid of 2 omega naught frequency, cosinusoid of 3 omega naught frequency, in that manner. But when we pass this particular signal, in the Fourier series, we got to know that it is not having a single cosinusoid. That means it is having only sinusoids. So that means all these are 0. All these are 0. All these are 0. So what did you understand? What did you understand? You understood that every particular signal, every particular periodic signal in this particular chapter, when I am talking about Fourier series, that means I am talking about periodic signal. So in this whole chapter, we are just focusing on periodic signals only. So every periodic signal can be broken into a DC part. Okay, DC part I am showing by C note. It can be broken into a DC part. Okay, along with that, it will have sinusoids and cosinusoid. Sinusoids of frequency omega naught, 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught till infinity, and cosinusoids of frequency omega naught, 2 omega naught, 3 omega naught till infinity. Now it is not necessary that all these will be non-zero. It is not necessary that all these values will be non-zero. Some can be 0 as well. Here B1, B2, B3, B4, B5, B6, B7, B10, all these are 0. Here DC, A2, A4, A6, A8, A10, all these are 0. So it will have a DC and it will have sinusoids of frequency n omega naught. Sorry, this I am talking about cosinusoid. So it will have cosinusoids of frequency n omega naught. Just one here, just replace A with B and B with A. Actually, sinusoids are represented with B. Okay. Although you can represent by anything, but generally sinusoids are represented with B and cosinusoids are represented with A. So replace B with A and A with B. So cosinusoids are represented with A. So it will have cosinusoids. Okay, cosinusoids of n omega naught frequency, where n is going from 1 to infinity. So when you open it up, what you will get? A1 cos omega naught t plus A2 cos 2 omega naught t plus A3 cos 3 omega naught t plus A4 cos 4 omega naught t plus A5 cos 5 omega naught t, in that manner. Is that clear to you? Is this expression clear? Right? Cosinusoids of n omega naught frequency. We will be starting with omega naught, 2 omega naught, 3 omega naught. Basically, what will be the time period of this particular signal? That would be t naught. And what will be the fundamental frequency? That will be omega naught. Here we saw that this was having t naught and fundamental frequency was pi. So here fundamental frequency was pi, here it was 3 pi, here it was 5 pi, here it was 7 pi, here it was 9 pi. Then we got to know that this is omega naught, this is 3 omega naught, this is 5 omega naught, 7 omega naught, 9 omega naught. So first what you need to see, you will see xt, then you will get to know that xt is having a fundamental time period of t naught and fundamental frequency of omega naught. So now in this particular signal, I will have a dc plus a1 sin b1 sin omega naught t plus b2 sin 2 omega naught t plus b3 sin 3 omega naught t, in that manner, plus a1 cos omega naught t plus a2 2 cos omega naught t plus a3 3 cos omega naught t plus a4 cos 4 omega naught t. Okay, sinusoids and cosinusoids of n omega naught frequency. Along with that, it will have a sinusoid as well. So n goes from 1 to infinity, b1 sin n omega naught t. There you go. This is the meaning of Fourier series. Any periodic signal having time period of t naught and fundamental frequency of omega naught can be broken into DC and sinusoids and cosinusoids of frequency n omega naught. Okay, where n omega naught will vary from omega naught, 2 omega naught, 3 omega naught, 4 omega naught, and this is the broken down expression. One more thing, all these are orthogonal to each other, right? Sin omega naught t is orthogonal to sin 2 omega naught t. Say yes or no? Different frequency, that means orthogonal. Sin 2 omega naught t is orthogonal to sin 3 omega naught t. Yes. Sin 3 omega naught t will be orthogonal to sin 4 omega naught t. Sin omega naught t is orthogonal to sin 4 omega naught t. Sin omega naught t is orthogonal to sin 3 omega naught t. That means all these are orthogonal to each other. Sin omega naught t is orthogonal to cos omega naught t. Yes, because there is a phase difference of 90 degree. Sin omega naught t is orthogonal to cos 2 omega naught t. Yes, because different frequencies. So either they are having different frequencies or they are having the phase difference of 90 degree. So all these expressions are orthogonal to each other. Sin omega naught t is orthogonal to sin 2 omega naught t. You pick any two cosinusoid or sinusoid, they will be orthogonal to each other. Let's pick this one and this one. Are they orthogonal to each other? Yes. Let's pick this one. Let's pick this one and this one. Are they orthogonal to each other? Yes. So all these are orthogonal to each other. Okay. So it is said that your xt is broken into the pairs of orthogonal signal. Your periodic signal is broken into the pairs of orthogonal signals. All these are orthogonal to each other. So this is the actual meaning of Fourier series that we are learning here. Well and good. So a Fourier series is a way to break down any periodic signal or any periodic function into a sum of simple sine and cosine wave. It's like turning a complex wave into mix of smaller waves with different frequencies. Basically, this particular wave was broken into a smaller wave of a different frequency. Basically, if you add them up, if you add all these up, you will get the same expression again. Okay, what all things are written? For example, a square wave can be written as a sum of sine wave with different amplitude and frequency. The more sine wave you add, the closer you get to the original shape. Basically, if I add only 2, then different shape I will get. If I add only 3, different shape I will get. If I add infinite waves like this, then I will get the same expression. Are you getting this point? Okay. So this is the meaning of Fourier series. Let's see another example. We are going to do the same kind of thing. This time, what is the scene? This time you need to go to the lab again and you need to implement all these things on your own. So basically, what is the scene now? There is a question that this particular signal is given. This particular xt signal is given, which is having a fundamental time period of 2 seconds. Fundamental time period of 2 seconds. Okay, you can see this signal is periodic. Directly you can see same waveform is being repeated. Same waveform is being repeated. Now, if it is periodic, then one thing I am pretty sure that it would be made from some sinusoids and cosinusoid and DC. If it is a periodic signal, then it is made from sinusoid, cosinusoid and DC, and sinusoid and cosinusoid of frequency and omega naught, right? Now you need to go in the lab and you need to find the expression of xt in terms of sinusoid, cosinusoid and DC. This is the thing you need to do in the lab. So you will make a setup there. What kind of setup you can make? This you can think on your own, but as of now you don't need to think. That setup I will make. So what kind of setup you will make? This kind of setup you will make. What you are going to do is that there is a multiplier. What is the job of multiplier? That it will multiply two signals. So at the input of multiplier, you will apply xt, and here you will apply something from your own side. What you will apply, that I will tell. Okay, and then you will integrate. Then what you are going to do? You will integrate for one time period. What you are going to do? You will integrate for one time period, and then you will receive some output. Okay, so we are having some xt signal. We don't know what is the expression of xt. Okay, then what I am gonna do? What is the time period of this particular xt signal? That is 2 seconds. So what will be omega naught? Omega naught will be 2 pi by 2. That means pi radian per second. So first what I did, I am having the omega naught value of pi radian per second. That means my omega naught is pi. My 3 omega naught will be 3 pi, or 2 omega naught also again, right? Why 3 omega naught? 2 omega naught will be 2 pi. 3 omega naught will be 3 pi. So here I will apply sinusoid, cosinusoids of omega naught, 2 omega naught, 3 omega naught, 4 omega naught frequency. What do I mean by that? Here at the input of the multiplier, I will apply sin pi t now. Sin pi t. Here at the input of the multiplier, I am applying xt and sin pi t. So what is the job of multiplier? It will do the multiplication. So here what you will receive? Xt dot sin pi t. Then what is this? This is the integrator. It will integrate for 1 t naught. What is the value of t naught? It will integrate for 2 seconds. Okay. So what we will be getting at the output? This is my output. So what will be your output? Your output will be the integration of xt dot sin pi t. Okay. So you are in the lab. In the lab you will get some answer. You are in the lab. All these things are happening on a board. So on a board you will get some answer. But as of now we are not having any board. As of now we are not in the lab. So we need to know what is the expression of xt so that we can perform this integration. Are you getting this point? As of now we don't know the expression of xt. We are performing all these things in the lab. But as of now we need to do all these things on the paper because we are not in the lab. We need to do all these things on the paper. So if I am doing it on the paper, then I need to know the expression. So here I am revealing the expression of xt. The expression of xt is this: 2 plus 4 sin 3 pi t plus 5 cos 5 pi t. Although we don't know this particular thing, although in the lab we don't know the expression of xt, but here we need to know the expression of xt because we need to perform this particular integration. So what we are going to do? We are going to integrate it for 2 seconds. What is my xt? Xt is this: 2 plus 4 sin 3 pi t plus 3 cos 5 pi t multiplied with sin pi t dt. What do you think? What will be the result of integration? Do you need to perform this integration? No, because first 2 will be multiplied with sin pi t. So what we are getting? We need to integrate for 2 seconds 2 into sin pi t dot dt. Let me know what will be the answer of this integration. 0. Why is that so? Because what is the time period of this? 2. So you are integrating a sinusoid for one time period. You are integrating a sinusoid for one time period. Answer will be 0 only because the area will be 0. Plus next 4 sin pi t, 4 sin 3 pi t, sin pi t dot dt. What is the answer? Sin pi t, sin 3 pi t. What is the answer? All these two are orthogonal to each other, and if they are orthogonal to each other, 0. And for the next integration as well, cos phi pi t and sin pi t, what they are? They are also orthogonal to each other. So 3 cos phi pi t dot sin pi t dt. So they are orthogonal to each other. So 0 plus 0 plus 0, what will be the answer? 0 only. So here what answer we will get? 0. So in the lab, what did I do? I made the setup. At the input of the multiplier, I applied xt and I applied sin pi t. I multiply both of them and then I integrate over 2 seconds. Then at the output, what I am receiving? 0. What does that mean? That this xt is not having sin pi t inside it. That's it. Again, I am repeating. I went to the lab, I multiplied xt with sin pi t and then I integrated it over a time period. At the output, I received 0. That means what I applied? I applied sin pi t. So this sin pi t is not there inside xt. That is the conclusion that we have made. So this is the first thing that I did. I applied sin pi t. Now just let me know in the next cycle, in the next task, if I apply sin 2 pi t, what will be my output? At the input, now I am applying sin 2 pi t. What will be the output? Again, it will be 0. Why is that so? Because instead of sin pi t, what you will write here? Sin 2 pi t. Now sin 2 pi t to sin 2 pi t integrated over a time period. What result? What is the value of t naught? T naught is 2 only. Sin 2 pi t is having a time period of 1 second. So you are integrating as sinusoid for 2 cycles. Integrating a sinusoid for 2 cycles. What will be the total area? 0. So this will be 0. Then sin 2 pi t cos 3 pi t orthogonal to each other. Cos 5 pi t sin 2 pi t orthogonal to each other. Again the answer will be 0. So if I apply this particular input as sin 2 pi t, again my answer is 0 only. I am calling this as alpha t. Alpha t. Okay. So here my alpha t was sin pi t, then my answer was 0 only. Okay. Now if I apply my alpha t equals to sin 2 pi t, then also my answer is 0 only. If I apply my alpha t equals to sin 2 pi t, then also my output will be 0. Why it will be 0? You have understood. Because this will be orthogonal. It will be 0 only, right? If you apply alpha t equals to sin 3 pi t, if you apply alpha t equals to sin 3 pi t, then what will be your output? Will it be 0? No, it will be non-zero. Why is that so? Let's apply sin 3 pi t here. Let's apply sin 3 pi t. Okay. What I am applying? Sin 3 pi t. So alpha t will be multiplied with xt. That means sin 3 pi t will be multiplied with xt. And then you will integrate over a time period. So what will be your output? Output will be integration over a time period. Xt is multiplied with sin 3 pi t dot dt. What is your xt? 2 plus 4 sin 3 pi t plus 3 cos 5 pi t. 5 pi t dot dt. I am integrating over a time period, not dot dt, sorry, multiplied with sin 3 pi t dot dt. Okay. So to multiply with sin 3 pi t, what will happen? 4 t naught. 2 multiplied with sin 3 pi t. And what is the value of t naught? Value of t naught is 2 seconds. Yeah, so value of t naught is 2 seconds. And what is the time period of this particular signal? That is 2 by 3 seconds. 2 by 3 seconds means 2 by 3 into 3. That means 3 cycles will come. 3 cycles will come. So you are, this is 0 to 2 seconds. So this much you are integrating. What will be the total area? Total area will be 0 only. Total area will be 0. So what this will throw? This will throw 0 only. What about this one? 4 sin 3 pi t dot sin 3 pi t over a time period of t naught dot dt. Are they orthogonal to each other? Sin 3 pi t, sin 3 pi t. No, they are not orthogonal to each other. Right? They are not orthogonal to each other. So now you cannot say the integration will be 0. what it will become? It will become 4 sine square 3 pi t, and then you are integrating over a time period. So the answer will come out to be t naught by 2. If you remember this, do you remember it? Sine square theta d theta. What do we do? 1 minus cos 2 theta divided by 2. Then let's just say I am instead of theta I should have written here from 0 to t naught I am integrating. So then I need to integrate from 0 to t naught. 0 to t naught dot d theta only I can write. Oh, although it should not be theta here, it should be t. Here it should be t. Okay. So here it in place of theta it is t, because from 0 to t naught I am taking 0 to t naught. Then 1 by 2 is integrated with t from 0 to t naught. What will be the answer? T naught by 2. And what this will throw? For one time period, you are calculating the area of cos 2t. In one time period, area of cos 2t will be 0 only. So what will be the answer? T naught by 2. Right? Sin square t is broken into 1 minus cos 2t by 2. So this will throw t naught by 2 and this will throw 0. So answer would have been t naught by 2. Here 4 factor will come out. Here this is a 4. This is a constant value that will come out. So answer will be thrown as 2t naught. Basically it will be non-zero. The point is it will be non-zero. It will be non-zero. And what about this? T naught 3 cos 5 pi t. 3 cos 5 pi t dot sin 3 pi t dot dt. They are orthogonal to each other, so this will be 0. So 0, this is also 0, this is also 0, this is non-zero. So what is the answer? Non-zero. So what was the answer? Non-zero. So when you are performing all these things, when you are performing this particular thing in the lab, you got to know that when I applied sin 3 pi t, my output is coming non-zero. Whatever the value is coming, you don't care about that. You just care about that if I am applying sin 3 pi t, then my answer is coming non-zero. What does that mean? That this xt is having sin 3 pi t inside it. So what did you get to know? Till this point you got to know that it is having sin 3 pi t inside it. I don't care about the amplitude. I am calling the amplitude to be b3. This is the thing till now I have understood, that it is having sin 3 pi t inside it. Then I did the same thing with sin 4 pi t, sin 5 pi t. Here in place of alpha t I applied sin 4 pi t, sin 5 pi t, sin 6 pi t. Every time I was getting 0. Why is that so? Why you will get every time 0? Because this is the expression, no? If you apply sin 4 pi t here, then sin 4 pi t you are integrating over one time period 0. Sin 4 pi t, sin 3 pi t orthogonal to each other 0. Sin 4 pi t, cos 5 pi t orthogonal to each other 0. I applied sin 5 pi t. Sin 5 pi t again integrating over a time period 0. Sin 3 pi t, sin 5 pi t again orthogonal 0. Cos 5 pi t, sin 5 pi t again orthogonal 0, because they are, although they are having the same frequency, but they are 90 degree apart. So again they are orthogonal, again 0. Sin 6 pi t, sin 7 pi t, sin 8 pi t, sin 9 pi t, sin 10 pi t. You kept on performing and you get to know that every time our output was coming 0. Then you got to know that it is having only one sinusoid of frequency 3 omega naught. Right? It is having only one sinusoid of frequency 3 pi. What is the frequency here? 3 pi. Okay, and this can be written as 3 omega naught, because what is the value of omega naught? Omega naught is pi, so it can be written as 3 omega naught. So it is having only one sinusoid of frequency 3 omega naught. This is what you got to know. All good? Right? Then I started doing the same thing with cosinusoids. So first what I will apply? Cos pi t. When I apply alpha t equals to cos pi t, when I apply alpha t equals to cos pi t, again you are integrating over time period 0. Sin 3 pi t, cos pi t orthogonal to each other 0. Cos 5 pi t, cos 5 pi t again, or sorry, cos 5 pi t and cos pi t again orthogonal to each other, again it is 0. Basically now what I am doing, in place of alpha t, here now in place of alpha t I am applying cos pi t. Then also my output is coming out to be 0 only, because here I will put cos pi t, integrating over a time period 0. Sin 3 pi t, cos pi t orthogonal to each other 0. Cos 5 pi t and cos pi t orthogonal to each other, again it will be 0. Then I will apply cos 2 pi t, cos 3 pi t, cos 4 pi t. Till you apply cos 4 pi t, answer would be 0 only, because they will be orthogonal to each other, or you are integrating over a time period, answer is 0. Say yes or no. What I need to do is that I will apply cos 2 pi t. then what will happen? In place of sin pi t, here what I need to put? Cos 2 pi t. So integrating over a time period, then sin 3 pi t cos 2 pi t, again orthogonal, cos 5 pi t cos 2 pi t, again orthogonal to each other, again answer is 0. So output is 0. So when it will come out to be non-zero? When alpha t is cos 5 pi t. What will be the output? Output will be non-zero. Why non-zero? Because here what you will put? Cos 5 pi t now. So cos 5 pi t you are integrating over a time period, answer will be 0. Sin 3 pi t cos 5 pi t orthogonal to each other, answer is 0. Then cos 5 pi t and cos 5 pi t, what it will become? It will become the square, and square will give you the answer of t naught by 2. So what did you get to know? That when I applied cos 5 pi t here, my output was coming out to be non-zero. What does that mean? That means this particular xt signal is having cos 5 pi t inside it. So what next thing you got to know? Next thing you got to know is that my xt is having, already it was having a sinusoid. I don't care about the amplitude. Okay, I don't care about the amplitude. Just one second. And it was having a sinusoid, it was having a cosinusoid as well of frequency 5 omega naught. What is this frequency? This frequency is 5 omega naught, right? So it was having a sinusoid of frequency 3 pi t, and it was having a cosinusoid of frequency 5 pi t. Cosinusoid of frequency 5 pi. Sinusoid of frequency 3 pi, cosinusoid of frequency 5 pi. That means it was having sinusoid of frequency 3 omega naught and cosinusoid of frequency 5 omega naught. So till this point we have got to know that it is having sinusoid and cosinusoid. Only one cosinusoid is there, only one sinusoid is there. Sinusoid is having a frequency of 3 omega naught and cosinusoid is having a frequency of 5 omega naught. So this is the conclusion till this particular point. Now we need to think of a DC value as well, right? Because the signal can have DC value as well. So what I did? Next I tried to calculate DC value. So how do you calculate DC value? What is the formula of average? That you integrate over a time period. You integrate over a time period and then divide by the time period. So what we are doing here? Divide by the time period and then integrate over the time period, right? Integrate over the time period and then divide by the time period. Well and good. So when I do this particular thing, what is my xt? Xt is 2 plus 4 sin pi t, 4 sin 3 pi t plus 3 cos 5 pi t, 4 sin 3 pi t plus 3 cos 5 pi t. This is your xt, right? What I am doing? I am integrating over a time period. I am integrating this over a time period. So this I am calling as my output. So what will be my output? What is the time period? Time period is 2 seconds, right? Time period is 2 seconds. T naught value is 2 seconds. Here only we saw T naught value is 2 seconds. So 1 by 2. For 2 seconds I am integrating 3 pi t, 3 cos 5 pi t dot dt. So what it will throw? This will throw 0. This will also throw 0. But what this will throw? 1 by 2. For 2 seconds you need to do 2 dt. So what that would be? 1 by 2 2t for 0 to 2. The answer will be 2. So what is the DC value we are getting? 2. So what will be the output I will receive? 2. So what did you get to know? That your xt is having a DC value plus there is a sinusoid of frequency 3 omega naught plus there is a cosinusoid of frequency 5 omega naught. This is what you got to know. Although as of now you don't care about the value of B3 and A5, but we will care about B3 and A5 as well. But as of now you don't care about B3 and A5. Did you understand the conclusion? That any periodic signal, this was my periodic signal, but this periodic signal was having a DC value, a sinusoid of n omega naught frequency and cosinusoid of n omega naught frequency, where n value for sinusoid was 3 and n value for cosinusoid was 5. So this can be generalized for any periodic signal. This is how it can be generalized. That a DC, and now it is not necessary that only cosinusoid of 5 omega naught t we will be having. It might happen that 4 omega naught t 4 omega naught cosinusoid is there, 3 omega naught cosinusoid is there, 2 omega naught cosinusoid is there, 10 omega naught cosinusoid is there, 100 omega naught cosinusoid is there, or 500 omega naught cosinusoid is there. Same goes for sinusoid as well. Here we are having 3 omega naught, but it might happen that sinusoid of 2 omega naught, 7, 10 omega naught, 12 omega naught, 15 omega naught, these kind of sinusoid can also be present. Along with that, in this example, there was no DC value, but here in this example, DC value is also present. So now the conclusion is clear. Okay, and when we made this setup we did not make this setup, Joseph Fourier made. So from here the concept of Fourier series come into action. Okay, so when he did this setup, he got to know that okay, every periodic signal, no matter whatever the signal is, it is made from sinusoid and cosinusoids only. Along with that, it can have DC value as well. So this is how we came to the conclusion of a Fourier series. Now one more interesting thing we will see in this particular example. What did we say? That we will have the sinusoid of 3 omega naught, omega naught, 3 omega naught, 5 omega naught, 7 omega naught, 9 omega naught, right? Now, if I multiply my xt with sine omega naught, okay, and then I integrate it over a time period, will I get the non-zero value? Because yes, if I am saying that it is having a sinusoid of omega naught, then according to this setup, our output should be non-zero. Say yes or no? If I multiply my xt with sine omega naught t, here I applied my xt with sine pi t. What this sine pi t is? This is sine omega naught t only, no? Because omega naught value is pi only. So when I applied xt with sine omega naught t, my answer was 0. But when I applied xt with sine 3 omega naught t, what is this? 3 omega naught t. Then my answer was non-zero. What does that mean? That it was having sine 3 omega naught t. Basically, if you add sine 3 omega naught t and you add cos 5 omega naught t with the particular amplitude, and then you add a DC there, then you will get this particular waveform. So similarly here as well, if I add sine omega naught t, sine 3 omega naught t, sine 5 omega naught t, sine 7 omega naught t, sine 9 omega naught t, and till infinity, then I will get this particular waveform. That means this should throw non-zero. Are you getting this point? Will it throw non-zero only? Omega naught value is pi, sine pi t. What will be the time period? Time period will be 2 seconds. So what will be the waveform? This will be the waveform. 0, 1 and 2. 0 to 1, 1 to 2. This will be the waveform, right? Now this sinusoid multiply with A, and this sinusoid will be multiplied with minus A. This is my sine omega naught t. Sine omega naught t is multiplied with xt, and then you are integrating over a time period. So this is the sinusoid waveform which is being multiplied with xt. That means this lobe, this positive lobe is multiplied with positive value. What I will get? A only. The amplitude will be A. This negative lobe will be multiplied with negative value. This negative lobe will be multiplied with negative value. What it will become? It will become positive. This negative value will become positive. This negative lobe will be multiplied with negative value. This will become positive. Negative multiplied with negative, this will become positive. Now if you integrate over a time period, now xt is being multiplied, this xt is multiplied with this sinusoid, and now I am integrating over a time period. That means I am integrating over 2 seconds. Will it be 0 or non-zero? It is non-zero. That means yes, sine omega naught t is throwing non-zero. The same setup I have made, whatever the setup that I have made here, the same setup I have made. Now in place of xt, I am not applying this signal. In place of xt, I am applying this signal. Then I throw sine omega naught t as alpha t. This is my alpha t. When I applied sine omega naught t, I can see that by the mathematics only, I can see that it will throw me non-zero. If I apply sine 2 omega naught t, what I apply? Sine 2 omega naught t. That means what I am applying? Sine 2 pi t. Sine 2 pi t. What is the time period? 1 second, right? Time period is 1 second. Time period is 1 second. Time period is 1 second. What is this? This is my sine 2 omega naught t. So what will happen? These particular values will be multiplied with A. So if it is positive, then it will remain positive only. If it is negative, then it will remain negative only. But now this value will be multiplied with minus A. Basically, this is my signal now. This is my signal. 0 second, 1 second and 2 second. So from 0 to 1, it will be multiplied with xt. Xt is having a value of A. So this will be multiplied with positive value. but this thing will be multiplied with negative value. So whatever the waveform that you are having here, that will be just inverted. Say yes or no? This particular waveform is being multiplied with minus a. So positive value will become negative, negative value will become positive. So positive became negative, negative became positive. So this is the this particular waveform is the output of xt sine omega naught t. Xt dot sine 2 omega naught t. Now what we are doing? Xt dot sine 2 omega naught t. Xt dot sine 2 pi t we are doing. Now our alpha t is sine 2 omega naught t. So when I am multiplying both of the signals, this is the waveform I am getting. Now what I need to do? I need to calculate the area. So if I calculate the area, what area I will get? This is positive area, negative area, negative area, positive area. So here positive area is equals to the negative area. What does that mean? Answer would be 0. For sine 2 omega naught t, you are getting answer to be 0. By the waveform only you can understand. This will be the waveform of sine 2 omega naught t. So positive cycle, from 0 to 1 second is being multiplied with a. From 1 to 2 second is being multiplied with minus a. So this will be inverted. So this xt dot sine 2 omega naught t I have made here. This is your xt dot sine 2 omega naught t. What is this? This is your xt dot sine 2 omega naught t. Then I need to calculate the area. What is the area? Plus, minus, minus, plus. So positive area is equals to negative area, total area is 0. So what output it is throwing? It is throwing the output to be 0. That means sine 2 omega naught t is not there and sine 2 omega naught t was not there. What about sine 3 omega naught t? Sine 3 omega naught t. What does that mean? Sine 3 omega naught t means that it will have 3 cycles between 0 to 2. Between 0 to 2 it will have 3 cycles. Right? These kind of 3 cycles it will have. So what kind of scene will be there? This will be these 3 kind of lobe it will be there. 1 cycle, 2 cycle and then 3 cycle between 0 to 2 second. What I am applying now? Sine 3 pi t. Sine 3 pi t. That means I am applying now sine 3 omega naught t. What I am applying? Sine 3 omega naught t. Sine 3 omega naught t. So it will have 3 cycles. 3 cycles like this. Right? Because here what is the time period? Time period is 2 by 3 second. That means in 2 seconds it will have 3 cycles. In 2 seconds it will have 3 cycles. Now xt is being multiplied. Basically this part will be multiplied with a. So this will remain as it is, but this part will become negative. This part will become negative. So whatever this part was there, that means negative cycle, positive cycle, negative cycle. So it became positive cycle, negative cycle, positive cycle. Say yes or no? Let's calculate the area now. Negative area, positive area, positive area, negative area. So all these will cancel out. This area, this area, this area, this area will cancel out. But these two lobes will remain there as it is. This area plus this area. They will be non-zero. Basically, what I mean to say is that here how many positive area are there? 1, 2, 3, 4. And how many negative area are there? 1 and 2. So 4 positive area and 2 negative area. That means 2 positive area are remaining there as it is. That means the answer will be non-zero. That means sine 3 omega naught t will be present. If you do it with sine 4 omega naught t, you will get to know that answer is 0. You do it with sine 5 omega naught t, it will be non-zero. You do it with sine 7 omega naught t, it will be non-zero. You do it with sine 9 omega naught t, it will be non-zero. In that manner you proceed and you will get to know that I am having these sinusoids. And you do it with any cosinusoid. What I am saying, you do it with any cosinusoid, always the answer will be 0. What I mean to say is that in place of sine omega naught t, now my alpha t is cos omega naught t. What is my alpha t? Cos omega naught t. That means my alpha t is now cos pi t. What is the time period? 2 seconds. Can I make cos pi t? This will be my cos pi t, right? Cos pi t is being multiplied with xt. So this part will be multiplied with a only, but this part will be multiplied with minus a. That means it will be inverted. It will be inverted. So negative part will become positive part and positive part will become negative part. So this is the waveform of xt dot. This is the waveform of xt dot cos pi t. Xt dot cos omega naught t. This is the waveform of xt dot cos omega naught t. What is the area? Positive area, negative area, positive area, negative area. Total area is 0. So what is the answer coming out to be? 0. You do it with cos 2 pi t, you do it with cos 3 pi t, you do it with cos 4 pi t, you do it with cos 5 pi t. Always the answer will come out to be 0. Did you understand the actual meaning of Fourier series now? You would have understood, you would have studied this particular topic from anyone, like you would have seen any number of videos from any educator, but did you get this clarity? Now are you having the clarity of a Fourier series? That what is the meaning of Fourier series? We saw it with the square waveform, then we saw it with the random waveform. In the square waveform, we concluded that we are only having sine omega naught t, 3 omega naught t, 5 omega naught t, only the sinusoids of these signal. When we applied cosinusoid, always it is throwing 0. That means it is never having any cosinusoid present in the signal. And how we did it? We made a setup. We made a setup like this. Although when I started giving the meaning of Fourier series, I did not show you this setup, because if I have started from here, you would not have understood anything. First we started from here. We got to know that by experiment only we got to know that it is having sinusoid 3 sine omega naught t, sine 3 omega naught t, sine 5 omega naught t. That means these b2 value, b4 value, a1 value, a2 value, a3 value, all these were 0. Now you are curious that how this came into action. So for that I gave you this particular question, that you go in the lab, you multiply xt with the random sinusoid and cosinusoid, and then you integrate over a time period. What you are getting? Whenever you are getting non-zero, that means that particular signal is present. So that particular alpha t is present. We got to know that sine 3 pi t and cos 5 pi t are throwing non-zero. That means sine 3 pi t and cos 5 pi t are present. I don't care about the amplitude as of now. Along with that, it can have a DC value as well. So then we applied a DC checker. And DC value checker, when we applied, we got to know that yeah, it is having a DC value of 2. So this is what I got to know. And then we came back to our first question again, this question, and now we are doing the same thing that we did in the question 2 with this particular question, that I will multiply my signal xt with this is my signal xt. Xt will be multiplied with sine omega naught t, sine 2 omega naught t, sine 3 omega naught t, sine 5 omega naught t in that manner, and then I will integrate over a time period. Whenever it is throwing me non-zero, that means that particular signal is present. So I multiply with sine omega naught t. When I multiply with sine omega naught t, I got to know that negative area was becoming positive area. So positive, my area was non-zero. Then I applied sine 2 omega naught t. What I got to know that it will have 2 cycles. So positive negative area, that was throwing non-zero, and then positive negative area, again it was throwing 0. So that means sine 2 omega naught t was not there. Then sine 3 omega naught t was there. Sine 4 omega naught t was not there. In that manner we checked. Then we checked for cos omega naught t. So then we got to know that cos omega naught t is also throwing 0. Cos 2 omega naught t will also throw 0. Cos 3 omega naught t will also throw 0 only. That means yes, that it was only having sine omega naught, sine 3 omega naught, sine 5 omega naught, sine 7 omega naught, and sine 9 omega naught. So this is the conclusion that we have made. So this is the basics of Fourier series that we have shown here. Okay. So let me erase all these parts which are not necessary, so that you get a clear notes. But this was just to let you know the meaning of Fourier series, because when we start Fourier series, it always starts with a lot of formula, and the student often lose the interest. Now you are surely having interest in Fourier series. You are surely curious to know more things about Fourier series. Say yes or no. So your interest has built up now, and now the job for me will be easy, because you are having the interest now, and if you are having the interest, then I can make you understand the subject in a very good manner. So now the interest has been built up. Now let's write down the conclusions. So this is the conclusion that we have made, that our xt will be having a DC and sinusoids and cosinusoid. What is this? This is a DC, and it will have some cosinusoids and sinusoid. Cosinusoid and sinusoid. Cosinusoid and sinusoid of n omega naught frequency. That means they can have frequency of omega naught, 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught with respect to sinusoid and cosinusoid, and they will have a particular amplitude. They will have a particular amplitude. So now I am interested in the amplitude. What will be the value of an and bn? Till now we have seen everything, but we are interested in an and bn value. So for that, what I did, I need to find an and bn value. So what I did, on both of the side, I multiply with sine n omega naught t. Okay. On both of the side, I multiply with sine n omega naught t. C naught into sine n omega naught t. Along with the multiplication, what I was doing, I was taking the area for one time period as well. Basically, this xt was having some t naught and omega naught, right? So what I did, I multiply my xt with sine n omega naught t, and then I am calculating the area for one time period. Same thing I am doing this side as well. C naught sin n omega naught t dot dt plus n goes from 1 to infinity integration an cos n omega naught t sin n omega naught t dot dt plus t naught summation n goes from 1 to infinity bn sin n omega naught t dot sin n omega naught t dt. So this is the process we are doing. Now you put any value of n. You put n equals to 1, you put n equals to 2, you put n equals to 3, you put any value of n, any random value of n, always this integration will be 0 only. Why is that so? Let's put n equals to 1. C naught sin omega naught t dt. You are integrating a sinusoid for one time period. Answer will be 0. Integrating a sinusoid for one time period, again answer will be 0. 3, 4, this answer will be 0 only. Say yes or no? This will throw 0. Here you need to put n equals to 1 to infinity. No matter whatever the value of n you put, always sinusoid and cosinusoid will be orthogonal to each other. Just the reverse process I am doing. I am just doing the reverse process of this particular setup, nothing else. So when I multiply with sin n omega naught t, when I multiply my xt with sin n omega naught t, I can certainly know that my cosinusoid component will always throw 0 and my dc component will also throw 0. xt is multiplied with any sinusoid. In this particular setup, what we did? First we applied sin pi t, then sin 2 pi t, then sin 3 pi t. This is the same process we are doing here. We are applying sin omega naught t, sin 2 omega naught t, sin 3 omega naught t. In that manner we will apply one by one. So when I apply sin omega naught t, or I apply sin 2 omega naught t, or I apply sin 3 omega naught t, always this will throw 0 only. Why is that so? Because they are orthogonal to each other. Cos n omega naught t will always be orthogonal to sin n omega naught t, no matter what. So this will throw 0. But what about this one? This will not throw 0. So let's open it up. First put n equals to 1. So if I put n equals to 1 here also I need to put n equals to 1. What I mean to say is that, let's go to the next page. What I am doing, I am putting n equals to 1, 2 in that manner. So can I write down in this manner? Sin omega naught t, n equals to 1 I am putting. But at this particular side, I will put n equals to 1, n equals to 2, n equals to 3, because summation goes from n equals to 1 to 2, 1, 2, 3 in that manner. So here what I am putting, b1 sin omega naught t plus, here what I am putting, against n equals to 1, sin omega naught t dt integrated over a time period, plus b2, then I will put 2 sin 2 omega naught t sin 2 omega naught t dt integrated over a time period. Then what I will put, n equals to 3, in that manner till infinity I will put. Okay, so just one more I am going to put, integrating over a time period, b3 sin 3 omega naught t sin 3 omega naught t dt. Then till infinity I will put. So what result it will give you? Sin square omega naught t, b1 is a constant value, b1 is a constant value, b2 is a constant value, b3 is a constant value. Sin square omega naught t dt integrating over a time period. What will be the answer? T naught by 2, right? What result it is giving you? b1 into T naught by 2 plus b2 into T naught by 2 plus b3 into T naught by 2. In that manner, everything will give you T naught by 2 only, because this is your sin square 2 omega naught t dot dt integrated over a time period. What result it will give you? T naught by 2. This we have proved, because sinusoid will be gone into 4 cos omega naught t dt divided by 2. Then this will throw 0, but this will throw T naught by 2. Same goes here, same goes till the next point as well. So all these will throw T naught by 2, T naught by 2 and T naught by 2. Say yes or no? Similarly, here also, first I picked sin n omega naught t. So here sin n omega naught t can be replaced with sin omega naught t, sin 2 omega naught t, sin 3 omega naught t, because you are integrating, no? You are integrating. So with respect to n equals to 1 you will integrate, with respect to n equals to 2 you will integrate, with respect to n equals to 3 you will integrate. When you are putting n equals to 1, then only you need to compare this and this. When you put n equals to 2, so what you will compare? Xt sine 2 omega naught t. So when I put n equals to 2, this will be compared with this. And when I put n equals to 3, then this will be compared with this. Say yes or no? Are you getting this point? Here there was a summation. But here n values I need to put. If I put n equals to 1, n equals to 2, n equals to 3. So this was with respect to n equals to 1. This was with respect to n equals to 1. So these two can be compared. This was with n equals to 2. This was with n equals to 2. So these two can be compared. And then these two can be compared. What I am interested in? I am interested in finding the value of Bn. That means I am interested in finding the value of B1, B2 and B3. So can I compare? B1 T naught by 2 is equivalent to Xt sine omega naught t. From here, what is the value of B1 we are getting? 2 by T naught integrated over a time period. Xt dot sine omega naught t. Here dt was also there. Sorry, here dt is also there. So 2 by T naught Xt sine omega naught t dt. This is the value of B1 you are getting. Okay, B1 already written. So this is the value of B1 you are getting. Can I do the same with B2 as well? Or let's do it with B3, okay? Let's do it with B3. So B3 T naught by 2 is equivalent to what? Xt sine 3 omega naught t dot dt. So what is the value of B3 from here? B3 is equals to 2 by T naught into Xt dot sine 3 omega naught t dot dt. So this is the value of B3 you are getting. So in B1 and B3, what you can see? The 2 by T naught same, integrated over time period same, Xt is same, sine omega naught t, sine 3 omega naught t dt, all are same, omega naught t, 3 omega naught t. What is the difference? Omega naught t and 3 omega naught t. So B1 is having a frequency of omega naught, B3 is having a frequency of 3 omega naught. That means Bn will have a frequency of n omega naught. So from here, I need to add a page. So what will be my expression of Bn? That would be 2 by T naught integrated over a time period Xt sine n omega naught t dt. So this is the expression of Bn. In the same manner, your expression of An will come out to be 2 by T naught integrated over a time period. In place of sine n omega naught t, what will be there? Cos n omega naught t. So these are the expressions of An and Bn. Okay. So till this particular point, we were not interested in B3 and A5 value. Okay. We just got to know that our Xt is a combination of DC and orthogonal sinusoid and cosinusoid of frequency n omega naught. Then someone said that now I am interested in An and Bn value. For that, what I did, I multiply sine n omega naught t. Basically, the reverse process I am doing. I multiply sine n omega naught t with Xt and then I integrate it over a time period. What is the time period? Time period is the time period of Xt. Okay. Then I got to know that when I compare these values, I got to know that my B1 is coming out to be 2 by T naught Xt sine omega naught t dt and my B3 is coming out to be 2 by T naught Xt sine 3 omega naught t dt. That means if I am calculating Bn, then the frequency of sinusoid I need to put as n omega naught t. So will you be able to remember it? Okay. In A, always C will come. With A, always C comes. So you need to remember the word AC. AC current, DC current, right? So AC, if I am writing An, cosinusoid will come. If I am writing An, cosinusoid will come. With A, always C comes. And with B, S comes. BS, Bachelor of Science. BS, Bachelor of Science. AC, alternating current. So with A, always C come. Alternating current or Bachelor of Science. With B, always S will come. With A, always C will come. If you write down Xt in this manner, or you write down the expression of An and Bn. So with A, always C will come. And with B, always S will come. So by any trick you need to remember it. Say yes or no. All clear to you? an and bn expression clear? So this you need to keep in mind. And people always get confused, sir, 1 by t naught, 2 by t naught. So always remember here 2 by t naught will come. Why is that so? Because we have done the derivation, and in the derivation we know that this will be reduced to t naught by 2. And then when t naught by 2 goes to this side, it will become 2 by t naught. So people always get confused, 1 by 2 t naught, someone will write 1 by 2 t naught, someone will write 1 by t naught. Like in longer run, let's just say you don't revise signal system for 2 months, then you come back, then you write down the expression of an. Then you will know that, okay, AC cos n omega naught t dt. But here what do I write, sir? Sir, 1 by 2 t naught. Or sir, 1 by t naught. No. What you remember, in the derivation we know that it will be reduced to t naught by 2. So if it goes here, it will become 2 by t naught. So 2 by t naught. Just a way to remember I am telling, okay? Because we need to remember the things as well. Usually your Fourier series will start from these formula. They don't even tell you from where the formula came from, where the concept will come. They directly will start from here. And that will kill the motivation to study Fourier series. But we need the motivation, we need the interest. Now you are having the motivation and interest, both of the things. So A and B and formula, can you write down in a very good manner? Surely you can write down. And you will be able to remember as well. So these are the formula of A and B. Let's see one more interesting thing. What will be A of minus n? If I need to put A of minus n, so what that would be? 2 by t naught. I need to integrate over a time period xt. In place of n, what I need to put? Minus n. In place of n, I need to put minus n. Cos has the ability of eating up the negative sign. So cos has the ability of eating up the negative sign. T naught xt cos n omega naught t dt. And what this is equivalent to? This is equivalent to an only. So A of minus n is equivalent to an. And what do you think? You should be able to tell on your own. What do you think B of minus n would be equals to? B of minus n. Here you will put minus n. What is the ability of sine? Sine will take out the negative sign. Sine of minus theta. Sine of minus theta. What does sine do? Sine will take out the negative sign. That will be equals to minus sine theta. So it will take out the negative sign. So here negative sign will come. So B of minus n will be equals to minus of Bn. Say yes or no. Will you be able to remember these two things? A of minus n is equals to an and B of minus n is equals to minus of Bn. Is that okay for you? Should we write down the conclusion? Let's write down the conclusion of everything. What we got to know that our xt is a combination of DC and sinusoid and cosinusoid, orthogonal sinusoid and cosinusoid of frequency n omega naught. The n omega naught can vary from omega naught, 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught, in that manner till infinity. Where time period of xt is t naught. This xt is having a time period of t naught and fundamental frequency of omega naught. How do we calculate fundamental frequency? That is equals to 2 pi by t naught. All these things we have already seen. A of minus n is equals to an and B of minus n is equals to minus Bn. Formula of an is 2 by t naught xt dot a with c. Xt is multiplied with cosinusoid of n omega naught frequency dot dt. I need to calculate the area for one time period and then multiply it with 2 by t naught, not 1 by 2 t naught or anything like that. 2 by t naught. Why is that so? How will you remember? Because the integration will give t naught by 2 result, and the t naught by 2 will go to this side, it will become 2 by t naught. So an is 2 by t naught integrated over a time period xt cos n omega naught t. Bn is 2 by t naught integrated over a time period xt sin n omega naught t. With a c will come, with b s will come. And what is the dc value? This is the dc value. How do you calculate the dc value? You already know the formula of dc, or you call it average. So formula of dc or average is integrated over a time period divided by the time period. Integrated over time period divided by the time period. So this is the conclusion of trigonometric, what this is known as trigonometric Fourier series. What this is known as trigonometric Fourier series. Trigonometric Fourier series. Trigonometric Fourier series. So this is the conclusion of trigonometric Fourier series. And this is also very, very important. This will also be used somewhere. Okay. Let's see one more thing. If xt is real, then this is also real. Xt is real. All these will be real. and this is also real, that means an will also be real. And if xt is real, so this is real, this is real, this is also real, then bn will also be real. So real multiply with real and then integrated multiply with again real will be real only. So if xt is real, then an will be real and bn will also be real. Now if xt is imaginary, let's just say xt is minus j3t, this is your xt. Although this is not periodic, I am just telling that it is imaginary, or this waveform that we have shown here, in place of the magnitude is plus j and minus j. If this is the magnitude, that means this is imaginary. So imaginary multiply with real, what that would be? Imaginary only. Let's just say imaginary number j1 is multiplied with real number, what will be the answer? j3. So imaginary multiply with real will be imaginary, and then again multiply with real, again whole value will be imaginary only. Are you getting this point? What I mean to say is that if this is imaginary, multiply with real will be imaginary, and then again multiply with real, whole value will be imaginary only. Same goes for this one. That means if your xt is imaginary, then an will be imaginary and bn will also be imaginary. If xt is complex, so real part will go to real and imaginary part will go to imaginary part. xt is complex, that let's just say it was having an amplitude of 2 plus 3j, 2 minus 3j. So real part 2 will be multiplied with cosine omega naught t, this will throw real. 3j multiplied with cosine omega naught t, this will throw imaginary. So real plus imaginary, what that would be? Complex only. You don't need to mug up all these things, okay? Somewhere if it is used, then you should have the ability of using it, that's it. Okay, so this is the conclusion, right? Very simple thing. So in this slide we have seen all the conclusion till now, whatever that we have studied, this is the conclusion of every discussion that we have done till now. So this 66 minutes of the time will be revised within 60 seconds. Okay, when you come back, you will just see, okay, these are the examples, then this is how we derived, and to this slide you will come, to the 15th slide you will come, and you will see here, okay, this is the conclusion, this is how xt can be represented. Xt is dc and sinusoid and cosinusoid of frequency is n omega naught, where n goes from 1 to infinity, where a of minus n is equals to an and b of minus 1 is equals to minus bn. dc value I know how to write down, and then I wrote down the expression of an and bn as well. An is 2 by t naught xt cos n omega naught t dt, and bn is 2 by t naught xt sin n omega naught t dt. Time period of xt is t naught and omega naught is 2 pi by t naught. So this is the complete conclusion. And then if xt is real imaginary complex, so these are your an bn values. Now what if xt is even, what is xt is odd, what is it is neither even neither odd, so what will be the nature of an bn? So that also we will see. As of now we are just seeing real, imaginary and complex. What if xt is real? Sorry, what if xt is even? So if xt is even, what will be the nature of an bn? If xt is odd, then what will be the nature of an bn? If xt is neither even nor odd, what will be the nature of an bn? So all these things we are going to see. So for that you need to have the patience. In the upcoming lectures we are going to see it. Okay. Now next we need to study about exponential Fourier series. What we need to study? Exponential. So we converted this into sinusoid and cosinusoid. We can convert it into exponentials as well. So that we need to study. Okay, so that we will study after a break. But can you break it down? Xt can be broken down into dc plus a1 cos omega naught t plus a2. Just I am putting the values of n. a1 cos omega naught t, a2 cos omega naught t, a3 cos omega naught t. This is very simple. And then same goes for sinusoid as well. b1 sin omega naught t, b2 sin omega naught t, b3 sin omega naught t. b3 sin 3 omega naught t, b4 sin 4 omega naught t, b5 sin 5 omega naught t. In that manner it can be broken. So a general expression we are taking. Now we need to go to exponential Fourier series. Okay, exponential Fourier series we need to understand. From sinusoid to cosinusoid we can write down exponentials as well. So that we will see after a break. So I will take a pause, you can also take a pause. Okay, so after a break I will come back. Yeah, so let's start the exponential Fourier series now, right? So this we have seen, our xt can be broken into such sinusoids and cosinusoids of a different frequency, omega naught, 2 omega naught, 3 omega naught, 4 omega naught, right? What we have studied, have we studied something like this? E to the power theta is equals to, e to the power j theta is equals to cos theta plus j sin theta, and e to the power minus j theta would be equals to cos theta minus j sin theta. From there, what will be the value of cos theta? Cos theta would be a to the power j theta plus a to the power minus j theta divided by 2. And what would be sin theta? A to the power j theta minus a to the power minus j theta divided by 2j. So this we have already studied, right? All these things we already know. In basics of signal, these things we have already seen, right? You just subtract these two and then you will get 2j sin theta, and from there sin theta will be e to the power j theta minus e to the power minus j theta divided by 2j. So same thing I need to do here. What I am going to do is that I need the exponentials, right? So that's why our cos omega naught t can be replaced with e to the power j omega naught t plus e to the power minus j omega naught t divided by 2. Similarly, here a2 e to the power j2 omega naught t plus e to the power minus j2 omega naught t divided by 2. In that manner, for a3 as well, we will do the same thing. Here b1 e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j plus b2 e to the power j2 omega naught t minus e to the power minus j2 omega naught t divided by 2j and so on. So e to the power j omega naught t, it is having a factor of a1 by 2 plus b1 by 2j. What I am doing is that, what I am writing, c naught plus e to the power j omega naught t can be written a1 by 2 plus b1 by 2j. So a1 by 2 plus b1 by 2j e to the power j omega naught t plus, what about e to the power minus j omega naught t, that is a1 by 2 minus b1 by 2j, a1 by 2 minus b1 by 2j is equals to e to the power minus j omega naught t plus, what is e to the power 2j omega naught t, e to the power 2j omega naught t, a2 by 2 plus b2 by 2j, a2 by 2 plus b2 by 2j is equals to e to the power 2j omega naught t. Similarly, a2 by 2 minus b2 by 2j, what I am talking about, e to the power minus 2j omega naught t. So a2 by 2 minus b2 by 2j minus b2 by 2j is equals to a to the power minus 2j omega naught t and so on, right? So now minus minus value I am taking this side, okay, minus minus I am taking this side, all the minus are there. Basically e to the power minus j omega naught t, e to the power minus 2j omega naught t, so these I am writing here. So e to the power minus 2j omega naught t can be written as a1 plus, sorry, not a1, a2 plus jb2 by 2 e to the power minus 2j omega naught t. Did you understand this point? What is this? a2 by 2 minus b2 by 2j. So j can go upward. 1 by j is equals to minus j. 1 by j is equals to minus j. So this j goes upward. This j goes upward. So what it will become? Plus j. So a2 plus jb2 divided by 2. Right? Similarly, a1 plus jb1 here. a1 plus jb1 divided by 2 is equals to e to the power minus j omega naught t plus then the constant value. Then what about e to the power minus j omega naught t? So this j goes upward, it will become minus j. So a1 minus jb1 divided by 2 e to the power j omega naught t plus a2 minus jb2 divided by 2 e to the power 2j omega naught t, and the same manner it will keep on going. Okay. Now what I am doing, I am putting my c1 equals to a1 minus jb1 by 2. What is my c1? a1 minus jb1 by 2. This is my c1. So similarly, what will be your c2? c2 would be a2 minus jb2 by 2. Say yes or no? So this value will be c1, this value will be c2. What will be your c of minus 1? C1 is A1 minus JB1 by 2. So C of minus 1. In place of 1, you need to put minus 1. So A of minus 1 minus J of B of minus 1 divided by 2. One thing I know that A of minus n is equals to A of minus n is equals to An and B of minus n is equals to minus Bn. Say yes or no. So what will be this A of minus 1 equals to? A1. B of minus 1 will be equals to minus B1. So minus minus it will be plus divided by 2. So what your C of minus 1 came out to be? C of minus 1 is coming out to be A1 plus JB1 by 2. So what will be your C of minus 2? C of minus 2 will come out to be A2 plus JB2 by 2. So from here what did you understand? I have to add a page. That your Cn is An minus JBn by 2 and C of minus n is An plus JBn by 2. Did you understand these 2 points? Did you understand these 2 points? Surely you understood. Here I was getting this expression. Simple mathematics we are doing, nothing else, nothing complex is there, right? What we are doing, we just replaced our cos omega naught t, sin omega naught t with exponentials. From there we got the common values. E to the power j omega naught t is having this factor, e to the power minus j omega naught t is having this factor, e to the power 2 j omega naught t is having this factor. Now what did I see? I represented in this manner. Then I see that what if I replace a1 minus jb1 by 2 as c1? Then c2 will be a2 minus jb2 by 2. What would be c of minus 1? C of minus 1 would be in place of 1 you need to replace minus 1. So a of minus 1 minus j b of minus 1. So that is coming out to be a of minus 1 will be equals to a1, b of minus 1 will be equals to minus of b1. So this is coming out to be a1 plus jb1 by 2. So c of minus 1 is coming out to be a1 plus jb1 by 2 and c of minus 2 is coming out to be a2 plus jb2 by 2. That means cn is an minus jbn by 2. Cn is an minus jn by 2 and c of minus n is c of minus n. C of minus n is an plus jbn by 2. C of minus n is an plus jbn by 2. Or you can replace, if this is your cn, then what will be your c of minus n? C of minus n will be a of minus n minus j of b of minus n divided by 2. A of minus n is equals to an. B of minus n is equals to minus bn divided by 2. So yeah, we are getting the same thing. So in that manner we have got the value of cn and c of minus n. Now how I can replace my this xt signal? So all these are coming equals to xt only. Plus what this would be? C of minus 2. C of minus 2 e to the power minus j 2 omega naught t plus C of minus 1 e to the power minus j omega naught t plus 0 plus C1, this would be C of 1, C1 e to the power j omega naught t e to the power j omega naught t plus C2 e to the power minus j, sorry, C2 e to the power plus j only, C2 e to the power plus j omega naught t. Here you can see this is C2 e to the power 2 j omega naught t is there. So this is how I can represent and then it will go till infinity. So what do you see here? Can I represent my xt like this? Cn e to the power j n omega naught t, where n goes from minus infinity to infinity. So this is how can I represent my xt. Yes, this is my xt. N will go from minus infinity to infinity. Here we are starting from minus 2. Minus 3 would also be there. Minus 4 will also be there. So how it will be open? C of minus 3 e to the power j minus 3 omega naught t. C of minus 2 e to the power minus j 2 omega naught t. In place of n, what I need to put? Minus n. Then in place of n, what you need to put? Minus 1. So C of minus 1 e to the power minus j omega naught t. Then in place of n, you need to put 0. If you put 0, what will happen? C0 e to the power j 0. E to the power j0 is 1 only. So what you will get? C0. Plus then you put n equals to 1. So C1 e to the power j omega naught t. Then you put n equals to 2. C2 e to the power j 2 omega naught t. Then you put n equals to 3. C3 e to the power j 3 omega naught t. So yes, this is how I can represent my xt. Previously I was representing my xt as a DC value plus n goes from 1 to infinity. What I will represent? Cosinusoid first. So an cos n omega naught t plus n goes from 1 to infinity bn sine n omega naught t. But now sinusoid and cosinusoid have been replaced with exponential, complex exponential, and the complex exponential is Cn, and if I need to represent my xt in complex exponential, then I will represent in terms of Cn e to the power j n omega naught t, where n is going from minus infinity to infinity. A very important point. N is going from minus infinity to infinity. So here I am putting the star mark. Minus infinity to infinity, and here it is going from 1 to infinity. Okay, a very, very important point. Right? So here when we found out an and bn value, so an was coming out to be 2 by t naught. Then I have to integrate over a time period, multiplying your xt with cosinusoids. Okay. In the similar manner, 2 by t naught, multiplying your xt with sinusoid. Okay. What you know, Cn is an minus jbn by 2. So if you do this particular thing, an minus jbn by 2, then your Cn will come out to be 1 by t naught xt e to the power minus j n omega naught t dt. Okay. So this is how your Cn would come out. If you do an minus jn, an expression you are having, bn expression you are having, j is a imaginary value, 2 is also a real value. So an minus jbn by 2, whenever you do it using these expression, you will get this particular final answer integrated over a time period t naught. So Cn will come out to be xt multiplied with e to the power minus j n omega naught t dt integrated over a time period and then divided by the time period. So this is what will come out to be. So this is the expression of Cn. This should be there in your mind. This is the expression of Cn. These were the expression of An and Bn. How will you remember? You will remember xt is represented as this. Okay, I'm removing this star mark because someone will think that it is conjugate, because we represent conjugate by star as well, no? So that's why I'm removing the star mark. Okay, so just these expressions are there. So you will represent xt as n goes from minus infinity to infinity summation Cn e to the power j n omega naught t. Now you need to remember the expression of Cn. So kind of what you will say, that this is coming this side, e to the power j n omega naught t, this is coming this side. So xt e to the power j minus n omega naught t dt, then integrated over time period and then divide by time period as well. And if you put n equals to 0 here, if you put n equals to 0, what you will get? xt dot dt integrated over time period divided by time period. Is that the expression of C naught? Yes. This is the expression of C naught. What is the expression of C naught? 1 by t naught xt dot dt. So what you will do, put n equals to 0 here. If you put n equals to 0 here, divided by the time period and integrated over a time period, you will get C naught value. That is dc. This is the dc value. Integrated over time period divided by the time period, which is equals to C naught. Say yes or no. So all these formula are there, but I am telling you tricks to remember. I am telling you the complete derivation as well, so that you don't feel like that there are a lot of formula, but you need to remember it anyway, right? So what is the conclusion now? The conclusion is this will be your exponential Fourier series. The conclusion is xt can be represented from n goes from minus infinity to infinity in terms of a complex exponential, where n is going from minus infinity to infinity, and all the complex exponential are having a particular amplitude, and that amplitude is c of n. How will you calculate c of n? So 1 by t naught. In the expression of an and bn, 2 by t naught comes, but you know that c of n is an minus j bn by 2. C of n is an minus j bn by 2. So by 2 is there, no? That means this will also be divided. This will also be gone. So in that manner you can remember that 1 by t naught will come, then xt, and you will think that this will go, this goes here. So e to the power minus j n omega naught t dt. Certainly you will integrate for one time period. So this is the expression of Cn. Then you will remember another thing, that is Cn is equals to an minus j bn by 2, right? An minus j bn by 2. And what will be your C of minus n? C of minus n is an plus j bn by 2. Okay. From here you can calculate the C naught and C1, C2, C3 values. Any value you want to calculate, C1, C2, C3, any value you want to calculate, that you can calculate from here. Say yes or no. This is the whole conclusion of everything that we have studied till now. So we started with exponential Fourier series till this point. Sorry, we started with trigonometric Fourier series. Till this point, everything is clear. An value is clear, Bn value is clear, A of minus n is equals to An, B of minus n is equals to minus of Bn, C naught value, how to calculate the DC value, how to calculate An, Bn value, that is also clear. 2 by T naught, then you need to integrate over a time period. What you will integrate? Xt will be multiplied with sinusoids of different frequency, and for An, Xt will be multiplied with cosinusoids of different frequency, A, C, B, S. This is what you need to remember. And xt can be represented in DC value plus a sinusoid and cosinusoids of different frequencies, omega naught, 2 omega naught, 3 omega naught, in that manner. Here there is no concept of n equals to negative value. Here only n equals to positive values are there. But when we convert it into exponentials, then we got to know that, yeah, here the negative values will also come into action. So xt is represented as Cn e to the power j n omega naught t, where the summation is going from minus infinity to plus infinity, where Cn value is 1 by T naught xt e to the power minus j n omega naught T dot dt. Okay, so this will be your Cn. Xt is also there, An, Bn value also we have seen. Okay, so this is the conclusion of exponential Fourier series. That is, your xt is written as Cn e to the power j n omega naught t, n goes from minus infinity to infinity, where xt is 1 by T naught, where Cn is 1 by T naught and integrated over a time period, xt dot e to the power minus j n omega naught t dt, where Cn expression is An minus jbn by 2 and C of minus n expression is An plus jbn by 2. So that's it. This is the end of everything that we have studied till now. This is the conclusion of everything that we have studied till now. Rest of the things we are going to see in the next lecture. In the next lecture, we are going to do a basic revision of basics of signal. Basics of signal we have already seen. If xt is real, xt is imaginary, xt is conjugate symmetry, xt is conjugate anti-symmetry, what will happen? And then we will talk about C of n. Okay, so let's meet in the next lecture. This was the fundamental introduction to Fourier series and introduction to exponential Fourier series. Now all the things whatever that we study will be based on these formula only. Okay, everything will be based on these formula only. Nothing different will be there. Well and good. So let's meet in the next lecture. I hope you enjoyed it. Thank you very much. Yeah, welcome back. So what we were studying about Fourier series. In the first lecture, we saw the complete introduction to the Fourier series, and this was the conclusion. We have seen the exponential Fourier series and we have seen the trigonometric Fourier series as well. And both of the conclusion we already know. This is how I will represent my trigonometric Fourier series. From there, I got the exponential Fourier series. I know the expression of An, Bn and Cn, everything, right? An, Bn and Cn, all these things I already know. And from here, I know one more thing. Cn is equals to An minus jbn by 2. C of minus n is equals to An plus jbn by 2. From here, I can make one more conclusion. What is that? Look, if I add Cn and C of minus n, basically if I do Cn plus C of minus n, what I will get? If I add both of them. So An by 2 minus jbn by 2 plus An by 2 plus jbn by 2. So plus jbn by 2 and minus jbn by 2 will get cancelled out. An by 2 plus An by 2 will be An. Say yes or no. So what you are getting? Cn plus C of minus n is equals to An. So whenever you need to find An, this is the process you will do. Let's just say I am having the value of Cn. I need to find the value of An. So what I will do? If I have the value of Cn, then can I calculate C of minus n? Yes. In place of n, you need to replace minus n. And just add them, you will get An. If you have the value of Cn, then I need to calculate An. So what I will do? In place of n, I will put minus n. Then Cn plus C of minus n will be equals to An, right? And what about Bn? If you have the value of Cn, can you find out the value of Bn? Let's check it. So what I will do? C of minus n minus Cn. What I will get? C of minus n minus Cn. So what I will get? Jbn by 2 plus An by 2 minus An by 2 plus Jbn by 2. So what I am getting? This is getting cancelled out. So I am getting Jbn. So C of minus n minus Cn is equals to Jbn by 2. Sorry, not Jbn by 2, Jbn is equals to Jbn, right? So this is the other equation. Do we need to mug them up? No, we don't need to mug up these expression. You can just derive it in the examination. You would only remember this particular thing, that Cn is An minus Jbn by 2. Then from there, can I calculate C of minus n? Yes, An plus Jbn by 2, because A of minus n is equals to An, B of minus n is equals to minus Bn. So An plus Jbn by 2 and Cn is An minus Jbn by 2. Then if you add them up, you get An. If you subtract this from this, then you get JBN. So from here you can calculate the value of BN as well. So let's not keep this in box. What I'm gonna do is that, BN is equals to C of minus n divided by J. If J goes upward, what it becomes? Minus J. If 1 by J is equals to minus J. So what I can write? Bn is equals to J into C of n minus C of minus n. So this is what I will remember. This is your Bn, and what will be your An? An is Cn plus C of minus n. I hope this will be easy for you to remember. So Bn and An expression are these. An is Cn plus C of minus n, and Bn is J Cn minus C of minus n. Right? Although if you don't remember it, then also it is fine. You can derive it any day in the examination hall. Let's see some question. You need to find exponential Fourier series. So xt is given. 4 questions are there basically. Question A, B, C, D. So 4 questions are there. For different question, I need to find the exponential Fourier series. Right? What people will think? If you think blindly, you will say that, sir, I will apply this formula. 1 by t naught integrated with t naught xt dot e to the power minus j n omega naught t dt. So this is the formula of Cn. I can find out from here. Or what someone will say that, sir, I will find out the value of An and Bn, and from there I can find Cn. This you can tell, right? What someone will say that is that, sir, I will find the value of An using this formula. Xt with A always C would come. And then, sir, I will find the value of Bn as well using this formula, and then I will find my Cn, right? But all these formula you will never apply if sinusoid and cosinusoids are given. Okay, you will never apply these formula when sinusoids and cosinusoids are given. If directly I can see the function that it is sinusoid or cosinusoid, but let's just say in the examination hall, let's just say this kind of waveform is given, this kind of waveform is given. So there you will apply the formula. This kind of waveform or this kind of waveform is given. So there you will apply the formula. But if I am given the expression, let's just say in the examination hall, this expression was given. So I will never apply the formula, because I can analyze this expression using my fundamental concept as well. Are you able to understand this point? Let's just say if I am given this particular waveform, then I don't know what kind of sinusoids and cosinusoids are there. I don't know what kind of sinusoids and cosinusoids are there inside this. But if I am given this particular expression, then if I need to find exponential Fourier series, or if I need to find An or Bn, or if I need to find trigonometric Fourier series, then I will be able to find it very easily by doing the basic analysis. Here, what will be the value of B3? What do you think? What will be the value of B3? B3 is 4, directly I can tell. And what will be the value of A5? A5 is 3, rest all things will be 0. And what is the DC value here? DC value, C0, that is 2, that's it. Analysis I can do very easily, no? How did I call it A5? Because I know that my xt can be written as DC value plus A1 cos omega naught t plus A2 cos 2 omega naught t plus A3 cos 3 omega naught t plus A4 cos 4 omega naught t plus A5 cos 5 omega naught t. So what is this? 5 omega naught t. So I can tell the value of A5. I can tell the value of B3 as well. I can tell the value of C0 as well. In that manner I can tell all these values. So why do I need to do the analysis here? I don't need to apply any formula. So if a particular waveform is given, then only you will apply the formula. Okay, what I am saying, these formula you will apply only when waveform is given. Apply these formula only when xt waveform is given. Okay, fine. So here I am not going to apply this formula. I am going to solve it with the basic concept. So xt is equals to sin t. So whenever I need to find Fourier series coefficient or trigonometric, like whenever I need to find exponential or trigonometric Fourier series coefficient, our first task will always be to find the value of omega naught. So here what is my fundamental frequency? Fundamental angular frequency, that is 1. Now I will write down my signal in this manner, sin omega naught t. Is that clear to you? Because omega naught value is 1 only, no? So I can write down sin omega naught t. So my xt is sin omega naught t. First I find out the value of omega naught. Omega naught came out to be 1. So now I can write down my expression as sine omega naught t. What will be your sine omega naught t? E to the power j omega naught t minus e to the power minus j omega naught t divided by 2j. Say yes or no, right? So let's add a page. So your xt is coming out to be e to the power j omega naught t divided by 2j minus e to the power minus j omega naught t divided by 2j. This is your xt. What xt can be written as? Xt can be written as c of minus 2 e to the power minus 2j omega naught t plus c of minus 1 e to the power minus j omega naught t plus a dc value plus c1 e to the power j omega naught t plus c2 e to the power 2j omega naught t, in that manner till infinity. If you compare these expressions, what do you get to know? E to the power minus j omega naught t, e to the power minus j omega naught t, e to the power minus j omega naught t. That means this is written as c of minus 1. C of minus 1 is coming out to be minus 1 by 2j. C of minus 1 is coming out to be minus 1 by 2j. And what is your C of 1? C of 1 e to the power j omega naught t, e to the power j omega naught t. So C of 1 is coming out to be 1 by 2j. So your C of 1 is 1 by 2j and C of minus 1 is minus 1 by 2j. Say yes or no? Okay. So from here what I can see, this I can write down as j by 2, because if 1 by j goes upward it becomes minus j into 1, minus j into minus 1 will be plus 1. So C of minus 1 is j by 2 and C of 1 is minus j by 2. C of minus 1 can be written as, what is the mode of C of minus 1? If I ask you what is the mode of C of minus 1, mode, magnitude, that is 1 by 2. And what is the mode of C of 1? That is also 1 by 2. I hope you know how to calculate the mode. A plus jb, here A is 0, jb. So what will be the mode of this? Mode of b. So mode of minus 1 by 2 will be 1 by 2 only. So mode is 1 by 2. What about the angle? Angle of C of minus 1. What is the angle? 90 degree. And angle of C of 1. What is the angle? Minus 90 degree. All these things we have seen in basics. I hope you know all these kind of things. Very basic thing, angle and all these things. J will give you 90 degree angle. So minus j will give you minus 90 degree angle. So basically your C1 can be written as 1 by 2 with the angle of mode is 1 by 2 and angle is minus 90 degree. And C2 can be written as magnitude is 1 by 2, angle is not C2, so really sorry, C of minus 1, C of minus 1 and angle is 90 degree. So only these values are non-zero. If I ask you what is the value of C2 for this particular signal sin t, xt equals to sin t, what is the value of C2? That is 0. C of minus 2 is 0, C of minus 3 is 0, C of 3 is 0, all these things are 0. And what is the value of C0? That is also 0. Only C1 and C of minus 1 are non-zero, rest everything is 0 only. Say yes or no. Do you agree to this point or not? Only C of 1 and C of minus 1 are non-zero, rest all things are 0. So you can see that if I draw the graph of Cn versus n, what I am drawing? Cn versus n. So first I am drawing mode of Cn versus n. Okay. First what I am drawing? Mode of Cn versus n. So it is non-zero for 1 and minus 1. So mode of Cn versus n, it is non-zero for 1 and minus 1. That's it. At 1, what is the magnitude? 1 by 2. At minus 1, what is the magnitude? 1 by 2. I am drawing the magnitude only. Since it is discrete time, so value will be 1 by 2. Value will be 1 by 2. So this is how I will show the values. Values are 1 by 2. Did you understand? Why did I show like this? C, mode of C of n versus n I am drawing. So this is like a sequence, right? Sequence. Xt was a signal. We broke down into Fourier series coefficient. So these Fourier series coefficient will be C of 1, C of 2, C of 3, C of 4, C of minus 1, C of minus 2, C of minus 3, C of minus 4, or C of 0, or C of 10, C of 12. That means it will be defined at n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5, n equals to 6. Can it be defined at C of minus 1.1? No, there is no meaning of that. N has to be integer. So it is like a sequence. It is like a discrete time sequence, right? It is like a discrete time sequence. Say yes or no, right? And if I show the angle, so at -1 you are having the angle 90 degree, at +1 you are having the angle -90 degree. So at +1 you are having the angle to be -90 degree, at n equals to -1 angle is +90 degree. At n equals to -1 the angle is +90 degree. This is your +90 degree and this is your -90 degree. Now I need to show both of them combined. Look, I give you this number -2j. Can you tell me whether this number is positive or negative? -2j. Is it negative or positive? You cannot say. Someone will write down -2j as 2 by j. So here it looks like it is positive and here it looks like it is negative. You cannot say, right? What you can say? That sir, it is having an amplitude of 2. It is having amplitude of 2. What you will say, sir, it is having amplitude of 2 and angle of -90 degree. That's it. You cannot say whether it is positive or negative. If I give you +2 and -2, so you will say, sir, this is positive, this is negative. But if I give you +2j and -2j, you cannot say, sir, this is positive or this is negative. You cannot comment. Right? Are you getting this point? But one thing you can tell for sure, that whatever the direction of 2j will be there, -2j will be in the opposite direction. Because this is giving you 90 degree angle and this is giving you -90 degree angle. You cannot say one is positive or negative. You can just say that if I show 2j in positive direction, then I need to show -2j in the negative direction. And if I show 2j in the negative direction, I need to show -2j in positive direction. Is that point clear to you or not? Similarly, what is our C1? Our C1 is, someone will say that your C1 is C1 is 1 by 2j, but someone can say that it is -j by 2. So someone is saying it is negative, someone is saying it is positive. So we cannot actually comment whether it is positive or negative. So what I can do, I will show C1 as positive. If I am showing C1 as positive, that means C1 is having an amplitude of 1 by 2 and angle of -90 degree, and I am showing my C1 as positive. At n equals to 1, I am showing 1 by 2j. At n equals to 1, I am showing 1 by 2j. That means at n equals to -1, I will have to show negative because it is -1 by 2j. -1 by 2j. C of -1 is -1 by 2j. But it is never saying that this is positive and this is negative. No. This is never saying this particular thing that this is positive or this is negative. No, never. It is just a way of representation that if you are showing 1 by 2j in the positive side, then you have to show -1 by 2j at the negative side. Okay. Or what I could have done, is that there was another way of representing Cn. What could have been the another way? So here I am showing or. So that would be at -1 I show positive and at +1 I show negative. At -1 I show positive, that sir, this is my positive, -1 by 2j, -1 by 2j, and this is my negative, +1 by 2j, because 1 by 2j can be written as -j by 2 and this -1 by 2j can be written as +j by 2. So plus j by 2 minus j by 2. So this is how it can be written, C of n versus n. So there is two ways of representing Cn. Just you need to see the values. Value is -j by 2 plus j by 2. From there you can comment what will be the magnitude and what will be the angle. So this is how we are going to solve the problem based on Fourier series coefficient. This was very easy, very straightforward. Okay, you need to remember as well that C1 value will be 1 by 2j and C of -1 value will be -1 by 2j. It would be very easy to remember because sin t is equals to e to the power jt minus e to the power minus jt by 2. Then C1 value will come out to be 1 by 2, C of -1 value will be coming out to be -1 by 2. All good. Let's do the same for cos t. You can do the same for cos t on your own. Xt is equals to cos t, which can be first thing. What is the first thing? Always the first thing is find out the value of omega naught. That is 1. So can I write down my xt as cos omega naught t? Yes. E to the power j omega naught t plus e to the power minus j omega naught t divided by 2. This is your cos t. Can I write down this in this manner? J omega naught t into 1 by 2 plus 1 by 2 into e to the power minus j omega naught t. So from here you tell the value of C1. What is the value of C1? That is 1 by 2. Directly you can see fundamental frequency is coming. There is no factor here, only fundamental frequency is coming. So if fundamental frequency is coming, so this is plus 1, and what about this? This is minus 1. So C of 1 is 1 by 2, C of minus 1 is 1 by 2. C of 1 is 1 by 2, C of minus 1 is 1 by 2. Rest all the things are 0. Rest everything is 0. So draw the graph now. Cn versus n. First let's draw the mode of Cn versus n. What is the mode 1 by 2? What is the mode 1 by 2? So 1 and minus 1. 1 by 2 and 1 by 2. Okay. Next, angle. What is the angle here? 0 degree, 0 degree. Angle is 0 only. Mode of Cn. There is no angle. There is no term of j. That means there is no angle. So at n equals to 1, angle is 0 degree. At n equals to minus 1 as well, angle is 0 degree. Everywhere the angle is 0 degree only. Right? Now what about Cn? Cn versus n. So what is the value of C1? That is 1 by 2. And what is the value of C of minus 1? That is also 1 by 2. 1 by 2 and 1 by 2. So values are 1 by 2 only. This value is also 1 by 2. This value is also 1 by 2. Okay. So this is how I will show it. So always with respect to n, I will draw the graph. C of n versus n. So this is like a discrete time sequence. C of n is like a discrete time sequence, right? Let's solve the next question. Next question is xt equals to sine 2t, right? Sine 2t or cos 2t? Sine 2t. Next is sine 2t plus sine 4t. Okay. Sine 2t. What is the value of omega naught? Omega naught is 2 here. Sine omega naught is 2. So can I write down as sine omega naught t, right? What I will get? Sine j omega naught t minus sine e to the power minus j omega naught t divided by 2j. From here what you are getting? Ditto same thing you are getting. From here, if I write it down in this manner, 1 by 2j e to the power j omega naught t minus 1 by 2j e to the power minus j omega naught t. So what is the value of C1 here? 1 by 2j, and let's write it down on the upper side. From here I am writing, what is the value of C1 here? 1 by 2j, right? And what is the value of C of minus 1 here? Minus 1 by 2j. So from first question to third question, what did you do? In the first question, what was the frequency? Here the frequency was 1, but here the frequency is 2. Still the answer is same. In the first question, what was the value of C1? 1 by 2j value of C1. Here value of C of minus 1 is minus 1 by 2j. Here also the same thing. So let's just say I call first one xt as sine t, and then I find x of 2t, that is sine of 2t. So if it was having a Fourier series coefficient of Cn, this is also having the Fourier series coefficient of Cn only. Nothing got changed here. Although we will see this property, but here only you can see it. Sin t and sin 2t both are having the same Fourier series coefficient. This was having a fundamental frequency of 1, but this is having a fundamental frequency of 2. Only the fundamental frequency got changed. But Cn, the same Fourier series coefficient is there. If it was having Cn, then this is also having Cn only. Only the fundamental Fourier series coefficient, only the fundamental frequency got changed. That's it. Okay, only fundamental frequency got doubled here. That's it, nothing else. Okay. So again, I need to do the same thing, Cn versus n. First I will do mode of Cn versus n, then I will do angle of Cn versus n, and then I will do Cn versus n, right? So first I am doing mode of Cn versus n. What is the mode? 1 by 2, 1 by 2. 1 by 2 and 1 by 2. Minus 1, 1. What about mode angle of Cn versus n? Angle of Cn is, this is minus 90 degree and this is plus 90 degree. this is plus 90 degree and this is minus 90 degree. Right, this is Cn versus n. For n equals to 1, 1 by 2j, at n equals to minus 1, minus 1 by 2j, minus 1 by 2j, 1 by 2j. Very straightforward, very easy. All these things we have already seen. Let's go to the next one. xt equals to sine 2t plus sine 4t. So what will be the value of omega naught here? What is the fundamental frequency of this one? That is 2. What is the fundamental frequency of this one? That is 4. So what I need to do? Omega naught will be HCF of 2 and 4, if you remember this. Do you remember it? Time period will be LCM, right? Time period is LCM. So what will be the time period here? If I ask you t0 1, what that would be? 2 pi by 2. What that would be? Pi. And what would be t0 2 here? That would be 2 pi by 4. That would be equals to pi by 2. So LCM of pi and pi by 2. That can be written as LCM of pi and pi divided by HCF of 1 and 2. So what will be the LCM? Pi. What will be the HCF? 1. So your time period t0 is coming out to be pi, or you can say omega naught is 2 pi by pi, omega naught is coming out to be 2. So this is the value of omega naught. Or directly what you could have done, you could have just calculated the HCF of 2 and 4. So what is that? 2 only. Usually we are comfortable with this process, but in this Fourier series chapter, you should be comfortable with the omega naught as well. How will you calculate omega naught? Directly you need to take the HCF. So here omega naught value is 2, here omega naught value is 4. So what will be the omega naught of xt? What is the omega naught of ht? Sorry, not ht, xt. So what is the omega naught of xt? That is HCF of 2 and 4, that is 2 only, right? So our fundamental frequency of xt is 2. Say yes or no. So now can I write down my xt as sine omega naught t plus sine 2 omega naught t. Say yes or no. Omega naught value is 2. So here I am writing down sine omega naught t plus sine 2 omega naught t. Double of this, sine 2 omega naught t. So what I am getting? E to the power j omega naught t plus e to the power minus j omega naught t divided by 2j plus e to the minus sign would be there, no, really sorry, minus sign, e to the power 2 omega naught t minus e to the power minus 2 omega naught t divided by 2j, right? Here also I put minus 1 here. So this is what I am getting. So what do I see here? I take this negative 1. What I am doing? Minus 1 by 2j e to the power minus j 2 omega naught t plus again this one. This is also minus 1 by 2j, minus 1 by 2j e to the power minus j omega naught t plus 1 by 2j e to the power j omega naught t plus 1 by 2j e to the power 2j omega naught t, j 2 omega naught t. So what do you think, what is this value? What do you think, what is this? This is your C of minus 2. Say yes or no. This is your C of minus 2. Why is that so? Because Cn e to the power j n omega naught t. So if I put minus 2, C of minus 2 e to the power minus 2 omega naught t. So this is what I am getting. So this is your C of minus 2. What is this? C of minus 1. What is this? C of 1. And what is this? C of 2. Say yes or no. Are you getting this point or not? First task, always the first task is find the fundamental frequency, fundamental angular frequency. So here 2 and 4 I could see. That means omega naught 1 value was, omega naught 1 was 2 and omega naught 2 was 4. You know how to find out the fundamental frequency. You need to take the HCF. 2 and 4 HCF will be 2. So this can be written as sine omega naught t, this can be written as sine 2 omega naught t. Then I can break it down into complex exponentials. So when I broke it down into complex exponentials, this is what I was getting. E to the power j omega naught t divided by 2j, e to the power 2j omega naught t divided by 2j, Then in the minus side, e to the power minus j omega naught t divided by minus 1 by 2j, e to the power minus 2 j omega naught t divided by minus 1 by 2j. So C of minus 2, C of minus 1, C of 1, C of 2. This is what I am getting. Okay. So let's write down what all things you are getting. So C of 1 was 1 by 2j. C of minus 1 was minus 1 by 2j. C of 2 was 1 by 2j. C of 2 was 1 by 2j, and C of minus 2 was minus 1 by 2j. C of minus 2 was minus 1 by 2j. Right. So this is what we have got, and now we can draw the diagrams. First, what we will draw? Mode of Cn versus n. Right. So Cn is non-zero for n equals to 1, n equals to 2, n equals to minus 1, and n equals to minus 2. So what is the value of C of 1? C of 1, what is the mode of C of n here? 1 by 2, right? This mode is 1 by 2. What about this mode? Mode of C of minus 1. That is also 1 by 2 only. What about this one? What is mode of C2? Mode of C2 is also 1 by 2. Sorry, mode of C2. Okay, sorry. Really sorry. This was mode of C of minus 1. This was mode of C of minus 1. So that was 1 by 2. Here mode of C2, that is 1 by 2. And here mode of C of minus 2, that is also 1 by 2. Basically, you need to take the mode. So if I take the mode, value will be positive only. 1 by 2, 1 by 2, 1 by 2, 1 by 2. So always it is 1 by 2 only. And at 0 it is 0. So always it is 1 by 2. So always the value is 1 by 2. What about the angle? For angle, what I will do? Angle of C1. So what is the angle here? Minus 90 degree, right? Here the angle is 1 by j. 1 by j means minus 90 degree. So angle is minus 90 degree. What is the angle here? Plus 90 degree. What is the angle here? Minus 90 degree. C of 2 is minus 90 degree. And what is the angle here? C of minus 2. So minus 90 goes upward. This is already minus, so it becomes plus 90. So this angle is plus 90 degree. Is that clear to you or not? So this is your plus 90 degree and this is your minus 90 degree. Now I need to combine both of them and then represent it. So what I need to do? I need to combine both of them now. But the thing is, one will be represented by positive, another one will be represented by negative. Because all these are imaginary numbers, so you cannot tell whether it is positive or negative. So it is non-zero for 1 and 2. It is non-zero for minus 1 and minus 2. So what is the value of C of 1? 1 by 2j. So I am showing it by positive. I am showing it by positive. 1 by 2j. What is the value of C of 2? That is 1 by 2j. So this also I need to show by positive. What is the value of C of minus 1? That is minus 1 by 2j. So if I am showing this as positive, then this would be negative only. This would be negative. And what will be the value of C of minus 2? That will also be minus 1 by 2j. This is your minus 1 by 2j. And this is your 1 by 2j. So this is your C of n versus n, mode of C of n versus n, angle of C of n versus n. That's it. This is the process that we have done. So this is how we need to solve the problem. Certainly we will solve a lot of problems, like 5 to 10 problems more we will solve. But as of now, I just wanted to give you an idea of exponential Fourier series. So you would have got the idea of exponential Fourier series, that you will never apply these formulas until the waveform xt is given. Okay, and believe me guys, when we are done studying Fourier transform and Laplace transform, after that you will never have to apply these formulas in your complete life. Okay, because applying these formulas and then solving it requires a lot of time. It will require very much mathematics, like it will be completely mathematical. So applying these formulas requires some time. So in this chapter, in Fourier series, we will solve the problems applying these formula. But when we are done studying Fourier transform and Laplace transform, after that you wouldn't have to apply any formula an, bn, cn. You would not have to apply any formula, and you will be able to find out cn, an and bn just by a simple process. But that will happen after studying Fourier transform and Laplace transform. But as of now, in this chapter you will have to apply these formulas, but not in this lecture, in the upcoming lectures. Okay, so this is a very interesting chapter, like Fourier transform, Laplace transform, Z transform, all these are interrelated to each other. I will relate each things. Like in this chapter, what we are studying? Only we are studying periodic signals. In Fourier transform, we will study non-periodic signal as well. You can find out the Fourier transform for non-periodic signal as well. What does Fourier transform represent? So all these things we will see in the upcoming lectures. So as of now, what is the conclusion? That I have given you the field of Fourier series coefficient. So Fourier series coefficient we have find out in these manners, right? We have find out the Fourier series coefficient in these manner, and then we have for all these questions we have find out, right, without even applying these formulas. So what is the process? The process is, first you find out the value of omega naught. Always find out the value of omega naught, fundamental frequency. Here fundamental frequency was 1, here also it was 1, here it was 2. Then you represent your signal in terms of fundamental frequency only. That means sin omega naught t, cos omega naught t, sin omega naught t, sin omega naught t plus sin 2 omega naught t. Okay, sin omega naught t plus sin 2 omega naught t. So this is how you will represent your xt here. And if this is how I have represented, then I can break down into exponential. From there I go to know that my c of minus 1, c of minus 2, c of 1 and c of 2. And then I represented in this particular manner. Well and good. One thing I am pretty sure, from here also I can see, what will be your mode of Cn? That would be under root of this, under root of an square plus under root plus bn square divided by 2. Say yes or no? This will be your mode of Cn. Let's just say a is 3 and b is 4. So 3 minus 4j by 2. How will you calculate the mode? 2 remains as it is. What will be the mode of 3 minus 4j? That will be under root 3 square plus 4 square. So what will be the mode of an minus jbn? Under root a square plus under root a square plus minus bn square. So minus bn square will be bn square only. So in that manner I can write down. Say yes or no? And what will be the mode of minus Cn? That would be under root an square plus bn square divided by 2. So mode of Cn and mode of c of minus n. So basically one more thing you got to know here, that mode of Cn is equals to mode of c of minus n. This is always true. Although they are, one is an minus jbn by 2, another one is an plus jbn by 2. But if you calculate the mode, both of the modes are equal. Is that clear to you? Well and good. Okay. And here also you can check, if I take the mode, this and this both are equal, right? This and this both are equal. This and this both are equal. And here also this and this both are equal. So mode of Cn would be equal to mode of c of minus 1. So basically it will be like a even sequence, right? This is like a even sequence, right? It will be even. You cannot comment about angle. I am not commenting about angle, but I am talking about the mode of Cn. So mode of Cn will always be even, no matter what kind of function is there. Although we will write down all these points, but as of now you just need to remember one thing, that mode of Cn is equal to mode of c of minus n. Okay, mode of Cn is equal to mode of c of minus n. Yeah, sorry for the interruption. So what we were saying, we have studied about basic Fourier series coefficient, basic exponential Fourier series coefficient, how to find the exponential Fourier series coefficient and how to draw these graphs. And then we understood one point. What was that point? That point was that mode of Cn is equal to mode of c of minus n. Basically this particular graph will be symmetric about origin. So this we have understood, right? So this was the conclusion till this point, right? Now let's see a question. So here graph of Cn is given. You need to draw the graph of c of minus n. Then you need to draw the graph of c of n plus 3, then c of minus n plus 3, and then c of n minus 1. So these graphs you need to draw. So what is c of n? C of n is nothing but a discrete time sequence. What is C of n? C of n is nothing but discrete time sequence. Here we have seen it is a discrete time sequence only. It is a discrete time sequence having a value of 1 by 2j and minus 1 by 2j. And it is defined only for n equals to 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, n equals to 0. So it is nothing but a discrete time sequence only. When we were studying basics of signal, there we saw discrete time sequence as x of n, or y of n, or g of n, or h of n, right? Or z of n. In that manner we were seeing the discrete time sequence. Here what I am writing, I could have written c of n in that manner, but I am writing cn. So this is nothing but this only. Here I am writing in subscript. So whenever I represent Fourier series coefficient, I write down n in the subscript. But I could have written n like this as well. But general way is this. Okay, so this is how I am representing C of n. If I need to draw C of minus n, what is the meaning of C of minus n? That means you just need to take the mirror image. What is the meaning of C of n plus 3? That means you need to shift your samples 3 towards the negative hand side, n plus 3. What is the meaning of plus 3? Plus 3 means it should be shifted towards the negative hand side. What is the meaning of C of n minus 1? That means your samples will be shifted by 1 towards the positive hand side. What is the meaning of C of minus n plus 3? How will you draw C of minus 1 n plus 3? So first C of n, then C of n plus 3, and then C of minus n plus 3. So what is the meaning of C of minus n plus 3? That means first you shift it by 3 towards the negative hand side, and then you take the mirror image. Are you getting this point? So whenever I say C of n, what should come into your mind? That C of n is the Fourier series coefficient of xt. C of n is Fourier series coefficient of xt. What is C1? C1 is the magnitude of e to the power j omega naught t. What is C of minus 1? C of minus 1 is the magnitude of e to the power minus j omega naught t. What is C of 2? C of 2 is the magnitude of e to the power 2j omega naught t. Not only magnitude, you will say amplitude. I should not say magnitude, it is the amplitude. C of minus 1 is the amplitude of e to the power minus j omega naught t. C of 2 is the amplitude of e to the power 2j omega naught t. C of minus 3 is the amplitude of e to the power minus j 3 omega naught t. Right? And these amplitude will be discretized. That means C of 1 is defined, C of 2 is defined, C of 3 is defined, C of 4 is defined, C of 0 is defined, C of minus 1 is defined, C of minus 2 is defined. So this is a very big confusion for a lot of students. That sir, xt was given as a continuous time signal. But how C of n is discrete time? So C of n is just a way of representation. This is just a way of representation. And the representation we are doing in discrete time. So this is not time. This is actually n equals to 1, n equals to 2. So what this is showing? This is showing that this is fundamental frequency. What this is showing? This is 2 omega naught. This is n equals to 3 showing it is 3 omega naught. N equals to minus 1 is showing minus omega naught. So here this n is not the time. It is not the time. It is just a frequency. So that's why I am saying that C of n is a sequence. Okay. So it is not a, basically C of n is nothing but sequence. So if you need to draw C of minus n, what you will do? C of n2, you need to go to C of minus n. What does that mean? I just need to take the mirror image. That's it. So what you will do? You will just take the mirror image. So whatever C of n was given, I just need to take the mirror image C of minus n. So it was going from minus 2 to 4. Now it will go from minus 4 to 2. Minus 4, minus 3, minus 4, minus 3, minus 2, minus 1, and this is 0. So at 1 you are having a amplitude of 2. At 0 you are having amplitude of 2. At 2 you are having this amplitude is 1, minus 1, sorry. At 2 you are having the amplitude of minus 1. At 1 you are having the amplitude of minus 2. At 2 you are having an amplitude of 2. At 3 you are having amplitude of 0. At minus 4 you are having amplitude of minus 4. Minus 4. 2, wait a second. Yeah. 1 has been gone to minus 1. 2 has been gone to minus 2. Just the mirror image I am taking, nothing else. Just I am doing the mirror image, nothing else. Okay. So this 2 is coming to 2. This minus 1 is coming to minus 1. This 2 is remaining at 2 only. This minus 2 is coming to minus 2. This 2 is coming to plus 2 here. This minus 4 is coming here. And at minus 3 it is 0. So this is the graph of C of minus n versus n. Can you draw the graph of C of n plus 3? What will happen? The whole sample will be shifted 3 times backward. The whole sample will be shifted 3 times backward. So this 3 will come to 0. This 2 will come to minus 1. This 1 will come to minus 2. This 0 will come to minus 3. This minus 1 will come to minus 4. And this minus 2 will come to minus 5. And this 4 will come to 1. So this kind of sequence you will get. C of n plus 3. Say yes or no. What is the meaning of C of n minus 1? That means whole sequence. This whole sequence will be shifted by 1. This whole sequence will be shifted by 1. This whole sequence will be shifted by 1. Right? Whole sequence is shifted by 1. So this minus 2 is coming to minus 1, minus 1 is coming to 0, 0 is coming to 1, this 4 will be coming to 5. And what is the meaning of C of minus n plus 3? So C of minus n plus 3, what you will do? First you will start with C of n, then you will go to C of n plus 3, and then you will go to C of minus n plus 3. C of minus n plus 3. Okay. So C of n plus 3 we have already made. You need to go to C of minus n plus 3. C of minus n plus 3, that means you just need to take the mirror image. So just take the mirror image. So mirror image of this particular thing. What that would be? 2 minus 2, 2, 2 minus 1. So 2 minus 2, 2, 2 minus 1. And this minus 4 goes here. This minus 4 goes here. So this is the graph of C of minus n plus 3. I will be using it somewhere in the future. That's why we are studying it here. Okay. So C of n is nothing but a sequence only. This should be there in your mind. C of n is nothing but a sequence. Just like x of n, y of n, z of n, it is like a sequence only, because this is how we are drawing the graph. C of n versus n. C of n versus n. So it is a sequence which is defined at omega naught, 2 omega naught, 3 omega naught, 4 omega naught, or you can say n equals to 1, n equals to 2, n equals to 3, n equals to 0, n equals to minus 1, n equals to minus 2, n equals to minus 3. Right? So now this question is given. This is your x of t. It is having a Fourier series coefficient of C of n. Now you need to find the Fourier series coefficient of x of minus t. That is shown as d of n. Then you need to find the relation between Cn and Dn. So what is the first task? Let's find the Fourier series coefficient of xt. So what is the value of omega naught 1 here? That is 2. And what is the value of omega naught 2 here? Sorry, omega naught 1 is 1. Really sorry. Here omega naught 1 is 1, omega naught 2 is 2. So what will be the value of omega naught here? Omega naught for xt. What will be the value? That would be HCF of 1 and 2. What would be the HCF? HCF will be 1. So what is the value of omega naught here? Omega naught is 1. So can I represent my xt in this manner? Xt is equals to sine omega naught t plus cos 2 omega naught t. Right? So that will be equivalent to e to the power j omega naught t plus e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j plus e to the power j 2 omega naught t plus e to the power minus j 2 omega naught t divided by 2. So what is the value of C1? C1 is 1 by 2j. What is the value of C of minus 1? C of minus 1 is minus 1 by 2j. What is the value of C2? C2 is 1 by 2. And what is the value of C of minus 2? That is 1 by 2 only. You can directly see all these values: 1 by 2, 1 by 2, minus 1 by 2j, 1 by 2j. Right? So all these values I can see. Now what will be your x of minus t? Look, just tell me one thing. If x of t is having the fundamental frequency of omega naught, then what will be the fundamental frequency of x of minus t? That will also be omega naught only. Because t naught will not change, right? When does t naught changes? If you take the mirror image, will the t naught change? There is a particular signal which is having a fundamental frequency of t naught. Which is having a fundamental time period of t naught. Now if you take the mirror image, will the time period change? No. Time period will be as it is. That means omega naught will also be as it is. So fundamental frequency will also not change. So omega naught is same. Here also omega naught is 1. So if I write down what is the omega naught for x of minus t, that will also be 1 only. This is also 1. Right? Omega naught t, you will not say it is minus 1. It is 1 only. Omega naught is a positive value. So omega naught is 1. So what will be your x of minus t? X of minus t will be sine of minus t plus cos of minus 2t. Can I write it down in this manner? Sine of minus omega naught t, because what is the value of omega naught? That is 1, plus cos of minus 2 omega naught t. This omega naught is the fundamental frequency of x of minus t. That will be same, right? Fundamental frequency of x of minus t will be same as the fundamental frequency of x of t. So can I write it down in this manner? Surely I can write down in this manner. So what I will get? E to the power minus j omega naught t. Basically now in place of omega t, I will put minus omega naught t. So e to the power minus j omega naught t minus e to the power, in place of omega t I need to put minus omega naught t. So minus minus it will become plus, divided by 2j. Say yes or no. Are you getting this point? In place of omega naught t, I need to put minus omega naught t. So here I am putting minus omega naught t, here also I am putting minus omega naught t. Here, in place of 2 omega naught t, I need to put minus 2 omega naught t. So minus j 2 omega naught t plus, in place of omega naught t, I need to put minus 2 omega naught t. So minus minus will become plus. So e to the power j 2 omega naught t divided by 2. So what you are getting? Here the Fourier series coefficient is dn and here the Fourier series coefficient was cn. So what is the value of d of 1? D of 1 is, I need to add a page. So your d of 1 is, from here you can see d of 1 is minus 1 by 2j. D of 1 is minus 1 by 2j. What is the value of d of minus 1? D of minus 1. So d of minus 1 is 1 by 2j. What is your d of 2? D of 2 is 1 by 2. D of 2 is 1 by 2. And what is d of minus 2? That is also 1 by 2. Now let's draw the graph of Cn and Dn. Okay, let's draw the graph of Cn and Dn. So for n equals to 1, 2, minus 1 and minus 2. Okay, so Cn at n equals to 1 you are having 1 by 2j and at n equals to 2 you are having 1 by 2. So 1 by 2j and 1 by 2. This is your 1 by 2j and 1 by 2. At c equals to minus 1 you are having minus 1 by 2j, at c equals to minus 2 you are having 1 by 2. So minus 1 by 2j and 1 by 2. Minus 1 by 2j and 1 by 2. What about your d of n? This is the graph of c of n, right? What about the graph of d of n? N equals to 1, n equals to 2, n equals to minus 1, n equals to minus 2. So what is the value of d1? d1 is minus 1 by 2j. d1 is minus 1 by 2j. What is the value of d2? d2 is 1 by 2. What is the value of d of minus 2? That is 1 by 2. Sorry, 1 by 2. And what is the value of d of minus 1? That is 1 by 2j. 1 by 2j. So these are the values: 1 by 2, 1 by 2j, minus 1 by 2 and 1 by 2j. Can you see one thing? If you take the mirror image of this particular graph, you will get this graph. If I just take the mirror image, this goes here and this goes here. So if you take the mirror image, c of minus n will be equals to d of n. There you go. What does that mean? That if xt is having a Fourier series coefficient, if xt is having a Fourier series coefficient of Cn, then x of minus t will have the Fourier series coefficient of c of minus n. So a lot of people will remember this particular thing, but they don't even know what is the meaning of c of minus n. C of minus n is simply the mirror image of this. That's it. What does that mean? That means whatever the value of c1 you are getting here, the same value of c of minus 1 you will get here. Whatever the value of c1 was 1 by 2j. c1 was 1 by 2j. So d of minus 1 will be 1 by 2j. So whatever the value that you are getting at omega naught, the same value you will get at minus omega naught. Whatever the value you are getting at 2 omega naught, whatever the value you are getting at 2 omega naught, the same value you will get at minus 2 omega naught. Whatever the value you are getting at minus omega naught, the same value you will get at omega naught. So xt is having a Fourier series coefficient of Cn, then your x of minus t will have the Fourier series coefficient of c of minus n. You need to remember this particular thing. Say yes or no. Okay, very easy. xt Cn, x of minus t means n replaced with minus n. So this is how you need to remember it. So this is the first conclusion that we have made. You can star mark it. It should be there in your mind. It is very, very, very important. Okay, very important it is. Let's go to the next one. Fourier series coefficient of xt is Cn. Then you need to find the Fourier series coefficient of x conjugate t, that we are representing by dn. Okay, So let's do it with mathematics, although here also we could have done the mathematics, but I thought of explaining this with the particular question. So first I explained what is the meaning of C of minus n, what is the meaning of C of n plus 3, C of n minus 1, C of minus n plus 3. First I explained the meaning. Then I saw that let's solve it with respect to a question. So when we saw the question, we got to know that this is having omega naught frequency, this is also having omega naught frequency. So x of t is having Cn, then x of minus t is having C of minus n. Now we will do the mathematics. You can explain it with respect to question as well, but let's do the mathematics. Okay, so here we will do the mathematics. So what is C of n? C of n is summation going from minus infinity to infinity x of t e to the power j n omega naught t, right? What will be your d of n? So d of n will be minus infinity to infinity yt. What I am saying, this signal I am calling as yt. So yt e to the power j n omega naught t, right? The Fourier series coefficient, this is the Fourier series coefficient, this is also the Fourier series coefficient. So Fourier series coefficient for yt is dn. So what I will write, n goes from minus infinity to infinity, yt e to the power j n omega naught t. There is no issue about that, right? What I can do, in place of yt, what I can replace? X conjugate t. Say yes or no, right? Now what I will do is that in this question I am replacing n with minus n. What I am doing, I am replacing n with minus n, or should I replace here? Okay, let's replace n with minus n. N with minus n. What I am doing, in this particular equation I am replacing n with minus n. So what will happen? N goes from minus infinity to infinity, x of t e to the power, n is replaced with minus n, e to the power minus j n omega naught t. Just tell me one thing, n goes from minus infinity to infinity, x of n is equivalent to n goes from minus infinity to infinity, x of minus n or not? Or here you can put minus n goes from minus infinity to infinity. Both of them are same. Say yes or no. Basically, what this would be, x of minus 2 plus x of minus 1 plus x of 0 plus x of 1 plus x of 2 until going to infinity. Here the value of minus n you need to start from minus infinity. So again this will be the same thing. Are you getting this point or not? Minus n will be minus 2, minus n will be minus 1, minus n will be 0, minus n will be 1. So both of them are the same thing. The point is, here if I put minus n is going from minus infinity to infinity, or I put n is going from minus infinity to infinity, both are the same thing. If minus n is going from minus infinity to infinity, that means what all value it will take? Minus infinity, then dot 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 minus 2, minus 1, 0, 1, 2 till infinity. And if I say n is going from infinity to infinity, then minus infinity to infinity, then what all values it will take? It will take the same value, 0, 1, 2, infinity. So here if I replace, in place of n if I replace minus n, that doesn't matter, both are the same thing. Basically I can change the limit from n goes from minus infinity to infinity again. Are you getting this point or not? Did you understand this point? N is going from minus infinity to infinity. If I replace minus n, so here minus n will come, here also minus n should come, no, here also minus n should come. But that doesn't matter, because both of these things are same only. You will put the value of minus n there, or you put the value of n. If it is going from minus infinity to infinity, then that means n is also going from minus infinity to infinity only. If I say minus n is going from minus infinity to infinity, what does that mean? That n will go from infinity to minus infinity, or you can say it is going from minus infinity to infinity, because in the summation if I interchange the limit, n is going from a to b, and then I interchange the limit, n goes from b to a, both will be same, but in the integration b to a will be equals to minus a to b. But in the summation, if I interchange the limit, minus sign doesn't come out. This we have already proved. So same thing is happening here. Although the limit will change infinity to minus infinity, but in the summation you can interchange the limit, doesn't matter. Always we will write down the limit from lower value to higher value in case of summation. You can interchange the limit, but in case of integration, if you interchange the limit, then minus sign comes out. But in case of summation, if you interchange the limit, no negative sign would come out. Is that clear to you or not? I hope you remember it, right? Always we write down lower limit to higher limit. So this point is clear to you or not? It is clear, right? Now what I am doing, I will take the conjugate what I am doing, I am taking the conjugate on both of the side. J n omega naught t, conjugate on both of the side I am taken. So what is this? This is just summation. This is just summation. So what will happen? Conjugate can go inside. This is just a operator. So nothing will happen to operator. Conjugate can go inside. Right? Now one thing we already know. What is that? Let's remove it off. What is that? That A into B conjugate is equals to A conjugate dot B conjugate. So what it can be written as? N goes from minus infinity to infinity. X conjugate t e to the power j. What will be the conjugate of this thing? E to the power minus j n omega naught t conjugate. So what will be the conjugate of this particular thing? J will be replaced with minus j. J will be replaced with minus j. So here j will be replaced with minus j. So what it will become? Plus j. So this is the conjugate we are getting. So this is your C of minus n conjugate. C of minus n conjugate, is that equivalent to D of n? This is the equation 2. This is the equation 1. So what do you see here? That dn is equals to C of minus n conjugate. Say yes or no. So what did you understand? That if your x of t is having a Fourier series coefficient of C of n, then x conjugate t will have the Fourier series coefficient of, how will you remember? That okay, there is a conjugate sign, so there is conjugate sign. Here there is conjugate sign, here there is conjugate sign. But one more change I need to do, n will be replaced with minus n. That's it. This is the conclusion. Should be there in your mind. Has to be there in your mind. So what two kind of conclusion we have seen? That if xt is having a Fourier series coefficient of Cn, then x of minus t will have the Fourier series coefficient of C of minus n. Here there is a minus sign, here also there will be a minus sign. But if there is a conjugate, then conjugate will come. Along with that, minus sign will also come. A very, very important conclusion should be there in your mind. Xt is having a Fourier series coefficient of Cn, x of minus t will have a Fourier series coefficient of C of minus n, x conjugate t will have a Fourier series coefficient of C conjugate minus n. Okay. What will be the Fourier series coefficient of x conjugate of minus t? Can you write it down? Yes. Basically, from xt I can go to x conjugate t, and then I can go to x conjugate minus t. So here, if I follow this process, so what will be the Fourier series coefficient of xt? That is Cn. What will be the Fourier series coefficient of x conjugate t? So here conjugate will come, but if conjugate is coming, another negative sign will come. And what will be the, if I call x conjugate t as yt, so what will be your x conjugate minus t? That will be of y of minus t. So in place of t, what I am putting minus t. So in place of t if I put minus t, n goes to minus n. So here what will happen? N will go to minus n. So this will become plus n. So x conjugate minus t is having a C conjugate n Fourier series coefficient. So this is the answer. Basically, if conjugate came, then n became minus n, along with that conjugate sign also came. And then t became minus t. So minus n became plus n. Or what you could have done? You could have followed in this manner. X of t goes to x of minus t, then we go to x conjugate of minus t. So x of t is Cn. What is x of minus t? That is C of minus n. Then I need to take the conjugate. So if I take the conjugate, then conjugate come, along with that a negative sign also comes. So C conjugate n. So this is the same answer we are getting. X of minus t, n goes to minus n. When we do the conjugate, what happens? The conjugate sign come, along with that minus n replaced with plus n. So C conjugate n. That's it. That's the answer. So that means x conjugate minus t will have a Fourier series coefficient of C conjugate n, which you don't need to mug up. You will just remember it. Okay. You will just remember the process. These you need to keep in mind. A very, very important conclusion. And here you can follow the process. X of minus t, C of minus n. Then you take the conjugate. Conjugate will come. Minus n will be replaced with plus n. So this is the answer. In that manner you need to follow. Say yes or no. All good? Let's go back to basics of signal. Again we are going to basics of signal. Okay. So x of t is a continuous time sequence and alpha n is a discrete time sequence. There is no relation between xt and alpha n. Okay. What I am saying, x of t is a continuous time sequence. Continuous time signal, and alpha n is a discrete time sequence. There is no relation between xt and alpha n. No relation. No relation. No relation. So first let's talk about xt. So if xt is real, so can I write down xt equals to x conjugate t? This we have already seen. Xt is real, then xt equals to x conjugate t. Is that clear to you? Right? Very simple, right? Because xt, let's just say xt is 5t. Is that real? Yes. If you take the conjugate, in conjugate j is replaced with minus j. There is no j. So it will be 5t only. So xt conjugate. Xt is equals to x conjugate t. If xt is imaginary, xt is equals to j5t. Is that imaginary? Yes. What will be x conjugate t? J will be replaced with minus j. Is that equals to minus xt? Yes. So xt is equals to minus of x conjugate t. What is the meaning of conjugate symmetry? Xt will be equals to, you do the conjugate, also you replace minus t as well. If both are equal, then conjugate symmetry. If both are equal, but they are equal with the negative sign as well, that means it is conjugate antisymmetry. Okay. What is the meaning of even? X of t would be equals to x of minus t. And what is the meaning of odd? Minus sign comes out. X of t is equals to minus of minus xt. X of minus t, right? It has the ability of eating up the negative sign, but it has the ability of taking out the negative sign. So if negative sign comes out, minus minus will become plus, right? Here, this is how we check. So all these we have already seen. Real, imaginary, conjugate symmetry, conjugate antisymmetry, even, odd. Same goes for discrete time sequence as well. This alpha n could have been written in this manner as well. But I am writing alpha n because here we write down Cn. So that's why I am writing alpha n in this manner. But I am not saying that alpha n is the Fourier series coefficient of xt. This is what I am not saying. I am saying that xt is a separate continuous time signal and alpha n is a separate discrete time sequence. So no relation between alpha n and xt. So if I say alpha n is real, so same thing like continuous time. If it is real, that means there is no impact taking the conjugate. And if it is imaginary, then if I take the conjugate, it will be equal to the negative. If it is conjugate symmetry, so in conjugate symmetry, what do we do? N replace with minus n and then conjugate. If no signs comes out, that means conjugate symmetry. Now n replace with minus n, then take conjugate. If negative sign comes out, that means conjugate antisymmetry. What is the meaning of even? N replace with minus n, equal. And what is the meaning of odd? N replace with minus n, but negative sign comes out. Okay, well and good. Everything is crystal clear. Here it should have written alpha conjugate minus n. So I hope you are following it up. All good. Let's see a question. If xt is real, then you need to comment on C of n. If xt is real, then you need to comment on C of n. So xt is real. What does that mean? Xt will be equals to x conjugate t. What is the Fourier series coefficient of xt? Cn. What is the Fourier series coefficient of x conjugate t? So you will take the conjugate, n will be replaced with minus n. If both signal are equal, that means Fourier series coefficient will also be equal. So if xt is real, then what is the relation we are getting? C of n is equals to C conjugate minus n. C of n is equals to C conjugate minus n. Alpha of n is equals to alpha conjugate minus n. You replaced n with minus n and then you took the conjugate, and it is coming out to be equals to alpha of n and. What does that mean? That C of n is conjugate symmetry. Alpha n, you replaced n with minus n and then you took the conjugate. N minus n took the conjugate, it is coming out to be equals to C of n only. What does that mean? That it is conjugate symmetry. That means if xt is real, then Cn is conjugate symmetric for sure. That's it. This is the conclusion. If xt is real, then Cn is conjugate symmetry for sure. Is that clear to you? Second, if xt is imaginary, then what you will get? X conjugate t and then minus sign. So what does that mean? This will have Cn. Oh, one more thing. If xt has a Fourier series coefficient of Cn, then what will be the Fourier series coefficient of minus xt? That will be minus Cn. Very simple, right? Basically, x of t is broken into Cn e to the power j and omega naught t. If I multiply minus sign here, another minus sign will go here. This minus can go inside. So what will be the Fourier series coefficient? Minus Cn. Are you getting this point? So this also you can write down somewhere. Okay, here only I will write down. What will be the Fourier series of minus xt? Fourier series coefficient of minus xt, that will be equals to minus Cn. Very simple thing, right? If it is being multiplied with minus sign, then this will also be multiplied with minus sign. Yeah. So if there is a minus sign, then minus sign would come. Now conjugate is there, x conjugate t. So conjugate will come and will be replaced with minus n. So what is this? Cn is conjugate antisymmetry. Say yes or no. Do you agree to this point? Because x of n is equals to x conjugate minus n, then minus n comes out. What does that mean? This is conjugate antisymmetry. Alpha n minus alpha conjugate minus n. What does that mean? It is conjugate antisymmetry. This is a very typical concept which we are learning with very good patience and in a very good flow as well. I hope you understood the flow. Why we are doing all these things? Because we need to maintain the flow, and this is a very complex topic actually. Okay, a lot of people just mug it up. If it is real, then it will conjugate symmetry. If it is imaginary, conjugate antisymmetry. But you don't need to mug up anything. You will derive it in the examination hall. If xt is real, can you write down the relation? Xt equals to x conjugate t. Now can you write down the Fourier series coefficient of xt? Cn. What will be the Fourier series coefficient of x conjugate t? C conjugate minus n. If both are equal, what does that mean? Cn is coming out to be conjugate symmetry. And here Cn is coming out to be conjugate antisymmetry. There you go. Very simple, right? So what do you see here? Cn is equals to an minus jbn by 2 and C of minus n is equals to an plus jbn by 2. This is universal. This was always true. Always true. Say yes or no. Always true. Now if you look at this expression, then what you will say? That sir, in C of minus n, if you take the conjugate, then it feels like that j will be replaced with minus j. So it feels like that, sir, it will be equals to Cn. Here, just by looking at the expression, you feels like it feels like that, sir, if you take the conjugate here, then it is coming out to be Cn. But is it universal? That Cn is equals to C conjugate minus n. Is it universal? No, absolutely not. It is only true when xt is real. When xt is real, then only it is true. Here it feels like that it will always be true. But what if your Bn is imaginary or your An is imaginary? If these things are imaginary, then scenes will change. Because if your xt is imaginary, then An will be imaginary and Bn will be also imaginary. Okay, then the scenes will change. Are you getting this point? Okay, there C of minus n conjugate will come out to be minus of Cn. So just by looking at the expression, some people will say that, sir, Cn is equals to C conjugate minus n. But this is only true when xt is equals to real, or you can say xt is equals to x conjugate t. A very, very important point. A lot of people mess it up here. I have seen a lot of people saying that, okay, C of n is equal Cn expression, then C of minus n expression, even in the notes it is written. Then from here we can see that C of n is equal to C conjugate minus n. Absolutely wrong. This will be only true if xt is real, and if xt is imaginary. When xt is imaginary, what does that mean? That xt equals to x conjugate t, but with the negative sign. Then Cn would be equals to minus C conjugate minus n. So this will be the second thing. Okay, this is the first thing when xt is real, and when xt is imaginary, then this is what it will be followed. So you don't need to mug it up. The only point I wanted to deliver here is that when we wrote down these expressions, just a second. Yeah, so what I was saying, when we wrote down these expressions, Cn equals to An minus Jbn by 2, C of minus n equals to An plus Jbn by 2. So at that time, a lot of people would have thought that, sir, if you just take the conjugate here, it will be coming out to be equal. But there I did not write it down. Why is that so? Because I know that it will be only true if xt is real. And if xt is imaginary, then this will be true. Are you getting this point or not? Okay. So a very, very important point. So till this point, you don't need to feel like there is a lot of things. This is the only conclusion. If xt is having cn, x of minus t will have c of minus n, and x conjugate t will have c conjugate minus n. And this also you can remember, minus xt will have minus of cn. Then if xt is real, then you know. If xt is real, then you know what will be the relation. If xt is imaginary, then you know what will be the relation. From there you can write down the relation between complex. Then you can write down the relation between c of n and c of minus n conjugate as well, right? Basically, you can comment on the Fourier series coefficient of exponential Fourier series coefficient of xt, right? So these are very, very important. So if xt is real, then Fourier series coefficient of xt will be conjugate symmetric, and if xt is imaginary, then Fourier series coefficient of xt will be conjugate antisymmetry. You don't need to mug up these statements. I am never going to write down these statements in the text as well, but in the examination, if these statement wise questions are coming, will you be able to answer that? Surely you will be able to answer that, but not by mugging up, by deriving these things. In 2 steps you will be able to derive, and very confidently you will be able to mark the answer. Say yes or no. Let's prove it. Let's prove all these things with the question, right? So xt equals to sin t is given. You need to find exponential Fourier series. Basically, I'm going to prove this point. I'm going to prove this point. Okay. So what is xt here? Xt is real. Xt is real. So this we have already seen. What was the value of c1? That was 1 by 2j. And what was the value of c of minus 1? That was minus 1 by 2j. And yeah, one more thing. Cn plus c of minus n was equals to an. This is also always true. And cn minus of cn and then multiply with j was equals to bn. This is also always true. Say yes or no. Right? This was the relation or something else. If I subtract both of them, c of minus n, then jp would come, then minus j. Yeah, these two were the relation. Yeah. So these two were the relation. This is also always true. Say yes or no. Right? Here, by when we wrote down these expressions, we did not say xt is real or xt is imaginary. Just we wrote down these expressions. So this is also always true. So these two expressions are also always true. Now I have the value of c1 and c of minus 1. Can I find out the value of a1? What is a1? a1 is c1 plus c of minus 1. c1 plus c of minus 1. What that would be? 1 by 2j minus 1 by 2j. That would be 0. So a1 is coming out to be 0. Can I find out the value of b1? What will be b1? j into c1 minus c of minus 1. So j into 1 by 2j minus of minus 1 by 2j, that means plus 1 by 2j. So that would be equals to j. Sorry, j into 1 by j, it would be equals to 1. So b1 is coming out to be 1. And c1 was coming out to be 1 by 2j, and c of minus 1 was coming out to be minus 1 by 2j, and rest all was 0 only. Basically, c2 is equals to c of minus 2 is equals to c of 1, sorry, not c of 1, is equals to c of 0 is equals to c of 3 is equals to c of minus 3 was 0 only. Then a1 is also coming out to be 0, a2, a3, all these things will come out to be 0 only. Because if c3 is 0, c of minus 3 is 0, then what will be a3? c3 plus c of minus 3, 0 plus 0 will be 0 only. So all these will be 0, right? All these will be 0. All these will be 0 only. Here only b1 is 1. Rest all things b2, b3, b4, b5, all these will be 0. Why is that so? Because what will be b2? b2 will be c2 minus c of minus 2 into j. What is c2? 0 minus 0. 0 minus 0 will be 0 only. So it will be 0. So everything else will be 0. So only exponential Fourier series c1 and c of minus 1 are non-zero, and b of 1 is non-zero. Although for finding b of 1 you don't need to do all this process. Why is that so? Because what is the value of omega naught here? Omega naught is 2. So xt can be written as sin omega naught t. And what we have seen, xt can be written as dc value plus a1 cos omega naught t plus a2 cos omega naught t, a2 cos 2 omega naught t, in that manner, plus b1 sin omega naught t plus b2 b1 sin omega naught t plus b2 sin 2 omega naught t in that manner, right? So if I compare this expression with this expression, what I get to know is that from here I can see that b1 is equals to 1. For finding, if I just need to find b1, do I need to calculate c and nc of minus 1? No. Just by looking at this expression, I can tell that my b1 will be 1 and rest all the things will be 0. b2 will be 0, b3 will be 0, dc value will be 0, or a1, a2, a3, all these will be 0 only because it is not having any cosinusoid. If it is not having any cosinusoid, that means all these will be 0 only. There you go. Say yes or no. So this is the first question. Now in this question, what is the scene? xt is real, right? And what you can see, c of 1 is equals to c of minus 1 conjugate. If you take the conjugate of this particular thing, j will be replaced with minus j. So minus minus sign will come minus minus will be cancelling out. So it will be 1 by 2j. So c of 1 will be equals to c of minus 1 conjugate. Or you can write down c of n will be equals to c of minus n conjugate. So this is only true when xt is real, and this we have proved it. If xt is real, then c of n is equals to c of minus n conjugate. Here it is proved. Now what if your xt is imaginary? What is this? xt is imaginary, right? What is the value of omega naught here? Omega naught is 2. So how I can write my xt? xt will be j sin omega naught. Can I write it down in this manner? J e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j. J and j gets cancelled out. E to the power j omega naught t minus e to the power minus j omega naught t divided by 2. So what is the value of c1 here? 1 by 2. And what is the value of c of minus 1 here? Minus 1 by 2. Right? Well and good. What will be the value of a1? a1 will be c1 plus c of minus 1. So 1 by 2 minus 1 by 2. What that would be? 0. And what will be the value of b1? b1 will be j into c1 minus c of minus 1. So j into 1 by 2 minus of minus 1 by 2. That would be plus 1 by 2. So what will be the value? J. So a1 is coming out to be 0. a1, a2, a3, all these values will come out to be 0, right? b1 will be j, and rest all the things b2, b3, b4, all these will come out to be 0 only. So all these is 0, b1 is j, and all these will be 0. And this we can directly see that sin omega naught t component will be b1, and that is having a magnitude of j only. I should not say magnitude, that is having an amplitude of j only. So b1 will be j only. You don't need to do all this process to find out the value of b1, because directly we can see it will be written as xt can be written as j sin omega naught t. So your xt is dc plus b1 sin omega naught t plus b2 sin omega naught t plus b3 sin 3 omega naught t plus b4 sin 4 omega naught t in that manner. So from there I get to know that my b1 value is j only. And there is no cosinusoid, that means a1, a2, a3, everything is 0. Say yes or no. Now, what do you see here? What do you see? xt is imaginary, right? xt is imaginary. So c of 1 is equals to c of minus 1 conjugate, because this is real only. So if you take the conjugate, it will be same as it is, but another negative sign you need to put. What is c of minus 1? That is minus 2. If you take the conjugate of this, nothing will happen. But if you add another minus sign, what you are getting? C of what you are getting? 1 by 2. So yes, this is also true here. So c of 1 is coming out to be c of minus 1 conjugate and then another minus sign. Now someone will say that, sir, it is equals to, this relation is also true, sir. Yes, this is also true. This relation is also true. But this relation is also true, no? As of now, our target is not to prove this relation. I am solving these questions just for the sake of proving this particular thing. That if xt is real, then only c of n will be equals to c conjugate minus n. But if xt is imaginary, then c of n is equals to c conjugate minus n minus sign. Because when we see this expression, a lot of people confuse that this will be always true. But no, this is not always true. Like a lot of people, even in the notes of a lot of educators at big platform, I have seen that they have written C of n is equals to C conjugate minus n. Always true. Absolutely wrong. It is only true when xt is real. Okay, and that we have proved as well. But if xt is real, then xt is equals to x conjugate to xt is equals to x conjugate t. And if xt is having a Fourier series coefficient of Cn, then what will be the Fourier series coefficient of x conjugate t? Conjugate sign will come and negative sign. Then only it will be equal. If it is imaginary, then another negative sign will come. So this thing we are proving here. Okay, this particular thing we are proving here. Although this is also true, if you look at this expression, you will say that C of minus n and then minus sign I multiply will be equals to C of n. So yeah, this is also true. But this is not our target as of now. Our target is C of minus n conjugate, then minus sign will be equal to Cn. And this we are proving. Okay. So this was the target. That's why we were solving these particular questions. Okay. Now if your xt is complex, what is this? Complex. Why is that so? Because this is the real part and this is the imaginary part. So combine both of them will be complex. So now your xt is complex. So let's see what will be your C1, C of minus 1 or whatever it is. Let's see that. So what I will do, first target always to find out the value of omega naught. Here also omega naught is 2, here also omega naught is 2. So if I do the HCF, basically what I need to do, omega naught will be HCF of 2 and 2, because here the fundamental frequency is 2, here also fundamental frequency is 2. So HCF of 2 and 2 will be 2 only. So what is the value of omega naught? Omega naught will be 2. So how I can write my xt? Xt will be cos omega naught t plus j sin omega naught t. It can be written as e to the power j omega naught t plus e to the power minus j omega naught t divided by 2 plus e to the power, here multiply with j, e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j. Right? So j and j got cancelled. What you will get? E to the power j omega naught t divided by 2 plus e to the power minus j omega naught t divided by 2 plus e to the power j omega naught t divided by 2, j and j get cancelled, minus e to the power minus j omega naught t divided by 2. So what is happening here? This and this is getting cancelled. So what you are getting? E to the power j omega naught t. And which is very obvious, right? Cos omega naught t plus j sin omega naught t. What is that? E to the power j omega naught t only. There you go. What does that mean? C1 value is 1. What does that mean? From here, what do you see? C1 value is 1. What is the value of C of minus 1? That is 0. Only C1 is 1, right? What do I write down? Xt is equals to C naught plus C1 e to the power j omega naught t plus C of minus 1 e to the power minus j omega naught t plus C of 2 e to the power j2 omega naught t, and in that manner we keep on going. So here only C1 is non-zero, rest all are 0. So C1 is 1 and C of minus 1 is 0, rest all are 0, everything is 0. So is there any relation? Basically no relation between C1 and C of minus 1. So there is no relation between C1 and C of minus 1. So this was the thing we have proved. If xt is real, then Cn is equals to C of minus n conjugate. If xt is imaginary, then Cn equals to C of minus n conjugate multiply with minus 1. Basically another minus sign will come. But if xt is complex, then there is no relation between Cn and C of minus n. That's it. So no relation between, in place of writing Cn, here I will write down Cn and C of minus n. So if there is no relation, that means xt has to be complex. Say yes or no. Okay, let's find out the values of b1, a1, all these things. Okay, so here what we have seen, that my c1 is 0, sorry, c1 is 1 and c of minus 1 is 0. So what will be the value of a1? a1 will be c1 plus c of minus 1, that would be 1 plus 0, that would be equals to 1. So c1 is 1. What about b1? So what is b1? b1 is j into c1 minus c of minus 1. So j into, what is the value of c1? 1. minus 0 j. Oh sorry, why I am writing c1 here? This was a1, really sorry. a1 is 1, and what is the value of b1? b1 is j, right? And directly from here as well you can see what was your xt. Xt was cos omega naught t plus j sin omega naught t. So directly from here you can see multiply 1 was there, so this was your a1 and this was your b1. So a1 was 1 and b1 was j. If you are having the value of a1 and bn, then you can find out the value of c1 as well. What is c? Minus j bn by 2. So 1 minus j into j divided by 2. So c1 will be a1 minus j bn by 2, because what is cn? Cn is an minus j bn by 2, right? I hope you remember the expression. Cn is an minus j bn by 2. So if you are having cn, then you can find out this particular thing. So 1 plus 1, because j square is minus 1, so 1 plus 1. So c1 is equals to 1. And can you find out c of minus 1? Yes, because what is c of minus n? C of minus n is, or you can write down in this manner, an minus j b of minus n by 2. What is a of minus n? That is an only. What is b of minus n? That is plus j bn by 2. So c of minus n is an plus j bn by 2. So what is c of minus 1? a1 plus j b1 by 2. So what is a1? 1 plus j into what is b1? That is also j divided by 2. So 1 minus 1, that would be 0. So what is the value of c of minus 1? That is 0. So from here c of minus 1 also we found out. So n number of ways are there. I am just telling that if you find out one, you can find out another one. Are you getting this point? So in examination you can use any way. You just need to, I am not saying you need to remember the things. I am giving the little things to remember only. Only the little things. Okay. And by the end of this lecture I will try to write down the conclusion as well, that till now what all points you need to remember. Or you can see in the lecture itself, like I am giving you the slides. In every slide we are seeing that what all things we need to remember. There are only some little things which we need to remember. We started with, from here we started, like, right? From here we started trigonometric Fourier series coefficient. This was the trigonometric Fourier series. There we saw the expression of an and bn, right? An and bn. So this was the conclusion of trigonometric Fourier series coefficient. So this is an important slide. You can mark it out. From there a of minus n is equals to an and b of minus n is equals to minus bn. A and bn expression is there, dc value explanation is there, and xt can be written in this form. Then we go to exponential Fourier series. So this is also an important slide. Here also there are some formulas. An formula is there, bn formula is there. Although you don't need to mug it up, you can derive it in the examination hall very easily. Cn expression you can remember, 1 by t naught xt e to the power minus j omega naught t dt, right? Then from here cn and c of minus n came out to be, cn was an minus jbn by 2. So this should be there in your mind. Cn is an minus jbn by 2 and c of minus n is an plus jbn by 2. But cn equals to c conjugate minus n. That is always not true. So now we saw the questions. When we saw the questions, we got to know that cn is nothing but a sequence only. It is nothing but a sequence only. So c of n is a sequence only. Then this was just to prove that it is a sequence. Then what we saw here? What we saw that if xt is having, then only this slide is important. This slide is important now. If xt is having a Fourier series coefficient of cn, then x of minus t is having a Fourier series coefficient of minus cn. Then x conjugate t will have a Fourier series coefficient of c conjugate minus n. Now, one more thing you will let me know. What will be the Fourier series coefficient of alpha xt? Xt is multiplied with the constant value alpha xt. So that will be alpha xn. Sorry, alpha cn. Say yes or no? Basically, what was your cn? Cn was, not cn, I should not say cn. Your xt was n goes from minus infinity to infinity, cn e to the power j n omega naught t. Now if I, in place of xt, what I am putting, I am multiplying with alpha here. So here also it will be multiplied with alpha. So alpha is not a function of n, so it can go inside. So what is the new Fourier series coefficient? That is alpha cn. So if you multiply with the negative sign, then it will multiply with the negative sign. If you multiply with any constant value, then it will multiply with any constant value. So this also you can keep in mind, right? Fourier series coefficient will be alpha cn. Here Fourier series coefficient is minus cn. So this slide was important. Then this was just a basic revision. From here we go to know that this slide is important now. So only two to three slides are there which you need to revise. When you come to revision, only 2-3 slides should be revised. That's it. Rest all the job is done. From here, then we found out these things. Basically, xt is real. Again and again, we are writing on the same thing. What we are writing down, that these things are always true. These things are always true. But these are not always. This is not always true. That c of n is equals to c conjugate minus n. This is not always true. Okay. It is only true when xt is real, and when xt is imaginary, there is different relation. So if xt is real, then you can find out the relation in this manner. If xt is real, then you can find out the relation in this manner. And if xt is imaginary, then you can find out the relation in this manner. Right? Say yes or no. Okay. So these are the conclusion. Then we proved this particular thing. Nothing else. We proved this particular thing. How did we prove it? We just proved in a manner that if it is imaginary, then we can see that c1 is equals to c conjugate c of minus 1 conjugate, then another minus sign is required, and here no minus sign was required. Cn was equal to c conjugate minus n. So this we proved, and when it was complex, then there was no relation between Cn and c of minus n. So this is the conclusion till now. Say yes or no. Right? Now, important conclusion. What is the conclusion? That if xt is real, that means x of t is equals to x conjugate t. Right? That means xt is having a Fourier series coefficient of Cn, and x conjugate t is having a Fourier series coefficient of c conjugate. But if there is a conjugate, then negative sign will also come. So Cn is equals to c conjugate minus n. From here, what you can say, that Cn is conjugate symmetry. If xt is imaginary, if xt is imaginary, sorry. If xt is imaginary, then this is the thing. Say yes or no. If xt is imaginary, then xt is equals to minus of x conjugate t. Cn. If there is a negative sign, there is a negative sign. If conjugate, conjugate, but n will be replaced with minus n. So from here, what you can say, Cn is conjugate antisymmetry. Right? This we have already seen. N replaced with minus n, conjugate, and then minus sign is coming out. That means conjugate antisymmetry. If xt is complex, then let's remove it off. If xt is complex, that means no relation between Cn and c of minus n. So these are the important conclusions. Say yes or no. A very, very good point. Let's see more things. Special note. If xt is even, then what will happen? If xt is even, so x of minus t will be equals to xt. If xt is even, what is the Fourier series coefficient of x of minus t? That is c of minus n will be equals to Cn. So if xt is even, what does that mean? Cn is also even. And if xt is odd, x of minus t will be equals to minus of xt. Minus sign will come outward. Here it will eat up the negative sign. Here minus sign will come outward. So what I can see? C of minus n is equals to minus Cn. So if xt is even, then this is the relation. If xt is odd, then this is the relation. That means Cn is odd as well. C of minus n is equals to minus Cn. Basically, x of minus n is equals to minus of xn. What does that mean? This is a odd sequence. That means Cn is a odd sequence. Right? Here Cn is even sequence. Here Cn is odd sequence. Here it was conjugate symmetry sequence. Here it was conjugate antisymmetry sequence. Right? So usually people mug up that xt is even, then this is even sequence. Xt is odd, it is odd sequence. If xt is real, then it is conjugate symmetry. Xt is imaginary, then it is conjugate antisymmetry. But in the examination, I will ask these kind of questions. That comment on Fourier series coefficient if xt is real and even, xt is real and odd, imaginary and even, imaginary and odd. So try doing this on your own. We will take a pause and after that we will start. But it is very, very easy. If xt is real, then what all relation you are having? If xt is even, then what all relation you are having? Then try to find the relation between Cn and c of minus n. You will see something there. Okay? Try doing it on your own. A very, very good discussion it would be. Okay? So I will take a break and then I will come back. Very good points we will take out from here. Well and good? Okay. Yeah, welcome back. So let's see this question. Very, very interesting question and a very good conclusion we are going to make out of it. So first one, you need to comment on the Fourier series coefficient if xt is real and even. Okay. So xt is given as real. If xt is real, what does that mean? That xt would be equals to x conjugate t. Say yes or no. If xt is real, then xt would be equals to x conjugate t. Along with that, what is given? xt is even. What is the meaning of even? xt would be equals to x of minus t. This is the meaning of even. Now I am not doing anything with respect to Cn. Okay, till now what I have written, xt is real, xt is even. Now this xt can be replaced with x of minus t. Say yes or no? xt can be replaced with x of minus t. So here what I am doing, this xt is as it is, this xt I am replacing with x of minus t, x of minus t, and then conjugate is there as it is. xt I am replacing with x of minus t, and this conjugate is there as it is. What does this mean? Are you able to understand this point? xt as it is, this xt I am replacing with x of minus t. So xt equals to x conjugate minus t. What does this mean? This means that it is conjugate symmetry as well. So what is the first conclusion you have made? That if your xt is real and even, if your xt is real and even, then your xt will be conjugate symmetry as well. Then your xt will be conjugate symmetry as well. Say yes or no? So this is the first conclusion you have made. So if xt is given, then you will comment on xt only. First you have commented on xt that it is real, even and conjugate symmetry. Only this was given, real and even. Then you go to know that it is conjugate symmetry as well. It might happen that even and conjugate symmetry is given. In the question, xt is even and conjugate symmetry, and conjugate symmetry. If this was given, then what you would have done? xt is even, x of t would be equals to x of minus t. xt is conjugate symmetry, x of t would be equals to x conjugate minus t. From there what you would get to know, that what you can see here is that basically x conjugate minus t can be replaced with xt. So if I take conjugate on both of the side, x conjugate t will be, conjugate will get cancelled out. So x conjugate t is equals to x of minus t. So x of minus t can be replaced with x conjugate t. So what you will be getting, xt is equals to x conjugate t. That means if xt is even and conjugate symmetry, then xt will be real as well. So two information is given, third you can understand on your own. But this is not our target. Our target is to comment on Cn. I need to comment on Fourier series coefficient, that is Cn. But did you understand the first point? The first point is, two information will be given, you will get to know the third information. So now what you can write down? You go to know that xt is real, even and conjugate symmetry. So what do you mean by xt real? That xt equals to x conjugate t. So from here what did you get to know? What is the Fourier series coefficient of xt? That is Cn. What is the Fourier series coefficient of x conjugate t? That is c conjugate minus n. Say yes or no, right? xt is even, that means xt is equals to x of minus t. So from here what you are getting to know? That Cn is equals to c of minus n. And next thing, what do you know? xt is conjugate symmetry, that means x conjugate minus t. So what is the Fourier series coefficient of xt? That is Cn. What is the Fourier series coefficient of x conjugate minus t? So if there is conjugate, then conjugate will come. In place of n, minus n will come. But there is negative sign as well. T is multiplied with minus 1 as well. So minus n will be replaced with plus n. Say yes or no? Say yes or no? Right? So from here what did you get to know? That Cn is equals to c of c conjugate minus n. What does this mean? That means Cn is conjugate symmetry sequence. Cn is equals to c conjugate minus n. Xn is equals to x conjugate minus n. What does this mean? That it is conjugate symmetry. From here what did you get to know? X of n is equals to x of minus n. What does this mean? That means it is Cn is even. And from here what did you get to know? That Cn is equals to c conjugate n. Xn is equals to x conjugate n. What is the meaning of this? That means Cn is real as well. So what was given in the question? In the question what was given? It was given that xt is real and even. From here what conclusion we made? The first conclusion we made that xt is conjugate symmetry, and the second conclusion we made that Cn is real plus even plus conjugate symmetry. So only two information will be given, and from that you can make these kind of conclusions. Is that clear to you or not? Is this clear or not? Very easy it is. You don't need to mug up anything. In the examination, you will do this process and you will be able to write down every single thing there. Also, we will see the conclusion. After that, it will become more easy for you. Second one, xt is real and odd. So you will do it on your own. Okay, xt is real and odd. You have to do it on your own. The screen is lagging. I need to check the reason why it is lagging. So do it on your own. xt is real. So what is the meaning of real? That xt would be equals to x conjugate t. And what is the meaning of odd? That x of minus t would be equals to minus of xt. So here in place of xt, what you can replace? This minus sign can go here. So in place of xt, I can replace minus x minus t. So what I need to do from here, what I get to know, xt remains as it is. In place of xt, what I am putting? X conjugate minus t and then minus sign outward. So this was showing it is real. This was showing it is odd. Now what this is showing? In place of xt, what I have put? X of minus t and then minus sign. Conjugate remains as it is. Conjugate remains as it is. So what this is showing? This is your conjugate anti-symmetry. So if xt is real and odd, if your xt is real and odd, then your xt will be conjugate anti-symmetry as well. So till this point, we did not use Fourier series coefficient at all. We are just seeing the basics of signal. That if your xt is real and odd, then xt will be conjugate anti-symmetry as well. That's for sure. Now we will use the basics of signal here. What we are going to use? If it is real, that means xt would be equals to x conjugate t. If it is real, xt would be equals to x conjugate t. Now we are going to use Fourier series coefficient. So Cn will be equals to C conjugate minus n. Is that clear to you? Xt is odd. That means Cn would be equals to minus of minus Cn, and xt is conjugate anti-symmetry. Conjugate anti-symmetry. That means Cn would be equals to minus sign is there. If you take the conjugate, then n will be replaced with minus n, but minus t is also there. That means it will be plus n only. So from here, what did you get to know? What do you mean by this? C conjugate minus n. What does this mean? C conjugate minus n. That means it is conjugate symmetry. Say yes or no. What is the meaning of this? It will be odd. Basically, if you are not able to understand, x of n is equals to x conjugate minus n. So you did minus n as well and then you took the conjugate as well. What does this mean? This will be conjugate symmetry. And what is this? X of n will be equals to minus x minus n. Minus sign comes outward. It will be minus only, then x of n will be equals to x of n. What does this mean? That means it is odd. All this we have already seen. And what do you mean by this? X of n is equals to x conjugate n, but negative sign is coming outward. That means this will be imaginary. So what do you see from here? What was given? In the question, what was given? In the question, only two information were given. That your xt is real and odd. So from there, what did you get to know? That your xt is conjugate anti-symmetry. And from there, what did you get to know? That Cn will be imaginary, odd and conjugate symmetric. So this is the second conclusion we have made. Let's see the third one. In the third one, what they are saying? Xt is imaginary and even. Xt is imaginary and even. What is the meaning of imaginary? That xt would be equals to, if I take the conjugate, then there will be a negative sign. This is the meaning of imaginary. What is the meaning of even? X of minus t will be equals to xt. This is the meaning of even. So what I will do? Xt I will replace with x of minus t. So what I am getting? X of t is equals to x conjugate. Xt I will replace with x of minus t. X of minus t, and then there is a minus sign already. This minus sign remains there as it is. Xt is replaced with x of minus t. So upper side there is conjugate. So what do you understand from here? This was imaginary. What is the meaning of this one? This is even, and what this is coming out to be? Conjugate anti-symmetry, right? Because you are taking the minus sign, then you are doing the conjugate, and then minus sign is also coming outward. That means it is conjugate anti-symmetry. So what was given? Xt is imaginary and even. From there, what did you get to know? That it is conjugate symmetry as well. So what is the scene? It was given that xt is imaginary and even. So from there, what did you get to know? That xt is conjugate anti-symmetry as well. Say yes or no. Let's do the things now. Now we need to comment on xt is equals to minus of x conjugate t. This is the meaning xt is imaginary. So if xt is imaginary, then minus sign is there, conjugate n is replaced with minus n. Second one, xt is even. So xt is equals to x of minus t. So cn is equals to c of minus n. And next one, xt is conjugate anti-symmetry. Conjugate anti-symmetry. So minus sign will come outward. cn minus c conjugate minus t will be replacing minus n with another minus n. So this will be the scene. I hope you are comfortable with all these things. What will be the Fourier series coefficient of x conjugate minus t? That would be c conjugate n. So all these things you are already comfortable because we have seen it again and again. So from here, what conclusion you can make? That means it is conjugate anti-symmetry. Say yes or no. Because x of n is equals to x conjugate n is replaced with minus n, then another negative sign is coming outward. So what does this show? This is conjugate anti-symmetry. What does this show? That it is even, because x of n is equals to x of minus n. That means it is even. And what does this show? What does this show? X of n is equals to minus of x conjugate n. That means it is imaginary, right? So what did we get to know? That your xt was, what was given? It was even and imaginary. From there, what did we get to know? That your xt is conjugate symmetric. Sorry, xt is conjugate anti-symmetry, really sorry. Xt is conjugate anti-symmetry. And what comment we made on c of n? That c of n is even, imaginary and conjugate anti-symmetry. Say yes or no. So nothing you need to mug up. There is a process, that process you need to follow and you are getting the answer, nothing else. D. Xt is imaginary plus odd. So I need to add a page. Xt is imaginary plus odd. So what is the meaning of imaginary? Xt will be equals to x conjugate t, but there will be a negative sign. So cn will be equals to, oh sorry, first we are not talking about cn. Xt is imaginary. Along with that, xt is odd as well. What is the meaning of odd? That there will be a negative sign, but minus will come outward. So xt will be replaced with x conjugate minus t, and minus minus will be plus. So from here, what you are getting? Xt as it is. Now this xt will be replaced with x of minus t, and then there is a negative sign. So minus minus will become plus. That would be equals to x conjugate of minus t. So this was imaginary, right? This was odd. Now what is this? X conjugate minus t. What does this mean? This will be conjugate symmetry, right? So what you have got? What was given? Xt is imaginary plus odd. Xt was given as imaginary plus odd. From there, what conclusion did you make? That xt is conjugate symmetry. This is the conclusion that you have made. Let's try out the things now. What we need to do? Xt is imaginary, that means if you take the conjugate, then negative sign will come out. Xt is odd, that means if you take the negative sign, then another negative sign will come out. And xt is conjugate symmetry. First you take the conjugate and then replace with minus t, no negative sign will come out. C of n will be equals to minus of c conjugate n will be replaced with minus n. C of n will be equals to minus c of minus n. And C of n will be replaced with c conjugate n. What is the meaning of this? What is the meaning of this? And what is the meaning of this? What is the meaning of this? Xn is equals to x conjugate n. What is the meaning of this? This is real. What is the meaning of this? It is odd, right? This is real, this is odd, because xn is equals to x of minus n, and then there is a minus sign. That means it is odd. And what is the meaning of this? This is your conjugate anti-symmetry, because first you replace n with minus n, then you took the conjugate and another minus sign is coming outward. That means it is conjugate anti-symmetry. So what did you get to know? that xt is imaginary plus odd, then from there you go to know that your xt is conjugate symmetry, and from there what is the conclusion that you made on Cn, that your Cn is conjugate anti-symmetry, or here I should write your Cn is real plus odd plus conjugate anti-symmetry. This is the conclusion we made. There you go. And last one, if xt is complex, then no relation. We cannot comment anything, that's it. No comments. If xt is complex, then you cannot comment anything. Basically, if this is the scene E, then there is no comment, no relation. Because if xt is complex, you cannot write x equals to x conjugate t or minus t, nothing you can write down. So no relation would be there, that's it. Well and good. So in that manner, any kind of relation will be given in the examination hall. Statement wise question will be there. Will you be able to comment? It is a very, very tough topic for a lot of students because they try to mug it up. Although no one will tell you that it will be conjugate symmetry, all these things, but always people will try to mug it up. But do you have the concept clear in your mind? What you need to remember, that if xt is having a Fourier series coefficient of Cn, then what will be the Fourier series coefficient of x of minus t? That would be c of minus n. And what would be the Fourier series coefficient of x conjugate t? That would be c conjugate n will be replaced with minus n. Now if I ask you what will be the Fourier series coefficient of x conjugate minus t, then c conjugate as it is, n is already replaced with minus n, but because of minus t, another minus n would come. So minus minus will become plus. That means it will be c conjugate n. So all these things you need to remember, and if you just remember these things, your job is done. Do you know what is the meaning of xt real? Yes. If it is real and even, I got to know that my xt is coming out to be conjugate symmetric as well. If it is coming out to be conjugate symmetry as well, then three things I am given. From there I can conclude that this is telling it is conjugate symmetry, this is telling it is even, and this is telling it is real. So this is the conclusion I have made. Same for the second one, same for the third one, and same for the fourth one as well. And if it is complex, then there is no relation. This is the table. If xt is real and even, then your also xt came out to be conjugate symmetry. And one thing I have also told, they can give these two as well, that even plus conjugate symmetry, then you will get to know that xt is real, right? If it was real plus odd, then it was conjugate anti-symmetry. If it was imaginary plus even, then it was conjugate anti-symmetry. And if it is imaginary plus odd, then it was conjugate symmetry. Now in the examination, what may happen? They have given imaginary and conjugate symmetry. What they have given? That xt is imaginary plus conjugate symmetry. What you will do? Xt is imaginary. Xt is equals to x conjugate t, but minus sign. What is the meaning of conjugate symmetry? Xt, x conjugate minus t, and then minus sign. Now what you need to do? What I need to do is that I can replace my xt with x conjugate minus t. So what I can do? Here. So x conjugate minus t, then already there is a minus sign, and xt I am replacing with minus of x conjugate minus t. Are you able to understand this? Minus sign is already there, xt is replaced with x conjugate minus t, and then minus sign is already there, and then another conjugate you take. So minus minus will be plus, minus minus will be plus, and conjugate will cancel out each other. Basically 3j, if you take the conjugate of this, what you will get? Minus 3j. Then another you take the conjugate, what you will get? Again 3j. So conjugate will get cancelled out. Minus sign is also getting cancelled out. What you are getting? X of minus t. So this is the relation I am getting. So if xt is imaginary plus conjugate symmetry, that means xt is even as well. Imaginary plus conjugate anti-symmetry, then xt is even as well. So here it is conjugate anti-symmetry. Really sorry. Here I have written conjugate anti-symmetry. This is the property of conjugate anti-symmetry. So if your xt is imaginary plus conjugate anti-symmetry, then it is coming out to be even as well. Are you able to understand the point? This is just mathematics, nothing else. That's why we are moving a bit faster here. Any two relation could be given, you can get to know the third relation just by following the basic mathematics. Let me show you again one more example. Okay, so it will be more clear to you. What information is given? Let's just say real and conjugate anti-symmetry. This is given. xt is real and conjugate anti-symmetry. So what you will do? Xt is real. So xt equals to x conjugate t. And xt is conjugate anti-symmetry. Conjugate anti-symmetry. Say yes or no. Right? So now what I need to do, what I can see is that xt can be replaced with x conjugate minus t and then minus sign. So xt will be, now this xt, what this is written, xt conjugate, this relation can be written like this, say yes or no. Now xt can be replaced with minus of x conjugate t conjugate. There will be no impact on the minus sign, so this I can take outward, x conjugate t and then another conjugate. 2 conjugate means both will cancel out. So what you are getting, okay, here there is minus sign, sorry, xt is equals to x conjugate minus t, so here minus sign is there. So what you are getting, x of t is equals to minus of x of minus t, this is what you are getting, x of t is equals to minus of minus, xt is equals to minus of x of minus, xt is equals to minus x minus t, this is what you are getting, that means it is odd. So yes, if xt is real and conjugate antisymmetry, that means xt is odd as well. So two relation would be given, you can find out the third relation, very easily you can find out the third relation. Conjugate will cancel out each other, minus sign will have no impact, that can come outward. So all these things you already know, right? So now it is all clear. Now from all these, what kind of conclusion we have made? That if xt is real and even, and then it will be conjugate symmetry as well, then this will also be real plus even plus conjugate symmetry. What about this one? It will be imaginary, plus odd plus conjugate symmetry. What about this one? It will be imaginary plus even plus conjugate antisymmetry. And what about this one? It will be real plus odd plus conjugate antisymmetry. Okay, so these are the conclusion. How did I write it? Very quickly. Deciding factor is even or odd. What I am saying? Deciding factor is even slash odd. This you need to remember. How you can remember? DOE, date of end. This is how you can remember that deciding is even or odd. Deciding factor is odd or even. Date of end. Okay, this is how you can remember that deciding factor is even or odd. What do you mean by deciding factor? If even is coming, then nothing will change. Real plus even plus conjugate symmetry, real plus even plus conjugate symmetry. If odd is coming, then everything will be opposite. Real plus odd plus conjugate antisymmetry. So odd will say that I am deciding, so I will come as it is. But real will be changed to imaginary, conjugate antisymmetry will change to conjugate symmetry. Even. So even will say I will come as it is, I will not change anything else as well. Imaginary plus conjugate antisymmetry. What odd will say? That I will come as it is, but I will change imaginary to real and conjugate symmetry to conjugate antisymmetry. Say yes or no. Will you be able to keep this thing in mind? Will you be able to answer in the examination hall? Although if you forget all these tricks, nothing is there in your mind, you forgot all the tricks, everything, then you can follow this process. No, it is not that tough. It is very easy. That's why I gave you the derivation. Otherwise, like, they will apply very complex mathematics and they will find out this table and people will mug up. People will mug up this table. But we have derived it with a good amount of brain, not with mathematics. Here we used our brain, right? If it is real and odd, then these are the relation we can get, and another relation we can get, that is conjugate antisymmetry. Okay, and from there, if I am having the three relation, then I can make out three output as well. That with respect to Cn as well, I can tell three different things. Is that clear to you or not? And this also very easily I can tell. Look, what I say is that real is a good guy. Okay, someone is real and someone is even. This is also a good guy. Okay, and imaginary is a bad guy, and odd is also a bad guy. Like, do you have any picture in mind? Like, whenever we see even 2, 4, 6, 8, we feel happy, right? 2, 4, 6, 8, whenever we see even number, because it will be divided by 2. But whenever we see odd, 1, 3, 5, 7, no, not happy. So odd is a bad guy, even is a good guy. What about real signal? If you deal real signal, you will be happy. 5t, 60, 70, or xt equals to sin t, sin 5 pi t, cos t. But if you see imaginary signal, imaginary j sin pi t, needlessly j word is coming. Needlessly j is coming, right? J sin t, j to t. So whenever you see imaginary, that will be a bad guy. If someone is real, in this gate industry, every educator will say that he is a real, but no one is actually real. If someday I come on YouTube and say that I am the real educator, then I am telling a lie. In this field, you are an aspirant, but I should not drag you into all these things. But let me tell you guys, no educator is real in this field. I used to think when I was a student that people are real here, but they are not real. Okay, this industry is not that good that it look like. Okay, so no one is real. Even I also never ever say that I am real. My students will say that, right? My students will tell whether I am a real teacher or not. So that depends on my student, not on me. Okay, so I never ever say that I teach the best, I am this thing, I am that thing. My students will tell that, right? So yeah, if someone is real, he is a good guy. If someone is imaginary, he is a bad guy. So good guy plus good guy will give you conjugate symmetry. So what do you think? Conjugate symmetry is there, and conjugate anti-symmetry is not there. So this will also be a good guy, and this will be a bad guy, right? Symmetry is there, and here anti-symmetry. So good guy plus good guy will make good guy. Good guy plus bad guy will make bad guy. Bad guy plus good guy will make bad guy. Just think, two good people are there. They will certainly make good people only. But if there is one bad person, he will generate bad person only. Because bad plus good. So if a bad plus good combination, you will see always the good guy will remain silent. Bad guy will say so much. So what does that mean? That it will generate a bad guy only. Here, bad guy plus good guy, bad guy. Bad and bad, both are bad. Certainly they will generate something good. Because here everything is negative, no? So negative into negative becomes positive. So if two bad guys are there, certainly they will generate good guy. It's like plus minus. Plus into plus will be plus. Plus into minus will be minus. Minus into plus will be minus. And minus into minus will be plus. So it's like a multiplication. So real plus even, both are good guy. It will generate good guy only. So real plus even will be conjugate symmetry. Real plus odd will be conjugate anti-symmetry. Imaginary plus even, conjugate anti-symmetry. Imaginary plus odd, conjugate symmetry. And if you know all these things, then who will be the deciding factor? Even will be the deciding factor. Okay. And then if even is there, it will change nothing. If odd is there, odd will say that I am the deciding guy, so I will remain as it is, but I will change other guys. Are you getting this point? Now it's not necessary that they will ask from here to here only. It is not necessary that they will ask from here to here, that xt is given and then they ask cn. No, cn is given and then they ask xt as well. Are you able to understand this point? What do I mean by that? This kind of questions can come. That cn is even plus imaginary, or let me write down even plus conjugate anti-symmetry. Even plus conjugate anti-symmetry. Then comment on xt. So what is the one way in the examination, or what you will do? Okay, sir, cn is even. Cn is even. Cn is even. Cn is conjugate anti-symmetry. Cn is conjugate anti-symmetry. These two things I can write down. Now c of minus n can be replaced with cn. So from here what I can see? C of minus n can be replaced with cn. So from here what did you get to know? That your cn is imaginary. What this was? Conjugate anti-symmetry. And what this was? Even. What you can see? This is a good guy. This was a bad guy. Good guy plus bad guy. What did they make? Bad guy. Imaginary is a bad guy. Odd is a bad guy. Conjugate anti-symmetry is a bad guy. So good guy plus bad guy made bad guy only. Right? Now you know all these things, that c of n is equals to, what you know? C of n is equals to c of minus n. So c of n is the Fourier series coefficient of xt, and c of minus n is the Fourier series coefficient of x of minus t. Next, what do you know? C minus n conjugate minus sign. So c of n is the conjugate of, c of n is the Fourier series coefficient of xt, and c minus n conjugate, minus sign as it is, c minus n conjugate is the Fourier series coefficient of x conjugate t. Because if you take the conjugate then minus sign also come, and then there is already a minus sign, right? And next, C of n is equals to minus Cn conjugate symmetry. So from here what you will see, xt, then this will be x conjugate minus t, and then there is a minus sign. Did you understand this point? X conjugate minus t, C conjugate n is replaced with minus n because of minus t, again it will be n. So C of n is equals to minus of C conjugate n. So from here all these things we can make. So what did we get to know? What does this mean? Even. What does this mean? What does this mean? Imaginary. And what does this mean? Conjugate antisymmetry. So if your xt was even plus conjugate antisymmetry, then what did you get to know? That my xt is imaginary as well. My xt is imaginary as well. And if even is there, what even will say? That I will not change anything. That means your xt will also be, here your cn was even plus conjugate antisymmetry. But if you see even will say that I will not change anything. So even plus conjugate antisymmetry plus imaginary. That's it. This is the answer. So without even doing all this process in the examination hall, I could have directly told the answer. But I will directly tell the answer only if I am not having time. Let's just say in the examination hall, I am in a hurry. Then only I will tell the answer directly. Otherwise, I will do the process. Process will not take me much time. And if I follow the process, I will be much comfortable in the examination hall. Say yes or no. So looking at Cn, you can comment on xt. Looking at xt, you can comment on Cn. So every single thing is clear, right? You can go from here to here in the table or from opposite to here as well. Randomly, if I ask you, Cn is imaginary plus odd, comment on xt. Comment on xt. So what do you see? Bad guy. Imaginary is a bad guy. What do you see? Bad guy. So bad guy will make good guy. That means it will be conjugate symmetry as well. If there is odd, what odd will do? That sir, I will come as it is, but I will change imaginary to real and conjugate symmetry to conjugate antisymmetry. So if your Cn was imaginary plus odd, then your xt was odd plus real plus conjugate antisymmetry. You can check as well. Cn was imaginary plus odd, then it was conjugate symmetry as well, and your xt was real plus odd plus conjugate antisymmetry. Say yes or no. In that manner, will you be able to tell in the examination hall? It might happen that you follow all this table. It might happen you forgot everything, but you will never forget the concept. So there should be equilibrium. In the concept and in the trick, there should be a equilibrium. There would be some people who will be just focusing on concept, some people will be just focusing on the trick, and both of the things alone will never work in the examination hall. But our platform, PrepFusion, the best platform to prepare for GATE EC examination, you also admit that particular thing, and on the best platform we make sure that there is an equilibrium between concept, trick and problem solving. So that's why you are studying from us, right? And you are lucky enough to study from PrepFusion. So comment down how did you like this concept, and we will proceed with more concept, and certainly we are going to see a lot of good concept in Fourier series. I hope you are building up your interest in this particular chapter, which felt like a formula based chapter, but actually it is not a formula based chapter. Here we are just learning minimum number of things, and whatever that you need to learn, that also we are learning with good amount of tricks and good amount of concept as well. Well and good, let's meet in the next lecture. Thank you very much. In the next lecture, we will continue this part only. Okay, we will solve some problems. Yeah, thank you. Hi everyone, welcome back. So in the last lecture, we were studying about Fourier series coefficient, exponential Fourier series coefficient. So we were commenting on Cn, right? We were commenting on this Cn, that if xt is real, xt is odd, if xt is conjugate symmetry, then what would be the nature of Cn? And if Cn is imaginary, Cn is odd, Cn is even, Cn is conjugate symmetry, then what would be the nature of xt? So that particular thing we have already seen, right? Now we need to see the questions, that how the questions can be asked. So this is the question from OpenM only. So they have given three different questions are there. x1t is given, x2t is given, x3t is given. You need to comment on x1t, x2t and x3t. This is the question, okay? We need to comment on x1t, x2t and x3t. We need to tell whether they are real or imaginary, even or odd, or neither even nor odd, okay? Real, imaginary, complex also could be the possible option. So let's see the first question. In the first question, what they are saying, your x1t is represented as, n is going from Here they have mentioned k. In the examination, k could be there, m could be there, p could be there, alpha could be there, it could be anything. We have studied by n. So I am replacing k with n. So n is going from 0 to infinity. 1 by 2 to the power n e to the power j n omega naught t, where omega naught value is 2 pi by 50. Right? We need to comment on the nature of xt. That means what is the matter of concern here? The matter of concern is Cn, right? This is my Cn. So what is my matter of concern? Matter of concern is Cn, which is 1 by 2 to the power n. But very important thing, what is the important thing? That it is there for n going from 0 to 100 only. N going from 0 to 100. If n is negative, otherwise it will be 0. What do you understand by that? That what is the value of C0? 1 by 2 to the power 0, that means 1. DC value is 1. What is the value of C1? Value of C1 is 1 by 2. What is the value of C2? That is 1 by 2 square. In that manner. But what is the value of C of minus 1? That is 0. Right? Because here n is going from 0 to 100. It is not going from minus infinity to infinity, or it is not going from minus 100 to 100. It is only going from 0 to 100. That means C of minus 1 is 0. C of minus 2 is also 0. Same goes for C of minus 3. So from here, can you find any relation between C of n and C of minus n? This can be written as C of n, right? And this can be written as C of minus n. Is there any relation between C of n and C of minus n? Basically, are both of them equal? No. Because one is 1 by 2, other one is 0. Or this is the scene. Because if this was the scene, we could have said that it is even. If this was the scene, we could have said that it is odd. But it is neither even nor odd. So first conclusion, neither even nor odd. What we were doing, we just need to analyze our Cn. We got to know that Cn is there from 0 to infinity only. Cn is non-zero, so from 0 to 100 only, not infinity, from 0 to 100 only. That means negative value of Cn is not even existing. C of minus, it is existing, but it is 0. So C of minus 1, C of minus 2, C of minus 3, all these values are 0. What does that mean? That means Cn is neither even nor odd. What does that mean? That xt is neither even nor odd. From here, what I would say, that my xt is neither even nor odd. Why is that so? Because from here I have made the conclusion that Cn is neither even nor odd. That means xt is neither even nor odd, right? Because what you have studied, that if xt is even, then your Cn is also even, right? And if xt is odd, then your Cn is also odd. And if your xt is neither even nor odd, then your Cn is also neither even nor odd. But here we have analyzed Cn, we got to know that it is neither even nor odd, that means xt is also neither even nor odd. Now let's see the conjugate. So can you find any relation in the conjugate? Basically, can you write down in this manner that C of n is equals to C of minus n conjugate? Can you write down in this manner? Because if I could have written down in this manner, then what I could have said, that xt is equals to x conjugate t. Because what is the Fourier series coefficient of x conjugate t? That is C conjugate minus n. So if I could have written this particular thing, then I could have said that xt is equals to x conjugate t, and from here I could have said that xt is real. But can I write it down? No. Because what is my Cn? What is my C1? That is 1 by 2. What would be my C of minus 1 conjugate? 0 conjugate will be 0 only. Are both of them equal? No. Can I say C of n is equals to C of n conjugate? If I had said this particular thing, that C of n is equals to C of n conjugate, then what I could have written? Basically, not C of n conjugate. Here I should have written C of minus n conjugate and then minus sign. So if I could have said this particular thing, then I could have written that xt is equals to minus of x conjugate t. And what does that mean? That it would be imaginary. But no, this is also not true, this is also not true. Why is that so? Because what will be the value of minus of C of minus 1 conjugate? That would also be 0, because minus 0 is 0 only. So both of them are not equal. and these two also are not equal. These two also are not equal. This is also not equal. Here also these two are also not equal. Nothing is working basically. So you cannot say it is, neither it is imaginary, neither it is purely real. So neither it is purely real, neither it is purely imaginary. What does that mean? That means xt is complex. So xt is complex and neither even no road. So did you understand how to analyze these kind of questions? First you will see C of n. Then on C of n you will do the operations. That C of n is equals to C of minus n, or C of n is equals to minus of C of minus n. Nothing is working. Okay. Then we got to know that it is neither even nor odd. Then I will come to conjugate. I will take the conjugate. I will take the conjugate of C of minus n. So when I take the conjugate of C of minus n conjugate, when I take, if both of them were equal, I would have said that it is real. But no, it is not even coming out to be real. Then I checked what if it is equals to the negative of C of minus 1 conjugate. Then it is not even equals to the negative of C of minus 1 conjugate. That means it is neither purely imaginary. What does that mean? It has to be complex. So this is how we are going to solve the problems. Okay. Let's take the second one. In the B, what is given? In B, C of n is given as cos n pi. Directly I will see C of n. C of n is given as cos n pi. The important part is here n is going from minus infinity to infinity. If I write down my xt, where my n is going from, not minus infinity, sorry, minus 100 to 100. N is going from minus 100 to 100. Cos n pi e to the power j n omega naught t. Cos n pi e to the power j n omega naught t, where omega naught is 2 pi by 50. What is the value of Cn here? Cn is equals to cos n pi, right? And it is there for n going from minus 100 to 100, and otherwise it is 0. So here if I write down C of 0, that is 1 only. If I write down C of 1, what that would be? Cos pi. If I write down C of 2, what that would be? Cos 2 pi. In that manner, if I write down C of 100, what that would be? Cos of 100 pi. Similar manner, I can define C of minus 1 as well. So cos of minus pi, cos of minus pi, what that is equivalent to? Cos of pi only. Here, cos of minus 2 pi. So that would also be equal to cos 2 pi. In the similar manner, okay, C of minus 1, C of minus 2, C of minus 100. So C of minus 100 would also be equal to cos of pi only. So from here, what do you see? C of n is equals to C of minus n. This is what we can see. C of n is equals to C of minus n. But now someone will say that, sir, you checked at 100 only. What if I check at 101? What is the value of C101? 0 only. Because it is non-zero between minus 100 to 100, otherwise it is 0. So C101 is 0. And what is the value of C minus 101? That is also 0. So from here also what you can say? That C101 is equals to C minus 101. From here what you can say? C1 is equals to C of minus 1. From here what you can say? C2 is equals to C of minus 2. From here what you can say? C of 100 is equals to C of minus 100. So always it should be followed. If it is always followed, and what about 0? Sir, what about 0? C of 0 is 1. So if I put 0 here, so C of 0 is equals to C of minus 0. What is the meaning of minus 0? Minus 0 means 0 only. So C of 0 is equals to C of 0. Yes, it will always be 0. C of 0 will always be equals to C of 0. So what does that mean? That apparently C of n is equals to C of minus of n is proved here. But here, if in place of minus 100, if I had put 0 only, then there would have been an issue. In place of minus 100, if I have put that n is going from 0 to 100, then you could not write this particular thing. No matter whatever the value of cos n pi is there. What some people will do, some people will say that, sir, directly I could have put, in place of n, I could have put minus n, then it would come out to be cos n pi. Yes, this is even. My job is done. No. Always check from where to where it is going. If it was going from 0 to 100, then there would be issue. Because your C of 1 would be cos pi, but your C of minus 1 would be 0. And there you could not write this particular thing. then you could not have said that C of n is even. So here what I can say, that my C of n is equals to C of minus n. That means my xt is equals to x of minus t. And from there I can say that my xt is even. Say yes or no. So this is the first conclusion I have made. But are you able to understand the point that there should be symmetric? Okay, there should be symmetry, that C of minus 1 should be equals to C of 1, C of minus 2 should be equals to C of 2. What if here in place of 100 I would have written 101? In place of 100 I would have written 101. Then also you could not have said that xt is even. Why is that so? Because what would be the value of C101? That would be cos 101 pi. And what would be the value of C minus 101? That would be 0. Are both of them equal? No. That means you cannot write that C of n is always equals to C of minus n. Here it is equal. Here also it is equal. But always it has to be equal. And always you cannot write. That means you cannot say that it is even. Are you able to understand this point or not? So always check as all the values. This limit is very, very important. This limit is very, very important. Okay. So luckily in this particular question, the limit was given from minus 100 to 100. But when I frame the question in test series, I will always trouble you. Right? In the test series, I will do these kind of things. That this will be an even function. This will be an even sequence. Cos n pi is an even sequence. But for defining xt, if my n is going from minus 50 to 100, let's just say it is going from minus 50 to 100, that means n equals to minus 51. C of minus 51 will throw 0, but C of 51 will throw cos 51 pi. So both of them are not equal. And if both of them are not equal, then you cannot comment that C of n is equal to C of minus n. So a very, very important thing, in test series you will find these kind of questions. Okay. So always take care of such things. So here I am putting the star mark, that this part is important. The limit is important. So as of now our xt is even. What next we need to check? We need to check the conjugate. So can I write down this particular thing, that C of 1 is equals to C of minus 1 conjugate? Because here what I can see is that C of n is real. What is C of n? C of n is real. So C of n is equals to C of minus 1 conjugate. C of 2 is equals to C of minus 2 conjugate. In the same manner, C of 100 is equals to C of minus 100 conjugate. That means these values are real only, no? Cos 100 pi will be real. Whatever the value is, but it would be real. It cannot be imaginary. There is no j here. So it cannot be imaginary. So these values will be real. And if you take the conjugate of real, that would be same as that particular value only. And here also you have concluded that C of n is equals to C of minus n. Basically you can take conjugate on both of the sides. What I have concluded, that C of n is equals to C of minus n. Can I take conjugate on both of the sides? Yes. What will be C of n conjugate? C of n only. C of n conjugate will be C of n only. There you go. And from there what I can conclude, that x of t is equals to x conjugate t. What does that mean? That means xt is real. But what if I had changed the limit from minus 50 to 100? So there what would have been the scene, that C of minus 50 to 100 I am talking about, right? So C of 51 would have been cos 51 pi, and C of minus 51 would have been 0. So can you write down that C of 51 is equals to C of minus 51 conjugate? No. C of n is equals to C of minus n conjugate? No. So there you cannot comment that xt is real. It will neither be real, it will neither be imaginary, it will be complex. So the answer would have been neither even nor odd and complex. But as of now, we can write down these things. As of now, we can say that xt is real as well. So from here, what is the conclusion that we have made? That your xt is real and even. And we started with Cn because our Cn was also real and even. But the important learning from this particular question is that always see the limit from where to where it is going. Just by looking at this Cn, you are not going to comment anything. Always see the limit, whether there is symmetry or not. C of n and C of minus n, both should be non-zero, then only you will be able to comment. Say yes or no. And always check the DC value as well. Basically, if I am writing C of n is equals to C of minus n, so always I will check the DC value as well. What do I mean by that? That C of 0 is equals to C of minus 0 conjugate. Is that true? What is C of 0? C of 0 is 1. What is C of minus 0? C of minus 0 is equal to C of 0 only. That is 1 only. So 1 is equal to 1 conjugate. What is the conjugate of 1? That is 1 only. So 1 equals to 1. Yeah. So this is also satisfied. So always after writing down the conclusion, always I will check at C of 0 as well. Because if C of 0 is creating some problem for you, then everything can be destroyed. These kind of examples we will see where everything else will be followed. Everything else will be followed, but C of 0 will create some problem. So always check at C of 0 as well. Always check at C of 0. So are you able to understand how to proceed in these kind of questions? Like you have the concept, now we are just learning the problem solving skills, that how to solve the problems in the examination hall. That we are learning now. So last question you will try on your own. Go step by step. We just need to avoid minor mistake. What people does is that they will check half information and then they will say that sir exam mein minor mistake ho gaya. We did minor mistake in the examination hall. So there is nothing called minor mistake. The problem is that you don't have problem solving skills. You understand the concept, you have the concept, but you don't know how to apply it. So this is how we should be checking all the things, and this is how we should be learning the subject. Next, x3t minus 100 to 100 n pi by 2 and the same thing. Here also there is symmetry. Omega naught is 2 pi by 50. Although these are not a matter of concern, omega naught and all these things. From here what I can see, that my C of n is j sin pi by 2, n pi by 2. But it is therefore minus 100 to 100, otherwise it is 0. So again there is symmetry, so I can be happy now. Why I can be happy? Because there is symmetry. That means if C of 1 is non-zero, then C of minus 1 will also be non-zero. So these things are there. Okay. So let's check. First I will check at C of 0. C of 0 will be 0 because anything in the sign will be 0 only. If in the sign you are putting 0, then sin 0 will be 0. What will be C of 1? J sin pi by 2. What will be C of 2? J sin pi. And what will be your C of 100? J sin 100 pi. Now you will say that sir this value is equal to 0. Yes, this is 0. No issue. What will be your C of minus 1? C of minus 1 will be j sin minus pi by 2. Sin has the ability of taking out the negative sign. So minus j sin pi by 2. What will be your C of 2? C of 2 will be j sin minus pi. Sin has the ability of taking out the negative sign. So j sin pi. Sin pi is 0 only. So this is 0. C of minus 100. Although this is also equal to 0, but this is not our target. Our target is not to make anything 0. Our target is to see something that a minus sign is getting out. So I hope people are making the conclusion now. From here what I can see, what would be my C of minus 0? That would be equal to C of 0 only, that is equal to 0 only. So from here can people make the conclusion that C of n is equal to minus of C of minus n. Check at every value. Wherever it is becoming 0, 0 is equal to minus 0. Is that true? Yes, because minus 0 is equal to 0 only. So this is also true. Basically, the problem can happen with the DC. So I checked the DC. C of 0 is equal to minus C of minus 0. If I put 0 here, so C of 0 is 0. Minus C of minus 0 is 0. So 0 is equal to 0. Yeah. 0 is equal to 0. So 0 will never create any problem. That's for sure. Because 0 plus 0, everything is same only. 0 conjugate, minus 0 conjugate, everything is same. So 0 will never create any problem. This will also not create any problem. Here it is C of minus 2. So C of minus 2 is equal to minus of C2. This is also true. So from here what I can see, and here also you can see that minus sign is getting out. So from here I can see that x of t is equal to minus of minus xt. What does that mean? That your xt is odd. First one down. What about the second one? Xt is odd. What about the second one? Conjugate. if you see this one, can I write down C of 1 is equals to C of minus 1 conjugate? Because if you take the conjugate of this particular thing, then j will be replaced with minus j, and minus minus will become plus, that will be equals to C of 1 conjugate. Can you write down C of 2 is equals to C of minus 2 conjugate? Yes, surely I can write down. C of 2 is equals to C of minus 2 conjugate. 0 conjugate will be 0 only. That would be equals to 0. And can you write down C of 0 is equals to C of minus 0 conjugate? C of minus 0 is also 0. 0 conjugate will be 0 only. Yes, that also I can write down. So from here, what you concluded? That my C of minus 1 conjugate if I take, then plus j will be replaced with the minus j. So that will be equals to C of 1. So from here can I conclude that my xt is equals to x conjugate t. Or from here what I can conclude, that my C of n is equals to C of minus n conjugate. C of n is equals to C of minus n conjugate. And when we solve it, what do we get? Xt is equals to, what is the Fourier series coefficient of x conjugate t? So there will be a conjugate sign and will be replaced with a minus n. So yeah, from here this is what we can conclude. So from here what we get to know, that my xt is real, right? So what we understood, xt is real and odd, right? Because our Cn was, what was our Cn? Because our Cn was imaginary, right? Cn was imaginary, and it was odd as well. Because if you take minus sign, if you place n with minus sign, what will happen? Minus sign will come out. So it was odd as well. So what is the job of odd? Odd will say that I will come as it is, but I will change the other guy. Imaginary will be changed to real. Okay, so imaginary will be changed to real. So that's it. So Cn was imaginary and odd, so my xt was real and odd. But by only looking at this particular thing, I will never decide. I need to see the limit as well. Always see the limit as well. Now you are saying that, sir, you are not writing conjugate symmetry, anti-symmetry. So that also you can write down. So real and even, good guy, good guy. Real is a good guy, even is a good guy. This will make conjugate symmetry. So here also, if it is even, then again this will also be conjugate symmetry. What about this one? Imaginary and odd. Imaginary bad guy, odd is also a bad guy. Bad guy will make good guy. So this will also make conjugate symmetry. But what is the job of odd? The job of odd is that it will change everything. So this will make conjugate antisymmetry. So x of t will be real, odd and conjugate antisymmetry, while C of n was imaginary, conjugate symmetry and odd. So if they give you anything, you have the capability of telling the nature of xt and cn in all three formats: real, odd, conjugate symmetry, imaginary, even, conjugate antisymmetry. All these kind of things you will be able to tell. Say yes or no. So it is a very important concept and a very good concept which are skipped at a lot of places. So usually as an aspirant we should never skip these kind of topics, because if I am a teacher, if I need to frame a good question on Fourier series, then I will frame the question from this particular topic. Because most of the people, what they will do is that they will try finding x of t. From these expressions they will try finding x of t, and from there they will make the conclusion. And in the examination hall, if you do these kind of calculation, then certainly you will take on something wrong. So build your problem solving skills in that manner that you are able to do well in the examination hall, not just during the lecture. In the examination hall as well, you need to do the things, and that is the most important part. So here two graphs are given, mode of Cn and angle of Cn. So what is your Cn? Cn is given as mode of Cn and angle of Cn. This is how I can write down. So we need to write down the values. What is C of 0? So mode is 2, angle is 0. Mode is 2, angle is 0. What does that mean? 2 only. What is C of 1? C of 1 is mode is 3 and angle is 90. What is the meaning of 90 degree angle? J. I hope you know this particular thing. Angle is e to the power j pi by 2. So e to the power j pi by 2. What does that mean? Cos pi by 2 plus j sin pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1. That would be equals to j. And what is the meaning of minus sign here? So here minus j would come. So these basics of complex number you should be knowing, and for that I have made a video as well, that basics of complex number that you should be studying. What is your C of minus 1? C of minus 1 is amplitude is 3 and angle is minus 90 degree. If it is minus 90 degree, then minus 3j. What is C of 2? C of 2 is 1 and angle is minus 90 degree. That would be minus j. And what is C of minus 2? C of minus 2 is amplitude is 1, angle is 90 degree. Say yes or no. So looking at these values, what you can write down? That your C of 1 is equals to C of minus 1. Sorry, C of 1 is equals to minus of C of minus 1. And from here what you can write down? That your C of 2 is equals to minus of C of minus 2. C of 2 is equals to minus of C of minus 2. Just you take the minus sign here, both will be equal. You take the minus sign here, both will be equal. So this is what you can write down. From here you will make the conclusion that C of n is equals to minus of C of minus n. From there you will make the conclusion that x of t is equals to this particular thing. And from there you will make the conclusion that xt is odd. And whatever that you have done here, this is absolutely wrong. Because what did I tell you? Always check the 0. C of 0. DC value is non-zero. And what did I tell you? If your function is odd, then DC value has to be 0. If you remember this particular thing, x of t is equals to minus x of minus t. DC value has to be 0. Is this the odd graph? Is this odd? Yes. What is the DC value? 0. You can keep on repeating this graph. Okay, you can keep on repeating this graph. But DC value will be always 0. Or you can check from here as well. No. What is the thing? That what is your C of 0? C of 0 is 2. What will be your C of minus 0? That will also be 2. Because C of minus 0 will be equal to C of 0 only, because minus 0 is same. That will also be true. What you are saying from here? Put 0. In place of n, you put 0. So C of 0 should be equal to minus of C of minus 0. So what is C of 0? C of 0 is 2. What is C of minus 0? So 2 is equal to minus 2. No. That means this relation C of n is equal to C of minus n is not true. It should be always true. What did I tell you? It should be always true. But at n equals to 0, the problem has been created. So if always it is not followed, then you cannot comment. And neither, here minus sign you cannot tell. Here minus sign you cannot tell. And certainly C of n is not equals to C of minus n as well. But that you can see here as well. C of n is surely not. From here what you will say? That sir, C of 0 is equals to actually C of minus 0. If you look at this particular thing, that C of 0 is equals to C of minus 0. So can you conclude from here that C of n is equals to C of minus n? No. It is followed here, but it is not followed here. Everywhere one rule should be followed, then only you can comment. You can directly see that C of 1 is equals to not C of minus 1. C of 1 is not equals to C of minus 1. Both are not equal. So it cannot be even. You felt like it is odd, but this DC value started creating problem. If your DC value was 0, let's just say if my C naught was 0, in place of 2, if it was 0, then this would have been 0. Then 0 would be equals to minus 0. Yes. Then everything would have been correct. But if DC value is 2, then this is creating the problem. What does that mean? That your C of n is neither. From here, what you can conclude that my xt is neither even nor odd. So very, very important thing. Whatever, like wherever they can get you puzzled in the minor mistake that we are seeing here. You will never do the minor mistake in the examination, that's for sure. So these kind of minor mistake could be possible, which we are looking. And if one can think that how DC value can be non-zero, what is C naught? C naught is the DC value, no? C naught is the DC value. So in a odd function, DC value always has to be 0. In an odd function, DC value always has to be 0. So if DC value is non-zero, that means certainly it cannot be odd. Okay. So even odd is done. What is the next? Real and imaginary, right? So let's check for real and imaginary. So this is your C of 1, this is C of minus 1. So from here what I can say? That my C of 1 is equals to C of minus 1 conjugate. C of minus 1 conjugate. And from here what I can say? C of 2 is equals to C of minus 2 conjugate. Because if you take the conjugate, it will be minus j. If you take the conjugate, it will be plus j. Right? So next what I am saying, that my C of n is equals to C of minus n conjugate. Can I conclude from here only, whatever that I want to conclude? No. What I need to do? Let's say move it off. what I need to do, I need to check at 0 as well. So I will put n equals to 0 here. C of 0 is equals to C of minus 0 conjugate. What is C of 0? That is 2. What is C of minus 0? That is also 2. Conjugate of 2 will be 2. 2 is equals to 2. Yes, followed. So here C of n is equals to C of minus n conjugate is certainly followed. These two are happy. These two are happy. This guy is also happy now. So yes, this finally I can conclude. And from there what I will get to know, that xt is equals to x conjugate t. What does that mean? That your xt is real, right? Xt is real because my C of n was equals to C of minus n conjugate. From here C of minus n conjugate. So C of n was equal to C of minus n conjugate. That means xt was equals to x conjugate t. So xt is real. So these two things I can conclude about xt, that it is real but neither even no road. Say yes or no. Let's do the next question. On your own you need to do the next question and you need to find xt as well. Okay, here in this question you need to find xt as well. So let's find out the xt. What will be your xt? Xt will be equals to C naught plus C1 e to the power j omega naught t plus C of minus 1 e to the power minus j omega naught t plus C2 e to the power j2 omega naught t plus C of minus 2 e to the power minus j2 omega naught t. What is the value of C naught? That was 2. 2 3j minus 3j. 2 3j e to the power j omega naught t minus 3j e to the power minus j omega naught t plus C2 minus j plus j. So minus j e to the power j2 omega naught t plus j e to the power minus j2 omega naught t. Okay, so what I can do, 2 plus 3j, just calculation is there, nothing else. J omega naught t minus j minus omega naught t. Can I make sinusoid from here? Yes. What I need to do, I just need to divide by 2j and multiply by 2j. Then what I can do, I can take common e to the power j2 omega naught t minus e to the power minus 2j omega naught t. Can I divide by 2j? Yes. And can I multiply by 2j as well? Yes. So 2. J and j will make minus 1. So minus 6 sine omega naught t. Here j and j will make minus 1. So plus 2 sine 2 omega naught t. This is your xt. And from xt as well you can find out that, here what you can find out, that your x of t is not equals to x of minus t or minus of x of minus t. That means it is neither even nor odd. This is not true. Along with that, x of t is not equals to this thing as well. So from here what you can see, neither even nor odd. And from here directly you can see that it is real only, right? X of t is real because everything is real, there is no j term. So x of t is real, it is neither even nor odd. In the examination, a lot of people will follow this process. Okay, if this question is coming and they ask you to comment on the nature of xt, then people will follow this particular process, that they will find out xt. But what if I take the limit from minus 100 to 100? How will you find out xt there? So better always go with the C of n, right? Always go with the C of n. So this is how I will write it down. Say yes or no. Is that all clear to you or not? I hope it is clear. So this is how we can find out. Let's check back the calculation again. 3j was there, minus 3j was there, minus j was there, plus j was there. Okay, then I took common, then divided by 2j into 2j sine 2 omega naught t, 2j 2 and here 2j and minus 6. Yeah. And one thing I always tell, whether it is analog electronics, network analysis, control systems, signal system, communication system, EMFT, always solve the question in the examination hall with patience. Gate examination is never the examination of speed. Gate examination is the examination of accuracy. If you solve these kind of things in hurry, then some plus j minus j, all these error will happen. So always solve the questions with patience. You just need to think of it. Am I able to solve? Now I will do the calculation very slowly. And if you solve in this manner, then it will be easier for you to check as well, that whatever the calculation that I have done, that is correct. Yes. When I was a student, I also used to solve in a hurry. That's why my accuracy never went above 70%. Even in the final examination, it was 70%. I attempted 64 questions and there was so many minor mistakes out of 65. If I had like very basic questions of control system, I got wrong in the main examination, in GATE 2022 examination. If I just could have solved the basic question correct only, no, then something different would have happened, right? Although my rank was fine, but again, different things could have happened. So this is what I am saying, that always solve the questions with full amount of patience, right? Let's see this one. Try doing it on your own. C0 is given, C1 is given, C of minus 1 is given, C2 is given, C of minus 2 is given. You need to comment on xt and then you need to find xt as well. So what it feels like? It feels like that in C of minus 1, if I take the negative sign, what I will get? 2 minus 3j. And then if I take the conjugate, plus j will be replaced with minus j. And this is coming out to be C of 1. In C of minus 2 as well, if I take the negative sign, what it will become? 1 minus j. And then I take the conjugate, it will become 1 plus j, which is equal to C of 2. So what did I get to know? Minus sign. Minus sign. From there I am thinking to make this conclusion. This is what I am thinking. But check at 0. What I need to do? N equals to 0. I need to check at n equals to 0. I put n equals to 0 here. C of minus 0. Minus 0 is 0 only. What is C of 0? 2. Minus, what is this C of 0? 2. What is 2 conjugate? That is 2 only. 2 is equals to minus 2. Not true. That means it is not true for n equals to 0. So at n equals to 0, it is not followed. That means you cannot write down that C of n is equals to minus C of n minus conjugate. Right? So you cannot write down that x of t is equals to minus of x conjugate t, because x conjugate t will have C of minus n. So this you cannot write down. And surely you cannot write down the other relation, that C of n is equals to C of minus n conjugate. Surely you cannot write down this, that x of t is equals to x conjugate t. This also you cannot write down. This directly I can see. In C of 1 only I can see it. Although here for 0 it will be satisfied. But C of 1, in C of 1 I can directly see that what will be C of minus 1 conjugate? C of minus 1 conjugate will be minus 2 minus 3j. This is not equals to C of 1. So certainly I cannot write down this particular thing. This is also not true. So what does that mean? It is, this would have shown imaginary, this would have shown real, right? So this is also not true. What does that mean? That x of t is complex. There you go. Look, here it is followed, right? Here it is followed. What does that mean? That these two parts will be imaginary actually. But this is the part which is real. And real plus imaginary will always make complex. Real plus imaginary will always make complex. Are you getting this point? This part is complex because here C of n is equals to C of minus n is followed. That means here xt will be complex. Sorry, not complex. Xt will be imaginary. This part will be imaginary. This part will also be imaginary. But the DC value is real. Then whole function will become complex. When we find xt, we will see it. Okay, so there also I will tell the conclusion. When we find xt, we get to know that whatever that is made from C of 1, C of minus 1, C2 and C of minus 2, that part will be imaginary. But only this part will be real. Because here in this part we can see that my xt should be imaginary. But this real part is creating all the problem. So real plus imaginary is making it complex. So xt is complex. You can tell about your even and odd as well, right? So can you comment anything? Directly I can see that C of n is not equals to C of minus n, because C of 1 is certainly not equals to C of minus 1, and neither it is equals to that, neither this is the same, right? Because if I take the negative sign here, what it will become? 2 minus 3j. So c of minus 1 minus sign is not equals to c of 1. Minus of c of minus 1 is not equals to c of 1. Neither c of minus 1 is equals to c of 1, because minus 2 plus 3j is not equals to 2 plus 3j. So both are not true. What does that mean? From here what I could have concluded that xt would have been equals to x of minus t, and from here I could have concluded that xt is equals to x of minus t and then negative sign. That means here I could have said that it is even, here I could have said that it is odd, but it is neither even nor odd. So xt is neither even nor odd. So xt is complex and neither even nor odd. Say yes or no. Well and good. So this is how we will solve the problem. We need to find xt now. So let's find xt. So what will be your xt? Xt will be dc value plus, now I am not going to write down the formula, I will directly write down 2 plus 3j e to the power j omega naught t plus minus 2 plus 3j minus 2 plus 3j e to the power minus j omega naught t plus 1 plus j e to the power j2 omega naught t plus minus 1 plus j e to the power, this was c of minus 2 minus j2 omega naught t, right? Now what I can do, 2 plus 2 e to the power j omega naught t minus 2 e to the power minus j omega naught t plus 3j e to the power j omega naught t, right? Plus 3j e to the power minus j omega naught t. Are you able to understand what I am doing? 3j I can take common now, na? Right? So this is what I am doing. And from here e to the power j omega naught 2 e to the power j2 omega naught t minus e to the power minus j2 omega naught t plus j e to the power plus j e to the power minus j2 omega naught t. I hope all this is clear, right? So what I will do, 2 I am taking common, then what will happen here, e to the power j omega naught t minus e to the power minus j omega naught t. So I will have to divide and multiply with 2j. So what I will get, 4j sin omega naught t. Say yes or no. What I will get, 4j sin omega naught t. Say yes or no. Here what I will get, 3j, and then I need to take e to the power j omega naught t plus e to the power minus j omega naught t. So from here what I can make, cosinusoid, because e to the power j theta plus e to the power minus j theta divided by 2 is cos theta. So multiply and divide by 2. So what I will get, 6j cos omega naught t. 6j cos omega naught t plus, what about this one? Here also divided by 2j, multiply by 2j. So 2j sin omega naught, sin 2 omega naught t. And what about this one? Here also 2j plus 2j cos 2 omega naught t. I hope this mathematics is clear. I took the j common, e to the power j2 omega naught t plus e to the power minus j2 omega naught t. So divide by 2, multiply by 2. So multiply by 2, so it will become 2j, and this part will become cos. So cos 2 omega naught t. So this is what we are getting. What do you think? This part is completely imaginary, because j, this part is completely imaginary, and this part is real. So what you can see here, your xt is complex. And I told you one thing, that because of c of 1, c of minus 1, c of 2 and c of minus 2, whatever that we are getting, that will be imaginary only. So yes, it is imaginary, but this was real, that is creating all the problem. If our dc value was 2j, then our answer would have been that your x of t is complex, right? If our dc value was 2j. I guess I have put the example as well. I guess there is one more example like this. Yeah, there is this kind of example is also present, so that we will see. And directly you can see here that your x of t is not equals to x of minus t, and neither your x of t is equals to minus of x of minus t. Both are not true, because here minus sign will be taken out, here minus sign will be eaten up, here it will be taken out, here it will be eaten up. So nothing relation we are getting. What does that mean? That it is neither even nor odd as well. Okay, so this example we have seen. Do the same for this one. What we can see here, in C of minus 1, if I take the negative sign, what I will get? 2 minus 3j. And then if I take the conjugate, this is the thing I will be getting, 2 plus 3j, which is equals to C of 1 only. I guess same value I am taking, 2 plus 3j minus 2 plus 3j, 1 plus j minus 1 plus j. Yeah, same value I am taking. So basically, C of minus 2 conjugate minus sign is equals to C of 2 only. This we have already seen, right? If I take the minus sign and then I take the conjugate. So this we have already seen. Now from here, what is the conclusion I am making? C of n is equals to minus C of minus n conjugate. But this is not the final conclusion. You need to check at n equals to 0 as well. So C of 0 should be equals to minus C of 0 conjugate. What is C of 0? C of 0 is 2j minus 2j conjugate. What will be the conjugate of 2j? That will be minus 2j. So minus of minus 2j, because plus j will be replaced with minus j. So what you are getting? 2j. So 2j is equals to 2j. So yes, it is followed for n equals to 0 as well. For n equals to 0 as well, it is true. What does that mean? That now I can say that C of n is equals to minus C of n. C of n is equals to minus C of minus n conjugate. What does that mean? I can put down x of t is equals to x conjugate t. X of t is equals to minus x conjugate t. What does that mean? That means that it is imaginary, right? Because minus sign is coming out, that means it is imaginary. So x of t is imaginary. What about even and odd? Directly I can see that there is no relation between C of n and C of minus n. C of n, C of minus n, no relation. Both are not equal. Neither negative sign is coming out. Okay. So x of t is basically imaginary plus neither even nor odd. And everything will be same here in the x of t. Everything will be same. What will be the different thing? That only 2j will be here. Here in place of j I have put 2j. So this expression will be completely copied. This expression will be completely copied here. This will be my x of t. But now the matter of difference. What is the matter of difference here? The DC value was 2j. So this value was imaginary. And imaginary plus imaginary, everything has become imaginary. And certainly it is neither even nor odd as well. Okay. So this is how we need to follow it. Are you able to understand the point? Let's check back the calculation for this particular question. Minus 2, 3j plus 3j, j 1 minus 1, j plus j. Then divided by 2, 2j cos omega naught t divided by 2j, then 2j sin omega naught t. Then here divided by 2, 6j cos omega naught t, and here divided by 2j, so 4j sin omega naught t and 2. Yeah, so calculation is also correct. So I hope now in this 50 minutes of discussion, your concepts are clear that how we are solving these kind of questions. So always check at C of 1, C of minus 1, C of 2, C of minus 2, and then find out the relation, and then you will be able to tell whether xt is imaginary, even, odd, real, or whatever it is, complex, and all these kind of things you can tell. Okay. And you can surely find xt as well. If in the examination hall it is asked to find xt, then this is the process to find xt as well, because you would be knowing the exponential Fourier series coefficient. From there you can certainly find xt as well. Well and good. Okay. xt is odd. What they are saying? xt is odd. What you need to find? Summation of all the Fourier series coefficient. What I need to find? Summation of all the Fourier series coefficient. So xt is odd. What does that mean? That my Cn will also be odd. If xt is odd, xt is odd. C of n is equals to minus C of minus n. What does that mean? This is also odd. In any odd graph, if I do the summation of all the samples, what that would be? Let's just say this is -2, this is +2, this is 1, this is -1. Is that odd? Yes. So -1, -2, +2, +1. What that would be? 0. Summation n goes from -infinity to infinity, C of n. This is your odd. So what that would be? 0. So what is the answer? 0. Okay. Or how you could have checked? X of t is equals to C of n e to the power j n omega naught t. Right? N goes from -infinity to infinity. Right? If I put t equals to 0, what I will get? Because what is my target? I need to make this particular thing. So put t equals to 0. What I am doing? T equals to 0. So x of 0 will be summation n goes from -infinity to infinity Cn e to the power j n omega naught into 0. What that would be? So x of 0 is equals to summation n goes from -infinity to infinity C of n. In any odd signal, x of 0 has to be 0. Why is that so? Because for odd signal, what is the property? X of t is equals to minus of x of minus t, right? Put t equals to 0 here. Put t equals to 0 here. Minus 0 will be 0 only. From here, what you are getting? 2x of 0 is equals to 0. So x of 0 is equals to 0 only. So for odd signal, x of 0 has to be 0. For odd sequence as well, we have found out this thing, right? For odd sequence, x of n has to be 0, right? Yeah, sorry for the interruption, someone came in between. Yeah, so what I was saying, so for odd sequence as well, I said this particular thing, that x of n has to be 0 for odd sequence. You don't need to mug it up, you just need to see it there, that x of 0, x of here also you will put 0. So x of 0 is equals to minus x of 0. That if this comes here, so 2x of 0 is equals to 0. What does that mean? X of 0 has to be 0. There you go, right? So x of 0 has to be 0. That means this has to be 0. So what you get to know from here? C of n is equals to 0. Now someone will say that, sir, this is also a odd signal, right? This is also a odd signal. So here x of 0 is 0. No, x of 0 is not defined. Actually, it is 0 only. Just ahead, it is plus a, and just before it is minus a. So kind of you can take the average. It will be 0 only. Basically, if this is your x of t, and I ask you what is x of 0, you will say it is not defined. But ideally, we can say like, not ideally, like just for the concept purpose, I should not say concept purpose, what name I should take, like just for saying we can say that it is equals to 0 only, because just x0 plus is a and x0 minus is minus a. You take the average, it will be 0 only. Although this is not a concept that to find the average at a particular point you take the value ahead, then take the value backward and then take the average. That is not any concept. But it is not even defined at t equals to 0. It is not even defined at t equals to 0. So what I would say, it is equals to 0 only, because plus a minus a. So in between 0 would come. So x of 0 is 0 only. And in this kind of example, directly you can see, right? This is a odd signal. So here there is no discontinuity. Here there is no discontinuity. So here what you can see, directly you can see that x of 0 is 0 only. So in odd signal or in odd sequence, x of 0 has to be 0, right? So there you go. This question we have solved. So the summation of C of n. If your x of t is odd, then C of n will also be odd. And in an odd sequence, if you take the summation of whole, that will come out to be 0 only. So this was your method 1. And this was your method 2. So in that manner, we can solve the problem. Next, we will start studying about the power. So we have already seen how to find the power of a periodic signal, especially for sinusoids and complex exponentials. We have seen the concept of orthogonality as well. So now we are going to cover this particular part. So in this particular part, you know everything. You know every single thing. You just need to see it that I know it. Okay? You know everything already. You just need to see it and tell it that I already know it. That's it. So now we are going to see power using Fourier series, and that is known as Parseval theorems as well. But you don't need to look at the name of the theorem. You just need to look at the concept. So we are going to study the concept of power now. Okay, so let's meet in the next lecture. Thank you. Hi everyone, welcome back. So we have been studying about exponential Fourier series. In this video we will talk about power. So this video will be completely based on power. So if I give you a periodic signal, can you write down the power of that particular periodic signal? Yes, we have seen all these things in the basics of signal. So can you write down the power? One is sinusoid, another one is a constant value. C naught is a constant, okay? Or you can say this is a DC value or a constant value. So if there is a constant and then there is a sinusoid, can you write down the power? What will be the power? A square by 2 plus C naught square. But here instead of writing A square, I am writing mod of A square by 2. Mod of A square by 2 plus mod of C naught square. Because it could be imaginary as well, no? Basically, what if A is 2j? So will you directly do the square? No. First you will take the mod, then you will do the square. What if I ask you, what is the power of 2j sine omega naught t? Will you say, sir, it is 2j square divided by 2. What is 2j square? Minus 4 divided by 2. So the power is minus 2. No, this is wrong. What you will say? Sir, it is 2j, mod of 2j square divided by 2. That means 4 divided by 2, the power is 2. Are you getting this point? So always you need to take the mod because the constant value could be imaginary as well. So that's why I am writing down mod here. So a square by 2 plus c naught square. So mod of a square by 2 plus c naught square. What about this one? Omega naught to omega naught. Orthogonal to each other. And DC makes no impact. That is also orthogonal only. So omega naught to omega naught, both are orthogonal to each other. That means mod of a square by 2 plus mod of b square by 2 plus mod of c naught square. What about this one? Sine and cos, both are 90 degree apart. That means orthogonal to each other. So again the same answer, mod of a square by 2 plus mod of b square by 2 and dc square, mod of dc square. What about this one? Do you remember a e to the power j omega naught t? You need to take the mod, then you need to integrate for a time period divided by the time period. So what you will get? What will be the mod of this one? Mod of a square dot, you need to integrate it for a time period. That means mod of a square into t divided by t. So it will get cancelled. So what will be the answer? Mod of a square. Or how you can see it? What is a e to the power j omega naught t? A e to the power j omega naught t is a cos t plus j a sin omega naught t. Are both of them orthogonal to each other? Yes. So what will be the power? Mod of a square by 2 plus j mod of a square by 2. So mod of a square by 2 plus here also mod of a square by 2. So what that would be equals to? Mod of a square. So I told you complex exponential will give you the power of just the magnitude a square, right? So mod of a square will be the answer. So what will be the answer here? Mod of a square plus mod of c naught square. What about this one? Omega naught t to omega naught t. If m is not equals to n, I hope you remember all these things. If m is not equals to n, then they will be orthogonal. Basically, if it was omega naught t here, in place of 2 omega naught, if it was omega naught t, then there would be issue. But it is omega naught t, this is 2 omega naught t. They will be orthogonal to each other. It is like sinusoid only. In sinusoid, if same frequency is there, then there is an issue. But different frequencies are there, they will be orthogonal. Omega naught to omega naught orthogonal. Omega naught, but sine and cosine 90 degree apart orthogonal. So all these are orthogonal. Basically all these are set of orthogonals. So here what will be the answer? Mod of a square plus mod of b square plus mod of c naught square. Here there is negative frequency. M has to be equals to n. Here m value is 1, n value is minus 1. So this is also different, no? They are also orthogonal to each other only. Are you getting this point? A e to the power j omega naught t and b e to the power minus j omega naught t. That is also orthogonal to each other only. Are you getting this point? Negative frequency means also orthogonal. So they are also orthogonal. Plus mod of c naught square. Okay, so this will be the power. Well and good. Now what we need to see? We need to go to Fourier series. So do we know all these things? The xt can be broken into sinusoids and cosinusoid and dc, or it can be broken into complex exponentials. So these things we already know. dc plus a1 cos omega naught t plus a2 cos omega naught t plus a3 cos omega naught t. Just here it would be sin n omega naught t. Really sorry. Here it should be sin n omega naught t. So cosinusoid and sinusoid. So basically your xt would be a dc plus cosinusoid of omega naught frequency, cosinusoid of 2 omega naught frequency, cosinusoid of 3 omega naught frequency till infinity, plus sinusoid of omega naught frequency, sinusoid of 2 omega naught frequency, sinusoid of 3 omega naught frequency till infinity, having the amplitude of a1, a2, a3 till infinity, b1, b2, b3 till infinity, plus the dc. This is our xt. Same goes for complex exponential as well, but we will see the exponential later on. As of now, we are looking at the cosinusoid and sinusoid. Is that clear to you? Have we seen all these kind of things? Yes. Omega naught, 2 omega naught, 3 omega naught, 3 omega naught, 2 omega naught, omega naught. Cos sine 90 degree difference, cos sine 90 degree difference, cos sine 90 degree difference. That means all these are orthogonal to each other. Say yes or no. This is orthogonal to this one, 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 this is orthogonal to this one. So all these are a pair of, we should not say pair of, all these are set of orthogonal sinusoid and cosinusoid. Do you agree to this point? All are orthogonal to each other. If all are orthogonal to each other, can you write down the power? What will be the power? Mod of c naught square plus mod of a1 square by 2 plus mod of a2 square by 2 plus mod of a3 square by 2. In that manner you keep on going. Same goes with b1 as well. Mod of b1 square by 2 plus mod of b2 square by 2 plus mod of b3 square by 2, and in that manner it kept on going. So what is this? dc square plus summation n goes from 1 to infinity mod of a1 square plus mod of, so sorry, not a1, really sorry, n is going from 1 to infinity, so mod of a1 square plus mod of bn square divided by 2. Do you agree to this point? This is the power of xt. Do you agree to this point or not? Simply in your mind what you will think, okay, dc plus a1 cos omega naught t, a2 cos 2 omega naught t plus a3 cos 3 omega naught t. In that same manner, b1 sin omega naught t, b2 sin 2 omega naught t, b3 sin 3 omega naught t. In that manner it will keep on going. So dc square plus mod of a1 square by 2 plus mod of a2 square by 2 plus mod of a3 square by 2 plus mod of b1 square by 2 plus mod of b2 square by 2 plus mod of b3 square by 2. All these calculations you can do in your mind only. Say yes or no. Okay, I am considering that all are non-zero. a1, a2, a3, b1, b2, b3, everything is non-zero. This is what I am considering. So after that, can I develop this formula? Surely you can develop this formula. Well and good. Okay, so this formula we have developed. Although this is known as Parseval's theorem, but the name of the theorem is not important. What it is showing, that is important. So what this is showing? This is showing the power of xt. And power of xt is given as, how it is given? Power of xt is given as, since we are talking about periodic signal only, so here I will write down the formula of periodic only. In this particular chapter, we are only talking about periodic signal. So if we are talking about periodic signal only, so here I will write down the formula of periodic signal only. So 1 by t naught, you need to integrate over a time period, mod of xt square dt. So this was the power of xt, which is coming out to be equals to constant square plus the coefficient of cosinusoid square plus coefficient of sinusoid square divided by 2. And you need to add all these coefficients for 1 to infinity. Say yes or no. Is that clear to you or not? Everything is clear? Important part, always you need to note, this will go from 1 to infinity and this goes from minus infinity to infinity. Because when we break down cosinusoid, it comes into two parts, e to the power j omega naught t, e to the power minus j omega naught t. When you break down sinusoid, e to the power j omega naught t, e to the power minus j omega naught t. So two parts come, that's why here it goes from minus infinity to infinity. Well and good. So here just power of xt, that I have already written in the previous page only, so we don't need to care about it. Now we will talk about this complex exponential, right? So can I break down my xt in this form? C naught dc, c1 e to the power j omega naught t plus c2 e to the power 2 j omega naught t plus c3 e to the power 3 j omega naught t. In the similar manner in the negative side as well, c of minus 1 e to the power minus j omega naught t, c of minus 2 e to the power minus 2 j omega naught t, c of minus 3 e to the power minus 3 j omega naught t. Can I break it down in like this? Yes. Are all of them orthogonal? These two orthogonal? Yes. These two orthogonal? Yes. These orthogonal. DC is a orthogonal only. DC will be orthogonal to everyone, right? Are these two orthogonal? Yes. Everyone are orthogonal to each other. This is the meaning of Fourier series actually. When we write down the definition of Fourier series, there we mention the word orthogonal, that we break down our xt in set of orthogonal pair of sinusoid, cosinusoid or complex exponential. So all these are orthogonal to each other, and if they are orthogonal to each other, our job is done. Our Job is done. What I can write down? Plus mod of C of minus 2 square plus mod of C of minus 1 square plus mod of C naught square plus mod of C1 square plus mod of C2 square and so on. Now can I write it down in this manner? N goes from minus infinity to infinity mod of Cn square. Say yes or no. Right, very easy. You put minus 2, minus 1, 0, 1, 2 in that manner. Also, what you have seen this formula, right? Mod of C naught square plus n goes from 1 to infinity mod of an square plus mod of bn square divided by 2. We will do something about it, just wait a second, okay? So what you have studied, that mod of C of minus 1, what was C of 1? A1 plus jb1 by 2. And what was C of, A1 minus jb1 by 2, A1 minus jb1 by 2. And what was C of minus 1? A1 plus jb1 by 2. When we wrote down the mod of C of 1, what that was? Under root A1 square plus b1 square divided by 2. Here better we should have written mod of A1 square plus mod of b1 square, because they can also be A1, b1 can also be imaginary, right? So that's why I should have written here mod of A1 square plus mod of b1 square by 2. So here I will write down mod of A1 square plus mod of b1 square divided by 2, and that would be equals to C of minus 1 as well. So mod of C of minus 1 will be equals to mod of C of 1. This we have already seen, right? These modes are equal, this and this is equal. So mod of C of n is equals to mod of C of minus n. This we have already seen, because what is C1? A1 minus jb1 by 2. What is C of minus 1? A1 plus jb1 by 2. What will be the magnitude? Under root A1 square plus b1 square divided by 2, under root A1 square plus b1 square divided by 2, right? So this we have already seen. So what I can do? Dot. C of minus 2 can be replaced with C of 2 square. C of minus 1 can be replaced with C of 1 square. Then C of 0 plus C of 1 square plus C of 2 square and so on. So C of 1 square twice, C of 2 square, C of 2 square twice. So mod of C naught square twice of mod of C1 square, mod of C2 square. In the same manner, mod of C3 square will also come and so on. So can I write down in this manner? Mod of C naught square twice of summation goes 1 to infinity mod of Cn square. That's it. This is the power of xt. So what was the first formula? This is the generalized formula. Basically, this will work always. This will always work. This is always true. What about this one? This is also one of the formula. This is the other way of writing this particular formula. Okay. So let me add a page. I want to do something here. What I will do? I will add a page now. So let's break down this formula on the next page. What we have developed? We have developed that power was mod of C naught square, summation n goes from 1 to infinity, mod of an square plus mod of bn square by 2. This we have developed, right? And what do we know? That mod of Cn is equals to under root mod of an square plus mod of bn square divided by 2. Can I take this 2 outside, 2 here? This 2 I can take here. So if I do square on both of the side, what I will get? 4 mod of Cn square will be equals to mod of an square plus mod of bn square. Right? Just mathematics we are doing, nothing else. Mod of Cn was under root an square plus bn square divided by 2. So that 2 I took here, and then I am doing square on both of the side. So this square will cancel out the under root, and here it will be 2 square will be 4 Cn square. So here I will put that. So mod of C naught square, n goes from 1 to infinity, mod of 4 mod of Cn square divided by 2. So 2 and 2 it will get cancelled out. What it will become? 4 divided by 2. Let's write down 4 divided by 2. So what we are getting? mod of c naught square n goes from 1 to infinity mod of cn square. So this is the power of xt. So this is the formula that we have developed. Okay. So this way was the derivation, like you could have derived in this manner or you could have derived in this manner. Both are giving the same answer. But important part is you need to remember this particular formula. Why I am saying this is the important part? Let's do something. Okay. Let's frame a question. What I am doing, your xt is defined, n goes from 0 to 2, 1 by 2 to the power n e to the power j n omega naught t. Find the power of xt. What you need to do? You need to find the power of xt. What do you think? Will you apply this formula directly? Can you apply this formula? From here what I can see? C of n. C of n is 1 by 2 to the power n. But it is always there from 0 to 2 only. That means C of minus 1 is 0. This particular thing is 0. And this particular thing is non-zero. Here what did I say? Both will be equal. Both will be only equal if both are defined. Like one of them could be 0, no? What if this is 0? What I am saying is that, what if this is 0? C of minus 1 could be 0 as well. It can be defined in this manner, no? That C of minus 1 is 0. If your xt is complex, then there might be issue that C of minus 1 is 0. So this formula will only work if xt is purely real or if your xt is purely imaginary. But if xt is complex, then there would be issue. So here what I will write down, that this will work if xt is real or purely imaginary. Because if it is real or purely imaginary, that means C of n, C of minus 1 n both will be there. Because if xt is real, then what will be the issue? Then what will be the scene? That C of n will be equals to C of minus n conjugate. And if xt is purely imaginary, then C of n will be equals to C of minus n conjugate and then minus sign. Basically, C of minus n will be non-zero if xt is purely real or purely imaginary. Then C of minus n is non-zero. But what if here x of t is complex? Here xt will be complex or not? Yes, surely it will be complex. Why is that so? Because what will be my C of 0? C of 0 will be 1 by 2 to the power 0. That would be equals to 1. What will be my C of 1? C of 1 will be 1 by 2 to the power 1. That will be equals to 1 by 2. What will be my C of 2? 1 by 2 to the power 2. That would be equals to 1 by 4. What is my C of, here I will write down, what is my C of minus 1? That is equals to 0. C of minus 1 is 0. And what is C of minus 2? That is also 0. So from here I can directly see that C of n is not equals to C of minus n conjugate. Neither C of n is equals to minus of C of minus n conjugate. What does that mean? That means C of n is complex. And if it is complex, then this formula will not work. And directly you can see, you don't need to think all these things. Directly you can see, no, that how did we get this formula? How did we get this formula? We got this formula saying that both are equal. But are both of them equal? No. Why both of them are not equal? Because my xt was complex. So in statement wise, I can ask a very good question, that power of xt is given as mod of c naught square plus 2 into summation goes from 1 to infinity mod of cn square. This formula is always true, or it is only true when x of t is purely imaginary or purely real. So a very good question in the statement wise I can frame, because a lot of people just think that okay, from here this formula is derived, always it is applicable. How it will be always applicable? It will not be always applicable. Why is that so? Because C of minus 1, C of minus 2 could be 0, or it may happen that C of 1, C of 2 is 0, right? Both has to be non-zero. That means your summation should be symmetric. If summation is going from minus alpha to plus alpha, then this formula is applicable. And if it is going from minus alpha to plus alpha, then either it will be purely real or it will be purely imaginary. That's for sure. Are you able to understand this point? Well and good. Okay. Yeah. So this is what I was saying, that you need to check if you can apply the formula or not. So for that, what you need to do, you need to see the summation. that how the summation is going. Summation is going from 0 to 2, then you cannot apply that particular formula. So from here, what will be the power? Power will be 1 square plus 1 by 4 plus 1 by 16. Basically what I am doing, 1 square plus 1 by 2 square plus 1 by 4 square plus 1 by 2 square plus 1 by 4 square. So whatever the power you will get, so 1 plus 1 by 4 plus 1 by 16. So 16 is coming as LCM, 16 plus 4 plus 1. The power will be 21 by 16. 16, 21 by 16. Yeah, so power will be 21 by 16 watt. So 21 by 16 watt. Okay, just a minute, I will take a pause. Yeah, welcome back. So we were studying about power, and here one thing I did wrong. Here I have written Cn is complex. No, from here xt is complex, right? From here the conclusion is xt is complex, not Cn is complex. Cn is real only. You can directly see Cn is real. So I'm not commenting about C of n here. I am talking about xt here. So Cn is real here, but xt is complex. Why xt is complex? Because C of 1 is not equals to the conjugate of C of minus 1. Neither it is equals to the negative conjugate of C of minus 1, right? So that means xt is complex. So you cannot apply that particular formula because actually C of minus 1 is 0. C of minus 2 is 0. That was the scene, right? Let's go here. Find out the power. Just let me know, can I apply this formula? Can I apply this formula here? Can I apply this formula? So what did I tell you? This is only applicable when xt is purely real or purely imaginary, right? Purely real or purely imaginary, right? So here xt is equals to minus 2 to 2, 1 by 2 to the power n, e to the power j n omega naught t plus pi by 2. So here I need to take pi by 2 aside. Basically what I need to do, minus 2 to 2, 1 by 2 to the power n, e to the power j n omega naught t, e to the power j pi by 2, and e to the power j pi by 2 will become j only. So n goes from minus 2 to 2, j 1 by 2 to the power n, e to the power j n omega naught t. That is your xt, right? So from here I can see that my C of n is j 1 by 2 to the power n, 4 minus 2 to 2, and otherwise it is 0, minus 2 to 2, and otherwise it is 0. Just let me know what is the value of C of 0. C of 0 will be j only. What will be the value of C of 1? That will be j 1 by 2. And what will be the value of C of 2? That will be j 1 by 4. What will be the value of C of minus 1? That will be j 2. And what will be the value of C of minus 2? That will be j 4. So can you tell anyhow here, is there any relation between C of n and C of minus n conjugate? Is there any relation between C of n and C of minus n conjugate? What will be C of 1? 1 by 2j. And what will be C of minus 1 conjugate? Minus j2. Is there any relation? Like they are equal or equals to the negative of each other. Is there any relation? No, right? C of 1 is not equals to C of minus 1 conjugate, and C of 1 is not equals to minus of C of minus 1 conjugate. There is no relation at all. Basically this relation also doesn't hold, and this relation also doesn't hold. And from here what conclusion do you make? From here you can say that your xt is complex, and if xt is complex, then which formula is not applicable? This formula is not applicable. Although in the examination hall you don't need to do this process. If they are asking you the power of this particular function, then what you will do? If they are asking the power, then you will just take the mode of them and do the square and then just add them up. That's it. But here I am telling you one important concept, that is this formula is not applicable when xt is complex. So you cannot apply this formula here, because if you apply the formula like this, that power of xt would be, what I would do, mod of c naught square plus 2 summation n goes from 1 to infinity. Here in place of infinity where I will go 2, from 1 to 2, and mod of cn square. So this formula is not applicable. Not applicable here. Not applicable. So which formula is applicable? power of xt is, this is always applicable, minus 2 to 2 mod of cn square. This is always applicable, always applicable. You don't need to see whether it is real, imaginary, purely imaginary, purely real or complex. Nothing you need to see. This will always be applicable, always applicable, always applicable. A very important conclusion, I can frame these kind of questions in a short statement wise problems. Okay, I will write down the statement and I will ask you whether it is true or not. So let's calculate the power here. So what I will do, just take the mode of all of them. What will be the mode of j? That will be 1. 1 square will be 1 only. What will be the mode of j 1 by 2? That would be 1 by 2. What is the square of 1 by 2? That would be 1 by 4. What would be the square of 1 by 4? That would be 1 by 16. What would be the square of mode of c of minus 1? That would be 2 only. What will be the square of 2? 4 plus 16. Okay, why I put equal here? Plus 4 plus 16. So let's calculate, and let me calculate it and I will see what answer we are getting. Yeah, so we are getting 21.3125 watt. So this is the power we are getting. So that's the answer. But the conclusion would have been clear to you. I hope the conclusion is clear. Okay, so let's write down the conclusion now. What is the conclusion? That power of xt, that would be given as, this is the power of xt. There are multiple formulas. So let's write down the formulas in this manner. What will be the first formula? Power of xt. This can be given as mod of c naught square plus n goes from 1 to infinity mod of an square plus mod of bn square divided by 2. What is the other formula? N goes from minus infinity to infinity mod of cn square. Both of them are always applicable, always applicable, always true. Okay, but power of xt is equals to mod of c naught square plus summation n goes from 1 to infinity mod of cn square, but twice of this, right? Do you need to mug up any of them? No. If a concept is clear, like a1, a2, a3, all will be square divided by 2. So you will be able to write down all these things. Nothing you need to mug up. That's why I started from here. That's why I started from here. That here you will remember, okay, a sin omega naught t, b sin omega naught t, a sin omega naught t plus a1 sin omega naught t, b1 sin omega naught t plus b2 sin 2 omega naught t plus b3 sin 3 omega naught t. In the same manner with cosinusoid as well. So if in that manner it is given, then a square by 2 plus a square by 2, a square by 2. So it will be easy for you to remember. So here this final result you don't need to mug up. It should be there in your mind that what we are doing. Okay, there will be complex exponentials. If complex exponentials are there, that means mod of cn square, that this is what we are doing. Now mod of c of 1 could be equals to mod of c of minus 1. But that is only true. This is only true when your xt is purely real or purely imaginary, right? If xt is purely real or purely imaginary, then only this is true. Okay, so if that is true, then this kind of formula also we can develop, mod of c naught square plus 2 into summation n goes from 1 to infinity mod of cn square. So this kind of formula we can develop, and this is only true when xt is purely real or purely imaginary. So nothing you need to mug up, right? Only true if xt is purely real or purely imaginary. Not true if xt is complex. Let's go to the next one. So there is a special note. What is the meaning of power of third harmonic? What do you mean by third harmonic? Let's just say this is my xt. Xt is some dc plus a1, not a1, with a always cos comes. So a1 cos omega naught t plus a2 cos 2 omega naught t plus a3 cos 3 omega naught t and so on, plus b1 sin omega naught t plus b2 sin 2 omega naught t plus b3 sin 3 omega naught t. So this is known as third harmonic. Okay, this is known as fundamental frequency. This is your fundamental frequency. This is known as second harmonic. There is nothing called first harmonic. First harmonic means fundamental frequency only. This is known as second harmonic. 2 is there, no? 2 omega naught means second harmonic. Okay, this is known as third harmonic. Well and good. This is also third harmonic only. Third harmonic. So if I am writing my xt, I am only writing the third harmonic. What I am doing? I am only writing the third harmonic. So what will be my third harmonic? My third harmonic would be b3 sin 3 omega naught t plus a3 cos 3 omega naught t. And in complex exponential, what it would be? c3 e to the power j 3 omega naught t plus c of minus 3 e to the power minus j 3 omega naught t. This is my xt of third harmonic. Only third harmonic I am writing. If I need to find power of xt for third harmonic only, power of only third harmonic, power of third harmonic they are asking. So if I only need to write down the power of third harmonic only, what that power would be? Mod of b3 square by 2 plus mod of a3 square by 2. That's it. Or it could be equals to mod of c3 square plus mod of c of minus 3 square. That's it. Is that clear to you or not? Power of third harmonic. This concept is very easy. I just wanted to tell you the meaning of harmonic here. Omega naught is known as fundamental frequency. Fundamental frequency. 2 omega naught is second harmonic. It is not first harmonic. It is second harmonic only. Directly it is second harmonic. What is 3 omega naught? Or you can call it first harmonic as well. Okay, you can call it first harmonic. 3 omega naught is third harmonic. In that manner. Okay, 100 omega naught will be 100th harmonic. So in complex exponential, we will write down in this manner: c3 e to the power j 3 omega naught t plus c of minus 3 e to the power minus j 3 omega naught t. And in trigonometric, how we will write down? In trigonometric Fourier series, we will write down b3 sin 3 omega naught t plus a3 sin 3 omega naught. Sorry, b3 sin 3 omega naught t plus a3 cos 3 omega naught t. So these are the third harmonic. We need to write down the power associated with these harmonics. That would be mod of b3 square by 2 plus mod of a3 square by 2. So this I can write down mod of b3 square plus mod of a3 square divided by 2. Same goes here, mod of c3 square plus mod of c of minus 3 square. Power up to third harmonic. What is the meaning of power up to third harmonic? Up to means one first harmonic, second harmonic, third harmonic and DC as well. DC can be called as zeroth harmonic. So DC will also come. Power up to third harmonic. So if you write down your xt up to third harmonic, what that would be? DC plus all these things. This we have written up to third harmonic. This is your xt up to third harmonic. If I don't write down dot here, so this is your xt up to third harmonic only. Are you able to understand this point? Okay. So if I need to write down the power up to third harmonic, power of xt up to third harmonic. So what that would be? DC square plus mod of a1 square by 2 plus mod of a2 square by 2 plus mod of a3 square by 2 plus mod of b1 square by 2 plus mod of b. In that manner we will go. So what I can write down? Summation n goes from 1 to 3. N goes from 1 to 3. Mod of bn square plus mod of an square divided by 2. Is that okay for you? Mod of c0 square plus mod of a1 square by 2 plus mod of a2 square by 2 plus mod of a3 square by 2 plus mod of b1 square by 2 plus mod of b2 square by 2 plus mod of b3 square by 2. This is how we can write it down. And what else? In case of complex exponential, what that would be? C naught plus C1 e to the power j omega naught t plus C2 e to the power 2 j omega naught t plus C3 e to the power 3 j omega naught t plus C of minus 1 e to the power minus j omega naught t plus C of minus 2 e to the power minus 2 j omega naught t plus C of minus 3 e to the power minus 3 j omega naught t. Is that clear to you? I hope you are able to replicate. I hope you are able to resonate with whatever that I am saying. Right? In complex exponential, basically C naught will be non-zero. It might be 0, it might be non-zero, but up to third harmonic, if they are asking me to write down, so these things I will write down. C of 1, C of 2 and C of 3. Along with that, C of minus 1, C of minus 2 and C of minus 3. Right? So, C naught square plus summation goes n goes from minus 3 to 3 mod of Cn square. So this would be the power up to third harmonic. Is this discussion clear to you? I hope this discussion is easy for you to remember, and you don't need to remember anything here. This is just a pure concept. Meaning of harmonic. All good. Let's see the questions now. So you need to find out the Fourier series coefficient of this particular signal. You need to find out an, bn, cn. An, bn, cn. These things you need to find out. What is the first task? Always find the fundamental frequency. Always you need to find the value of omega naught. Right? So here omega naught 1 is pi and here omega naught 2 is 2. What was the task? Always it will be periodic if omega naught 1 ratio omega naught 2 is rational, then only it will be periodic. But omega naught 1 divided by omega naught 2 is equals to pi by 2, which is irrational. What does that mean? It is non-periodic, and if it is non-periodic, that means Fourier series is not defined. There you go. Fourier series is not defined, because Fourier series is defined only for periodic signals. So here only the problem is done. You don't need to find a and b and c n here. A and b and c n are not even defined. We are only talking about periodic signal here. So Fourier series is not defined. Okay, let's go to the next one. Here it will be defined, right? Because what is the value of omega naught 1? Omega naught 1 is 2 pi by 3. What is the value of omega naught 2? That is 5 pi by 3. So what do you think? What will be the omega naught? That would be HCF of 2 pi by 3, 5 pi by 3. That can be written as HCF of 2 pi 5 pi divided by LCM of 3 and 3. So HCF of 2 pi and 5 pi. The highest number which can divide 2 pi and 5 pi. So that number would be pi. LCM of 3 and 3 will be 3 only. So what is your omega naught? Omega naught is 3. Sorry, omega naught is pi by 3. So omega naught is coming out to be pi by 3. So omega naught is coming out to be pi by 3. So what is your xt? Xt is 2 plus, always this is the first task, then you write down your xt in this manner. Plus 5 sine 5 omega naught t. There you go. Okay. So from here, can you let me know what is the value of C naught? That is equals to 2. C naught value is 2. What is the value of A1? A1 will be 0. Why is that so? Because A1 will come with cos omega naught t. That is not there. A2 cos 2 omega naught t. So yeah, this is there. So A2 is equals to 1. What is the value of B1? That is 0. What is the value of B2? That is also 0. Because B1 sin omega naught t plus B2 sin 2 omega naught t plus B3 sin 3 omega naught t plus B4 sin 4 omega naught t plus B5 sin 5 omega naught t. So B3, B4, everything is 0. But what is the value of B5? B5 is 5. So A2 is 1, B5 is 5. Rest all the things here. A3, A4 and so on. all are 0. So C0 is non-zero, A2 is non-zero, and B5 is non-zero. What we need to find? We need to find Cn as well. So can we find Cn as well? Surely we can find Cn, right? So in Cn, C of 2, C of minus 2, C of 5 and C of minus 5 will be non-zero. Rest all will be 0. Okay. So do we have the page? Yeah. So we have the page. So if I need to find C1, what formula I can apply? A1 minus JB1 by 2. What is the value of A1? 0. What is the value of B1? That is also 0. So 0 minus J0 by 2. 0 only. Someone will say that, sir, I will break down into complex exponential and then I can find it. Yes, you can find it. Basically, someone will say that, sir, I will break down my xt as 2 plus cos 2 omega naught t. It will be e to the power j2 omega naught t plus e to the power minus j2 omega naught t divided by 2. So here 1 by 2 divided by 2 divided by 2. And next, here it is 5. 5 e to the power j omega naught t minus 5 e to the power, here it was 5 omega naught t, sorry, 5 omega naught t minus e to the power minus 5 j omega naught t divided by 2j divided by 2j, right? So what is the value of C naught? C naught is 2. What is the value of C2? Directly C2 is coming here. That is 1 by 2. Because e to the power j omega naught t is not even there. E to the power 2 j omega naught t is there. That means this is C2. What is the value of C of minus 2? That is also 1 by 2. What is the value of C of 5? That is 5 by 2j. And what is the value of C of minus 5? That is minus 5 by 2j. And we can find out in this manner what will be C2. C2 will be A2 minus JB2 by 2. B2 is 0, A2 is 1. So 1 by 2. C2 will be 1 by 2. What will be C of minus 2? A2 plus JB2 by 2. B2 is 0 and A1 is 1. Again 1 by 2. What will be the value of C of 5? A5 minus J5 by J, A5 minus JB5 by 2. So A5 is 0, A5 is 0, B5 is 5. So what we are getting? Minus 5j by 2. And what will be C of minus 5? C of minus 5 will be A5 plus, here this is 5 by 2j, it can be written as minus 5 by j divided by 2, right? Because j can go upward, so that will become minus j. So minus 5j by 2. And what about this one? 5j by 2. So here what we are getting? JB5 by 2. So what is the value of B5? That is 5. So 5j by 2. A5 is 0. So just basic simple mathematics, simple concept is there, nothing else. Break down your xt in any way that you want to break down. So this discussion was not needed here. So what I will do, I will just pick it up in this manner. And if someone wants to find C of, let's just say C of 1, that would be equals to A1 minus JB1 by 2. So A1 is also 0, B1 is also 0, all are 0, so everything will be 0 only. So these are non-zero. C of 0 is non-zero, C of 2, C of minus 2, C of 5 and C of minus 5, right? And if you need to find out the power, then just by the using the concept of basics of signal, can I find out the power? Yes. 2 square 4 plus a square by 2 1 by 2 plus a square by 2 25 by 2, right? This is using the concept of basics of signal. So what we are getting? 13 plus 4 17, right? Or what could be the way? DC square 4 plus a2 square by 2 1 by 2 plus b5 square by 2 25 by 2. So 13 plus 4 17 again. Or what I could have done? C0 square plus C2 square 1 by 4 plus C of minus 2 square 1 by 4 plus mode of C of 5 square. Mode, we need to take mode, right? So it would be 5 by 2 square, that means 25 by 4 plus, what about this one? This will also be 25 by 4. So what is the answer we are getting? 17. So power is coming out to be 17 in all three cases. So when I ask the power, in the examination you will not find the coefficients. You will directly do the basics of signal a square, sorry, dc square plus a square by 2 plus b square by 2. That's it. This is the power. And if I ask you the coefficient, then you can find out the coefficient as well. Just by looking at the question only, I can write down the coefficient. In the examination, I will not have to do all this process if I have good practice. I will see, okay, this is 2 omega naught, this is 5 omega naught, this is 5 omega naught. That means a2 will be 1 and b5 will be 5. That's it. I will be able to write down. From there, I can write down c of 2, c of minus 2 and c of 5, c of minus 5 as well. Here I will see e to the power 2j omega naught t. So 1 by 2, 1 by 2, then 1 by 2j and minus 1 by 2j will come. So 5 by 2j minus 5 by 2j. So all this calculation I can do in my mind only. This calculation I can do in my mind. If I am able to do the calculation, then I will be able to write down these things as well. I don't need to do this calculation. Say yes or no. And here I could have applied this formula. Mod of c naught square plus summation goes from 1 to infinity mod of cn square. Why I could have applied it? Because here my x of t is real. If this is real, then I can apply this formula. And you can check here, mod of c of 5 is equals to mod of c of minus 5. This is also 5 by 2, this is also 5 by 2. This is 1 by 2, this is also 1 by 2. So if mod is equal, then you can apply this formula. Okay, well and good. Let's go through this question. So what is the value of omega naught here? This is the value of omega naught, right? This is the value of omega naught. So omega naught is pi by 3. So how will I write down my xt? Xt is 3 sine omega naught t minus pi by 6. This is how I will write down my xt, right? So here omega naught, right? Here what is there? Omega naught. So if omega naught is there, that means this is first harmonic. What does that mean? That b1 value is 3. And this is what you did, and this is wrong. Why it is wrong? Because when we wrote down xt, what we wrote down? dc plus a1 cos omega naught t plus a2 cos 2 omega naught t. In the same manner, we kept on going. Same goes for b1 sin omega naught t plus b2 sin 2 omega naught t. So what was the angle here? Angle was omega naught t, 2 omega naught t, omega naught t, 2 omega naught t, 3 omega naught t. Was there any other phase? This pi by 6 was not there. Here I did not write cos omega naught t plus 5. Here I did not write 2 cos omega naught t plus 5. Omega naught t plus phi 1. 2 omega naught t plus phi 2. No. There is no phase. So why this phase is coming? If this phase is coming, that means you cannot say b1 is equals to 3. So this you cannot analyze in this manner. What you need to do? You need to open it up. xt is 3. Can you open this formula? Sin a minus b. So sin a cos b. Sin a cos b. What will be the value of b minus pi by 6? Pi by 6 is 30 degree, right? So cos 30 under root 3 by 2. Sin a cos b minus cos a sin b. So cos pi by 3 sin b 30 1 by 2. So this is how I will open it up. So what I am getting? 3 under root 3 by 2 sin pi by 3 sin pi by 3t minus 3 by 2 cos pi by 3t. And from here now I can tell that, and in place of pi by 3 I should have already put omega naught. Here why I am writing pi by 3? I should have already put omega naught here. Sin omega naught t cos omega naught t sin omega naught t cos omega naught t. So from here I can tell that this will be my b1. b1 is 3 under root 3 by 2. And what is my a1? a1 is minus 3 by 2. There you go. Okay. Say yes or no, right? And what is the DC value here? DC value is 0. And from here directly you can see that C of 1 and C of minus 1 will be defined. So xt is coming out to be 3 under root 3 by 2 sin omega naught t minus 3 by 2 cos omega naught t. 3 by 2 cos omega naught t. So I can break it down, or from here only I can find out. Basically what I need to find out, C1. So C1 will be A1 minus JB1 by 2 So a1 is minus 3 by 2 minus 3 by 2 minus j 3 under root 3 by 2 and divided by 2. So what I am getting, c1 is minus 3 by 4 minus j 3 under root 3 by 4. This is your c1. And what will be your c of minus 1? C of minus 1 is a1 plus jb1 by 2. So just the plus sign will come here, nothing else. C of minus 1, only this sign will be plus. So minus 3 by 4 plus j 3 under root 3 by 4. So this will be your C of minus 1. Or you could have done another process here, that would have been e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j minus 3 by 2 e to the power j omega naught t plus e to the power minus j omega naught t divided by 2. So what we will be getting? What will be the factor of e to the power j omega naught t? So directly I can see here, this will be minus 3 by 4, this will be 3 under root 3 divided by 4j, and this j can go upward. So minus 3 by 4, and if j goes upward it will become negative, so 3 under root 3 divided by 4j. This is the factor of e to the power j omega naught t. And what about here? Minus 3 by 4, this is your minus 3 by 4, and this j goes upward, so minus sign will become plus sign, so plus 3 under root 3 divided by 4j. So this is the factor of e to the power minus j omega naught t. So this is your C of 1 and this is your C of minus 1. So n number of ways are there, any way you can use. What about the power? So if it was a question based on basics of network, how I would have told the power? A square by 2, that's it. So 9 square by 2, right? Because only one sinusoid is there, na? You do not need to think orthogonal, non-orthogonal, nothing you need to think, right? Directly a square by 2, no matter whatever the phase is there. A sine omega t plus phi. What is the power? A square by 2 mod of a square by 2 I should write down, because this could be imaginary as well. So that's why mod of a square by 2, right? This you already know. There you go. Same thing here. What will be the power? So here power will be 3 square by 2. That would be 4.5. Or if you go by this, a1 square by 2 plus b1 square by 2. Basically what you will do, a1 square plus b1 square by 2. So what will be a1 square? That would be 9 by 4. a1 square will be 9 by 4 plus, what about b1 square? That would be 9 into 3 by 4, right? 27 by 4, because 3 square will be 9, under root 3 square will be 3 divided by 2 square, that would be 4. So 27 by 4. 27 by 4 divided by 2. So this will be 36 by 4, 9 by 2. So what is the answer? 4.5 again. We will get the same answer, that is pretty obvious. Next, what you would have done? Mod of c1 square plus mod of c of minus 1 square. Here I can see that mod will be same only. So what will be the mod? So a square plus b square. And this will be multiplied with 2, because this will also have the same mod, no? A square, here a is minus 3 by 4, square will eat up the negative sign. Here it is 3 under root 3 divided by 4 square. 9 by 16 plus 27 by 16 and 9 by 16 plus 27 by 16. 9 by 16 plus 27 by 16. So what will be the answer? 36 by 16 into 2. It would be 8. 8 4 is 32. If you solve this, it will become 4.5 only, which is pretty obvious. It should become 4.5 only, because from here as well 4.5, 4.5. So here also it will be 4.5. So 3 ways are there. From all 3 ways, here also I should have put mod, but luckily it was a real value, so it was not of any impact. So always 4.5 is coming. So is that clear to you? Basic problem we are solving, but we are just looking at everything. In the examination, if only power they are asking a square by 2, that's it. They might ask only a1 and b1. So you will open it up, you will write down a1 and b1. They may ask c1 and c of minus 1. So whatever that they can ask from this particular question, that has been solved in this example only, right? Let's go to the next one. Cn, an, bn you need to find out, and you need to find out the power as well. If they are asking the power in the examination hall, what you will do? Orthogonal to each other. So 2 square, what will be the power? 2 square dc square plus a square by 2 plus b square by 2. That's it. So 4 26 by 2, that would be 13 plus 4 17. This is your answer. If this question was asked in the examination hall, you will not do a and b and cn calculation. But what if they ask you a and b and cn as well? So what you are going to do? This will be kept as it is. First thing is a and b and cn. What is the first thing? Always find out the omega naught value. So what is omega naught 1 here? You can see 2 pi by 3. What is omega naught 2 here? 5 pi by 3. So what will be the value of omega naught here? You need to take the HCF of 2 pi by 3 and 5 pi by 3, which we have already done, was coming out to be pi by 3, right? So here if I put, what will be my xt? Xt is 2 plus cos 2 omega naught t plus 5 sin 5 omega naught t plus pi by 3. Pi by 3 is 60 degree. But this is something that is creating the problem. From here I cannot comment that this will be, from here I can comment that this will be my a2. That's for sure, because 2 omega naught t is there, so it will be my a2. But I cannot say that this will be my b5. So for that I need to open it up. First you open it up and then see what happens. So 2 plus cos 2 omega naught t plus 5 sin 5 omega naught t sin a cos b, cos pi by 3. What is cos pi by 3? Cos 60, that is 1 by 2 plus 5 cos a sin b, sin pi by 3. What is sin pi by 3? Sin 60, that is under root 3 by 2. Now I can comment. What I can comment? That my DC is 2, my A2 is 1, B5 is 5 by 2, and A5 is, here it was 5 omega naught t. I am not doing anything, I just applied the formula of sin A plus B. So sin A cos B plus cos A sin B, and A5 is 5 under root 3 by 2. And from here also you can calculate the power. What will be the power? DC square plus A square by 2 plus B square by 2, sorry, B square. A square is, the A2 square is 1 square by 2. B5 square by 2. B5 square. So 25 by 4 divided by 2, 25 by 8 plus 5 under root 3 by 2 square divided by 2. So 5 under root 3 by 2 square, what that would be? 25 into 3 divided by 4 into 2. So 75 by 8. 75 by 8. So what we are getting? 100 by 8, that would be 25 by 2 only, right? And 25 by 2 plus 1 by 2 plus 4, that will come out to be 17 only. Basically C0 square plus A2 square by 2 plus B5 square by 2 plus A5 square by 2. This is what I am doing. All these formula, whatever that I have taught, all those formula only we are applying, and we are getting the same expression of power as well. Same you can go with the same you can do with the exponential Fourier series as well. So you need to find out the coefficient of exponential Fourier series. What you need to find out? You need to find out C2, C5, C of minus 5 and C of 5, and C of 0 is 2 only. So what you are going to do? You are just going to open it up. So what is your xt? Your xt is 2 cos 2 omega naught t plus 5 sin 5 omega naught t plus pi by 3, right? So directly from here if I try to write down, what I will get? E to the power j 2 omega naught t plus e to the power minus j 2 omega naught t divided by 2 plus 5 e to the power j 5 omega naught t plus 5 by pi by 3 minus e to the power minus j 5 omega naught t plus pi by 3 divided by 2j, right? So 2 plus 1 by 2 e to the power j2 omega naught t plus 1 by 2 e to the power minus 2j omega naught t plus 5 by 2j e to the power j pi by 3 I will take outside, because in my expression only e to the power j 5 omega naught t should be there, only this should be there, so this should be outside, right? Minus 5 by 2j e to the power minus j pi by 3 e to the power minus j 5 omega naught t. So from here c naught value is coming out to be 2, c2 value is coming out to be 1 by 2, c of minus 2 value is coming out to be 1 by 2, c of 5 is coming out to be 5 by 2j e to the power j pi by 3. So this is 90 degree, this goes upward, it becomes minus 90, right? So what I can do, 5 by 2 e to the power j pi by 3 minus pi by 2, say yes or no? 1 by j is minus j and minus j is e to the power minus j pi by 2. So that thing I have done. And if two exponentials are in multiplication, that means their power can be added. So this is what we are getting. Say yes or no? Right? And here also it will be added. So c of minus 5 will be minus 5 by 2 e to the power minus j pi by 3 plus pi by 2 here. Here it will be plus pi by 2. Why it is plus pi by 2? Are you able to understand the point? Because this will also become minus, 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 both will be added. So one more thing we can do here, 5 by 2 e to the power j minus, what is the meaning of minus sign? Minus 1 is equals to e to the power j pi. E to the power j pi is minus 1. Say yes or no? E to the power j pi is equals to minus 1 only. Because cos pi plus j sin pi is 0. So e to the power j pi is minus 1 only. So what I can do, I am ignoring this minus sign and it can be written as e to the power j pi. So e to the power j pi minus pi by 3 minus pi by 2. Say yes or no? Did you understand this point? What I did here? So minus 1 was, this minus 1 was e to the power j pi. In the multiplication, e to the power minus j pi by 3 and e to the power minus j pi by 2 was also there. Right? Say yes or no? So from here, pi minus pi by 3 minus pi by 2 I wrote down. Right? So pi by 2 minus pi by 3, what that would be? Pi by 2 minus pi by 3. So this is 90 minus 60. So this will be 60. Because pi minus pi by 2 will be pi by 2, pi by 2 minus pi by 3 will be, this is 30 degree. So pi by 2 e to the power j pi by 6. And here what we are getting? Pi by 2 e to the power minus j pi by 6. So this was your C5 and this is your C of minus 5. Say yes or no? Because if you had find out from here, if you had find out from this expression, then you would get the same answer only. Okay, cos omega naught t into 3 by 2, if you had find out from here, then you would get the same answer. Basically I started my calculation from here. If I had started my calculation from here, then I would have directly got this answer. Are you able to understand this point? So this is your C of 5, this is your C of minus 5. Simplified expression. Basically these are the simplified expression. I just have removed j and minus j, all these things I have removed, and this kind of simplified expression we are getting. Here also this kind of a simplified expression we are getting. This is C naught, this is C2 and this is C of minus 2. And from here as well you can find out the power, right? Say yes or no? From here as well you can find out the power. How will you find out the power? It is very easy. What we need to do, power will be mod of C naught square plus 1 by 2 square plus 1 by 2 square plus, what will be the mode of a e to the power j theta? What is the mode of a e to the power j theta? That is a only. So 5 by 2 square plus here also 5 by 2 square. So what we are getting? 4 plus 1 by 4 plus 1 by 4 plus 25 by 4 plus 25 by 4, right? So what we are getting? 70, right? So this is the answer. Here also it was 17, here also it was 17, here also it is 17. This is how we have calculated all the coefficients as well. So not tough, right? Let's check the calculation for this question. I hope the calculation is correct. E to the power j pi by 3 goes outside, 2j comes outside, e to the power minus j pi by 3 goes outside, then 2j goes downside, minus j becomes plus j, so pi by 2 minus pi by 3, and here it becomes minus pi by 2 plus pi by 3. Yeah, everything is correct. So this is how we need to find out. Same kind of questions are there. Again the same kind of questions. Now what I am asking, find out the total power, then you find out the power up to 20th harmonic, then find out the power up to 500th harmonic, and then I am asking you the value of a n, b n and c n. So try doing this question on your own. I will take a break and then I will come back. So do it on your own. In the examination, how you would have solved the problem, in that manner you need to solve. In the examination, if this question is coming, how would you solve it? If this question is coming, how would you solve it? If this question is coming, then how would you solve it? And if this question is coming, how would you solve it? It might happen that you need to find out a n, b n, c n for calculating these things, or it might happen that you don't need to find out a n, b n, c n for calculating these things. So I want to see, for calculating first 3 questions, will you calculate a n, b n and c n? What I am saying, for calculating the answer of first 3 questions, will you find out a n, b n and c n? The answer is no. You don't need to find out a n, b n, c n for calculating the answer of first 3 questions. How? Just think about it and then write down your answer. Well and good. So I will take a pause and then I will come. Yeah, welcome back. So did you try this one? First, what we need to find? Total power we need to find. 3 pi by 4, 4 pi, 0.7 pi, 15 pi. All are orthogonal to each other. So what will be the power? Power will be a square by 2 plus b square by 2 plus 15 square by 2 and minus 15 square by 2, right? 225, 225, 450, 450 plus 25, 475, 475 plus 100, 575, 575 by 2 watt. This is the power. So no need to calculate any coefficient or anything like that. Find the power up to 20th harmonic. So 20th harmonic. So first we need to find out what is the first harmonic, right? That means we need to find out the value of omega naught. So what will be your omega naught? Omega naught will be HCF of 3 pi by 4, 4 pi, 0.7 pi, 3 pi by 4, 4 pi by 1, 0.7 pi means 7 pi by 10, and then 15 pi by 1. So that would be equals to HCF of 3 pi, 4 pi, 7 pi, 15 pi, what that would be? HCF of all these will be pi only, divided by LCM of 4, 1, 10 and 1. What will be the LCM? LCM will be the smallest number which is divided by 4 and 10. What that would be? 20, right? So omega naught value is pi by 20. This you can calculate, right? Omega naught value is pi by 20. So now what do you think? What is this? Xt is tan cos. Now you need to write down this particular frequency, or you can say this particular angle in terms of omega naught, right? Omega naught minus pi by 6. So you need to write down this in terms of omega naught. So what is given? 3 pi by 4. So 3 pi by 4 is given. That is equals to n omega naught. So 3 pi by 4 is equals to n into pi by 20. So what you are getting? 15, right? So 15 pi by 20. Basically this is your 15 omega naught. This is your 15 omega naught. Say yes or no? Because 15 into omega naught. What is omega naught? Pi by 20. So what you are getting? 3 pi by 4. So here 3 pi by 4 was written. So this will be 15 omega naught. This is the first term. What about the second term? Minus 5 pi minus 5 cos. Here also something omega naught into t would come, right? Something omega naught into t would come. So 4 pi should be written as n omega naught. So 4 pi is equals to n into omega naught is pi by 20. So what will be the value of n? That would be 80. So this would be 80 omega naught. And you can check as well 80 into pi by 20, what that would be? 4 pi only. If you are able to think directly, then you can think directly, otherwise you can do this calculation, right? Next one, 15 15 sine 0.7 pi. 15 sine 0.7 pi into t. 0.7 pi should be written as n omega naught, right? So pi got cancelled, n is equals to 14. So 14 omega naught, right? And what is the value of omega naught? So what you are getting? 0.7 pi only. So cross check also I can do. In the last, minus 15 sine 15 pi, minus 15 sine 15 pi. 15 pi should be written as n omega naught. So that would be equals to 300. So 300 omega naught t. So this will be your xt. What they are saying, power up to 20th harmonic. So what is this? This is 15th harmonic. 15th harmonic. What is this? This is 80th harmonic. What is this? 14th harmonic. And what is this? 300th harmonic. So power up to 20th harmonic, that means this and this will come into action. That's it. So again, you don't need to find a and b and anything. Just what you need to do, you need to find out which harmonic is that. This was your 15th harmonic. Next was your 80th harmonic. Next one was your 14th harmonic, and this was your 300th harmonic. They are asking till 20th harmonic. That means this and this will come into action. So your power till 20th harmonic, power up to. That means from 1 to 20, sorry, from 0 to 20, everything you can take. So between 0 to 20, what will come? 15th and 14th will come. DC value can also come, first harmonic can come, second harmonic can come, 4th, 7th, 9th, 10th, 14th, 15th, 19th, even 20th harmonic can also come. But here only 2 harmonics are there which are less than 20. Power up to 20th harmonics they are saying. That means this and this should be in action. What does that mean? The power would be 10 square by 2. It was 10 only, right? 10 minus 5, 15 minus 15. So 10 square by 2 plus 15 square by 2. What that would be? 225 plus 100, 325, right? Divided by 2. 325 divided by 2. This is the power up to 20th harmonic. 225 plus 100, 325 divided by 2. Next, what they are saying, power up to 500th harmonic. 500. This was B. In the C, they are saying power up to 500th harmonic. What does that mean? Before 500, everything can come. 500 and before 500. That means from 0 to 500, everything can come. From 0 omega naught to 500 omega naught, everything can come. And here, from 0 omega naught to 20 omega naught, everything can come. So from 0 to 500 omega naught, that means this can come, 15 omega naught can come, 80, 14 omega naught and 300 omega naught, everything can come, right? Because 500 omega naught, less than 500 omega naught and 500 omega naught included as well. So less than 500 omega naught, everything is there. That means everything would come. What does that mean? The power will be 575 by 2 only. 575 by 2 watt. Up to 500th harmonic. That means all these will come. Now you need to find out AN, BN and CN. This will be a long process, right? Because you need to open this up. Just only this you need to open up. That's it. Okay, so it will not be that long. So let's open up XT. So only first I need to open up, nothing else. So let's open up. XT is equals to tan cos A minus B I am applying. So what is cos A minus B? Cos A cos B plus sin A sin B, right? Cos A minus B. Cos A minus B. So what is cos A plus B? Cos A cos B minus sin A sin B. Yeah, okay. So this is cos A cos B minus sin A sin B. Sorry, plus sin A sin B. So cos A minus B formula is cos A cos B plus sin A sin B. So cos 15 omega naught t into cos pi by 6. Tan is there. So tan cos omega naught t, not omega naught t, it is cos 15 omega naught t. I am just applying the formula, nothing else. Cos 15 omega naught t, cos A cos B, 30 degree, under root 3 by 2, right? So 5 under root 3, this would be 5 under root 3. Cos A cos B plus sin A sin B. So this would be tan sin omega naught t. Tan is already in the multiplication, so tan sin omega naught t into sin 30, right? Sin 30, yeah, so that is 1 by 2. So into 1 by 2, so that would be 5. So 5 sin 15 omega naught t. So this will be 5 sin 15 omega naught t. We did nothing, we just applied the formula cos A cos B minus sin A sin B. So tan cos 15 omega naught t cos pi by 6, that is under root 3 by 2, because cos 30 is under root 3 by 2 only, right? So that would be 5 under root 3 cos 15 omega naught t, then tan sin A sin B. So sin omega naught t as it is, then sin pi by 6 is 1 by 2, so 5 sin 15 omega naught t. And what is the formula of cos A minus B? That is formula of cos A minus B, that is cos A cos B plus sin A sin B, plus sin A sin B. How you can check? If you put A is equals to B, then cos 0 will be 1. If I put A equals to B, so it would be cos square A plus sin square A, that would be 1 only. Just you need to put A is equals to B. So cos 0 would be equals to cos A cos square A plus sin square A. Is this equation satisfied? Yes. That means this formula is correct. So whenever you forget the formula, just put any condition, and if that is satisfied, that means your formula is correct. So in that manner we have written first term. Next all term will come as it is. So minus 5 cos 80 omega naught t, minus 5 cos 80 omega naught t plus 15 sin 14 omega naught t, plus 15 sin 14 omega naught t minus 15 sin 300 omega naught t, right? All good. 5 minus 5 15 minus 15, minus 5 15 minus 15, 80 14 300, and here 15 15. Well and good. Okay then. So what I can see first, I can see B14. B14 is 15. Then I can see B15. B15 is 5. Then I can see A15. A15 is 5 under root 3. Then I can see this has been covered, this has been covered, this has been covered. Then I can see B50. Not B50, it is A50, sorry. With the cos, always A comes. So A50 is minus 5. And this is your B300. That is minus 15. Is that clear? All good? Right? Let's check back again. So from here I am getting A15 500 root 3. From there I am getting B15 5. Then I am getting A80. A80. Why I am writing 50 here? A80 it is. A80, not 50. Why I am writing 50? It is 80, no? So A80. A80 is minus 5. Then this is B14 is 15. And then this is B300 is minus 15. Right? So we are having 14, 15, 80 and 300. This was 80 only. 80 only, yeah. 14, 50, 80 and 300. These are the harmonics we are getting. Now I can find out the values in terms of our C14. Basically I can find out Cn as well. But do you want me to find out? You can find out on your own as well, right? What will be C14? That would be A14 plus JB14 by, not plus, minus, AN minus JBN by 2. So what that would be? Minus J, because A14 is 0. So from here what I am getting? Minus J15 by 2. And what about C minus 14? C minus 14 would be plus J15 by 2. Right? What about C15? So C15 would be an minus jbn by 2. Say yes or no. An minus jbn by 2. And what would be C minus 15? That would be an plus jbn by 2. All good, right? Next, 15 is done. Then C80, that would be minus 5 by 2, and C minus 80 will also be minus 5 by 2 only, because that would be an by 2, a80 by 2. And what about C300? C300, that would have been minus jbn by 2, minus j15 by 2. Since it is minus 15, so another minus sign would come. So j15 by 2. Are you getting this point? From here also you can check. It would be 1 by 2j. So that j would come upward, so 15j by 2 it will become. And what about C minus 300? That would become minus j15 by 2. So in that manner you can check all of them. Okay. A very, like, it is like a hectic process, but in the examination they will not ask these much things. In the examination, what is the most important part? These questions are the most important one. Up to that harmonic. Or they can ask what is the power of 14th harmonic? What is the power of 14th harmonic? That is 15 square by 2. What is the power of second harmonic? What is the power of second harmonic here? 0. Because second harmonic is not even there. What is the power of fifth harmonic? That is also 0. What is the power of 15th harmonic? That is 100 square by 2. What is the power of 300th harmonic? Minus 15 square by 2. What is the power of 10th harmonic? That is not even there. So power of 10th harmonic is 0. So these kind of questions can be asked. Okay. Right. So I hope that is clear to you. Let's go to the next one. This question is there. This is also from OpenM only. So in these kind of question, if I frame the option, then it will be very easy for you, because there will be 4 options. Then you can match xt is real and odd, xt is periodic. So options, like 4 things are given. These 4 things are given, and you need to determine xt. Now in the examination, options will be mentioned. So you can tally from the options that, let's just say first option is sine under root 2 pi t. Then you will see, okay, it is real and odd. Yes, first condition is satisfied. The time period is 2, not satisfied, so option is cancelled. In that manner you can check. But here I am framing it as a theoretical question. So let's start. What is the first thing they are saying? Xt is real. How will you solve it? Xt is real. So this thing I know, xt is real. So from here I can tell that this I can tell, right? Xt is odd. Xt is odd. So from here this is what I can tell. Okay. Next what they are saying, xt is periodic with t naught equals to 2. T naught is equals to 2. That means what is the value of omega naught? Omega naught is 2 pi by 2. Omega naught is pi. So value of omega naught is pi. Ak is 0 for what they have given. Ak means Cn, right? The Fourier series coefficient is Ak. That means this they are talking about Cn. So it is 0 for mod of k greater than 1. What does that mean? Mod of k greater than 1. That means k is greater than 1 and less than minus 1. Mod of k greater than 1. What does that mean? If k is minus 2, condition is satisfied, right? 2 greater than 1. And if k is plus 2, then also it is satisfied. That means k should be greater than 1 and k is less than minus 1. What does that mean? It is non-zero between minus 1 to 1. What does that mean? That c of minus 1 is non-zero. C of 1 is also non-zero. Xt is odd. Xt is odd. What does that mean? What will be the DC value of xt? What is the DC value, or you can say average of xt? That means what do you think, what should be the C naught value of xt? That should be 0 as well. Say yes or no. C0 has to be 0. Why is that so? Put n equals to 0 here. C0 is equals to minus C of minus 0. So C0 is equals to C minus 0 means C0 only. So C0 should be equals to minus of C0. From there what you are getting? 2C0 is equals to 0. From here what you are getting? C0 is equals to 0. Are you able to understand this point? from this question what they are saying, xt is odd. What does that mean? That these are equal. Now you put n equals to 0. So c0 is equals to minus c of minus 0. What is the meaning of c of minus 0? That means c of 0 only. Now this comes here. So from here what do you get? C naught is equals to 0. So what does that mean? That C naught is also 0. So what did you understand from here? That only C of minus 1 is non-zero and C of 1 is non-zero. That's it. Rest all are 0. That means your xt is C of minus 1 e to the power minus j omega naught t plus C of 1 e to the power j omega naught t. There you go. This much thing you have understood till now. Omega naught value also you know, that is pi only. So omega naught value also we know, that is pi. Omega naught value is pi. Omega naught value is pi. Right? So we have used this information as well, and first information as well, that it is real and odd. xt is real. This you need to keep in mind. xt is real. Okay. From here another thing we get to know, that c of 1 is equals to minus of c of minus 1. C of 1 is equals to minus of c of minus 1. What does that mean? C of minus 1, what I can write down? C of 1 as it is, this I am keeping as it is. C of 1 as it is, minus C of 1, because what I know is that C of 1 is equals to minus of C of minus 1. So C of minus 1 can be replaced with minus C of 1. Say yes or no? So from here what I can do? C1 is coming common, e to the power j omega naught t minus e to the power, here also minus sign is there. Basically C of minus 1 is replaced with minus of Cn. From here what I can see, C of minus 1 is replaced with minus C1. So here I am replacing with minus C1. So what I am getting? Right? What I can do? Divide by 2j, multiply by 2j. So what I am getting? 2C1 into j sin pi t. Say yes or no? Is that clear to you? Okay, so this is the xt I am getting. Now the matter of concern is C1. What is the matter of concern? Matter of concern is C1. So what they are saying? Power of xt is 1. What is this? Power, right? Power of xt is 1. What they are saying is that power of xt is 1. Can you find out the power from here? Yes. What will be the power? 2c1j mod of this divided by 2. A square by 2 mod of this divided by 2 is equals to 1. So from here what you are getting? 4c1 square, 4, 2 square will be 4, j square and then mod it will be 1. C1 square will be mod of C1 square is equals to 2. So mod of C1 is coming out to be 1 by under root 2. So what will be the value of C1? From here, what all values of C1 you can get? From here, 4 values of C1 I can get. C1 could be 1 by under root 2. C1 could be minus 1 by under root 2. C1 could be 1 by under root 2 j, and C1 could be minus 1 by under root 2 j as well. Because for mod of C1, when you take the mod, then imaginary part will be gone. This will also throw 1 by under root 2, this will also throw 1 by under root 2, this will also throw 1 by under root 2, this will also throw 1 by under root 2. What do you think, which one will be selected? X of t has to be real. If it has to be real, and let's just say I take C1 equals to 1 by under root 2. So what answer I will get? 2 into 1 by under root 2 into j sin pi t. Is it real? No. So C1 equals to, this is not accepted, this will also not be accepted. Why is that so? Because it is real. X of t is real. Are you getting this point? If x of t is real, you need to make this as real. This is already real. You need to make this as real. Now if you put C1 equals to real, then the whole number will become imaginary. So what I need to put? These I need to put. So these will be accepted. These will be accepted. Right? So from here what I will get to know is that my x of t would be, C1 value will be 1 by under root 2 j into j sin pi t into sin pi t into sin pi t. So what I am getting? Minus under root 2 sin pi t. This is your x of t. And what is the other possible value? If you put negative sign here, j into j will become -1, and that would become under root 2 sin pi t. So these are two possible answers. There you go. Although in the examination hall you will be doing by the options, you will check which one is real. Is it real? Yes. Is it odd as well? Yes, because sinusoid is odd. First condition is satisfied. It is periodic? Yes. Periodic with period 2? Yes. Periodic with period 2 as well, because omega naught is pi, so time period is also 2. So second condition is also satisfied. Third condition, ak is 0 for mod of k greater than 1. That means only c1 and c of -1 will be defined. Yes, only c1 and c of -1 is defined. Here what will be the value of c1? That will be c1 will be 1 by under root 2j, and value of c2 will be -1 by 2 under root k and -1 by under root 2j. Basically c1 and c of -1 is only defined. So that is also clear, right? Because here we know that c of 0 is also not there, c1 and c of -1 is there. That is also clear. Next, power. So what will be the power? A square by 2. Under root 2 square will be 2. 2 by 2 will be 1. So power is also defined. So 4 options will be given, no? So from there you can check. But here we used our brain. Basically, if a tough question is coming in the examination hall, let's just say this was easy only, but let's just say if they frame a good question where calculation is required, then in this manner you can do the calculation. You just need to see the question and you just need to follow the process whatever that we have studied, right? There is only little concept in Fourier series, only little concept is there. Rest everything is problem solving. So we are just doing the problem solving, nothing else. In the whole lecture there is only problem solving, right? So I hope you are able to understand all these kind of questions. These are good kind of questions actually. So I guess yes, that's it. Yeah, that's it about this video. In this video we have studied about power and then we saw this question. Now next we need to start some properties. So some properties we will see, then we will see some questions, then we will move to trigonometric Fourier series, and then again we will come back to properties. So this will be the flow. Look, I don't want to teach all the properties in one go, because if I teach all the properties in one go, you will take pressure of the properties. So that's why I will not even take the name of property. We will solve with respect to question. We will solve the properties with respect to questions. So question practice will also be done and you will learn the properties in a very good manner. Okay, but if I write down, okay, this is the property of Fourier series, you will mug it up. But here target is not to mug up the property. Here target is to understand the property, what property is saying and why that property is developed. So that is the target. Are you getting this point? And we will use those property in problems as well, so that you can understand the properties in a very good manner. So let's meet in the next lecture. We are going to see some properties of Fourier series, only some, not all the properties, only some properties we will see. Okay, so let's meet in the next lecture. Thank you very much. Yeah, welcome back. So in this video we are going to see some properties of exponential Fourier series coefficient. So this is like a property only, but we are solving with respect to a question, and then we will see the mathematics as well. Okay, but first let's see the question and let's try understanding the meaning. So x of t is given as sin t, right? X of t is given as sin t. You need to find out the Fourier series coefficient Cn for sin t. And what is the fundamental frequency? Here they are saying that fundamental frequency of sin t is given as omega naught, which is equals to 1, right? Here fundamental frequency of sin t is given as omega naught, which is equals to 1. You need to find out the Fourier series coefficient of this. So directly I can write down, I already know it would be c of 1 will be 1 by 2j and c of -1 will be -1 by 2j. Till this point you should be comfortable with all these things, right? E to the power jt divided by e to the power jt minus e to the power minus jt divided by 2j. So c1 will be 1 by 2j, c of -1 will be -1 by 2j. Say yes or no. And fundamental frequency is 1, right? Can I draw the graph of c of n? Yes. C of n versus n. C of n versus n. At n equals to 1, at n equals to -1. So positive negative you actually cannot define. So I am just showing this by positive, and okay, let's show this by negative and this by positive, because they are the imaginary numbers, so you cannot tell which one is positive, which one is negative. So this discussion we have already done. So this will be minus j by 2 and this is sorry this is -1 by 2j, -1 by 2j, and this is +1 by 2j. So this is the graph of C of n. Fundamental frequency is 1. Now what I am doing? X of 2t I am doing. So do you remember one thing, that x of t is having a time period of t naught. Then what will be the time period of x of alpha t? t naught by alpha, right? Because graph will be shrinked. Graph will be, let's just say this is my graph. Okay, this is minus t naught by 2. This cannot be minus t naught by 2. What I do is that, let's make a periodic waveform. This is the periodic waveform we are having. Okay, just a rough waveform I have made. So this point is 0 and this point is t naught. Now if I do x of alpha t, that means my time axis is, time domain is multiplied with alpha, that means time axis will be divided by alpha. So my time period will be t naught by alpha. I hope you remember this thing. This we have studied in basics of signal. X of t is having a time period of t naught, then x of alpha t will have a time period of t naught by alpha. Now what is the relation between omega naught and t naught? Opposite, right? So if time period has become t naught by alpha, then what will be my frequency? That will become alpha omega naught, right? So here my time period was t naught and my angular frequency was, fundamental frequency was omega naught. So here what will be my fundamental frequency? Alpha omega naught. Basically fundamental frequency and fundamental time period, multiplication of these two is constant. T naught into omega naught is always equals to 2 pi. Here also t naught by alpha into alpha omega naught, that would be equals to t naught omega naught, that will always be equals to 2 pi. So fundamental frequency and fundamental time period. If fundamental time period is being divided by alpha, then fundamental frequency will be multiplied with alpha. And this you can see here as well. What will be your x of 2t? That will be of sine of, in place of t, you need to put 2t. So x of 2t, sine of 2t. So just let me know what will be your fundamental frequency now. That is 2. Fundamental frequency is 2, which is equals to 2 omega naught. Basically here fundamental frequency got doubled. Fundamental frequency got doubled here. So if x of t is having a time period of t naught and fundamental frequency of omega naught, then x of alpha t will have a time period of t naught by alpha and fundamental frequency of alpha omega naught. All good? A very important point. But what will be the value of C of 1 and C of minus? Basically here the Fourier series coefficient is dn. So how will I find Fourier series coefficient? Omega 2. Omega 2 is 2. So basically this is its fundamental frequency. Always whenever we find Fourier series coefficient, our matter of concern is fundamental frequency. This 2 omega naught I am not going to write down. 2 omega naught is nothing. 2 omega naught is just the comparison with this fundamental frequency, nothing else. Here what I am going to write down, omega 2t, which is my fundamental frequency. Fundamental frequency. This is my fundamental frequency. So e to the power j omega 2t plus minus e to the power j minus omega 2t divided by 2j. Divided by 2j. Now this is first harmonic or second harmonic? This is first harmonic only. This is first harmonic, right? If I ask you to write down the Fourier series coefficient of sine 2t, what you will do? E to the power j 2t, e to the power minus j 2t divided by 2j divided by 2j. Will you call them second harmonic? No. This is the fundamental frequency only, no? If here e to the power j 4t was written, then you would have said that, okay, this is twice of fundamental frequency. But now this is the fundamental frequency only. So what this is d1 only. Your d1 is 1 by 2j and your d of minus 1 is minus 1 by 2j. Are you able to understand this point or not? Here fundamental frequency got doubled of x of t. So if I am finding Fourier series coefficient of xt, that is Cn, then Fourier series coefficient of x of 2t is also coming out to be Cn only. Why is that so? Because this is the graph I have made. So let's make the graph of d of n. What I am making? dn. This is my dn. So at n equals to 1, what I am getting? 1 by 2j. At n equals to minus 1, what I am getting? Minus 1 by 2j. So D2 same graph I am getting, right? Minus 1 by 2j and 1 by 2j. 1 by 2j and minus 1 by 2j. So this graph and this graph, both are D2 same. So what does that mean? Cn is coming out to be dn. So what did you understand from here? That your x of t is having a Fourier series coefficient of Cn, fundamental time period of t naught and fundamental frequency of omega naught. Then x of alpha t will have the Fourier series coefficient of Cn only. but fundamental time period of t naught by alpha and fundamental angular frequency of alpha omega naught. So here fundamental frequency got alpha omega naught times. The Fourier series coefficient remains as it is. The Fourier series coefficient remains as it is. Are you able to understand the point? Because 2 here is the fundamental frequency of x of 2t. If I call this as yt and I ask you what is the fundamental frequency of yt, what you will say? Sir, that is equals to 2. That means you will replace this as sine omega t. And if I am replacing this as sine omega t, that means e to the power j omega t minus e to the power minus j omega t divided by 2j. That means this is my d of 1, not d of 2. This is d of 1 and this is d of minus 1. So that means there is no change in the Fourier series coefficient, only the time period and fundamental frequency got changed, nothing else. Is that clear to you or not? Let's do the mathematics. Okay, let's do the mathematics. How will I represent x of t? X of t I represent n goes from minus infinity to infinity, c of n e to the power j n omega naught t. How will I represent x of 2t? So I am saying x of 2t is y of t. Okay, y of t, x of 2t is y of t, and the Fourier series coefficient of y of t is dn. This is what I am saying. The Fourier series coefficient of x of 2t is dn e to the power j. In place of t I need to put 2t. Here y of t. Okay, what I am saying is that this is the scene, right? This is the scene from here. Basically, if I call this as yt, so yt is having a Fourier series coefficient of dn. So dn e to the power j n omega naught t I am writing. I am writing with respect to yt, not with respect to x of 2t. Say yes or no? Are you able to understand this point? But here if I have written fundamental frequency as fundamental frequency, this is having fundamental frequency of omega naught. If this is having fundamental frequency of omega naught, so can I write down omega naught here? No. Why is that so? Because yt is having a fundamental frequency of 2 omega naught. Fundamental frequency. What will be the fundamental frequency of yt? Because x of t is having a fundamental frequency of omega naught, then yt, which is equals to x of 2t, will have the fundamental frequency of 2 omega naught. So here what do we write down? Here do we write down omega naught? No. Here we write down the fundamental frequency. So what I need to write down? So here fundamental frequency is 2 omega naught. So I have to write down 2 omega naught here. Are you able to understand this point or not? A very, very important point. Did you understand this point? If I am writing down the Fourier series coefficient, what I am saying, the Fourier series coefficient of y of t is dn and the Fourier series coefficient of x of t is cn. So how do we represent any random signal? We represent any random signal, n goes from minus infinity to infinity. Here Fourier series coefficient comes, then e to the power j n, here fundamental frequency comes t. This is a random signal. This is your signal. Say yes or no? So y of t is having a Fourier series coefficient of dn. Dn I have written down e to the power j. Fundamental frequency is 2 omega naught into t. Say yes or no? Is that clear to you or not? All good, right? Now what I need to do? This I am calling as equation 1 and this I am calling as equation 2. I need to compare equation 1 and 2. This is what I need to do, right? I need to compare equation 1 and 2. So I need to make equation 1 as equation 2. I need to make equation 1 as equation 2. So what I am doing, in equation 1, t is replaced with 2t. I am replacing t with 2t. So what will happen? X of 2t, summation n goes from minus infinity to infinity, c of n e to the power j n omega naught 2t. Now can you compare equation 2 and 3? If you compare equation 2 and 3, what will you get to know? That d of n is equals to c of n. Right? So from here, d of n is equals to c of n. So basically Fourier series coefficient never changes. This is the conclusion, right? Let's write down this in a good manner. Y of t is equals to x of 2t. So here Fourier series coefficient is not getting changed. Are you able to understand this point? So what is the conclusion? The conclusion is if x of t is having a Fourier series coefficient of Cn, fundamental time period of t naught and fundamental frequency of omega naught, then x of alpha t will have a Fourier series coefficient of Cn, fundamental time period of t naught by alpha and fundamental frequency of alpha omega naught. Will you be able to remember these things in your mind? That's it. Well and good. So this is the first property that we have seen. Next property we need to see, if I do a shifting in time, I am doing a shift. So in place of t, what I am putting, let's just call this as yt, and yt is having a Fourier series coefficient of dn. Just let me know one thing, if x of t is having a time period of t naught, then what is the time period of x of t plus t naught? X of t plus t naught. If I shift my signal, will the time period change? Let's just say this is my periodic signal. This is my periodic signal. This is my periodic signal. If I shift this signal, then time period will change? No. This waveform will be repeated after t naught time only. So time period will not change after shifting. So if x of t is having a time period of t naught, then x of t plus t naught will also have a time period of t naught only. Do you agree to this point? Right? So time t naught, fundamental time period also did not change. So fundamental frequency will also not change. So omega naught t naught. So matter of concern is dn. This I need to find. So what I am saying, this is my yt minus infinity to infinity, which is having a Fourier series coefficient of dn, and fundamental frequency is omega naught only. Fundamental frequency is omega naught only. All good? Now in this equation, what I am going to do, in place of t, I am going to put t plus t naught. In this equation, what I am doing, in place of t, I am putting t plus t naught. So what I will get, x of t plus t naught is equals to summation n goes from minus infinity to infinity, c of n e to the power j n omega naught t plus t naught. Omega naught t plus t naught. So what we are getting, n goes from minus infinity to infinity, c of n e to the power j n omega naught t naught e to the power j n omega naught t. This is your x of t plus t naught, which is equals to yt only. So let's call this as equation 1 and this as equation 2. If you compare equation 1 and 2, what do you see? That your d of n is equals to cn e to the power j n omega naught t naught. What we get to know, that my dn is cn e to the power j n omega naught t naught. There you go. So what did you understand from here? What is the conclusion? What is the conclusion? So here I need to keep all this down. So conclusion was that my xt is having a Fourier series coefficient of Cn, fundamental frequency of omega naught and time period of t naught. So x of t plus t naught, will have a Fourier series coefficient of Cn e to the power j n omega naught t naught, fundamental frequency of omega naught and fundamental time period of t naught only. What is omega naught here? Omega naught is always the fundamental frequency. A very important point. Omega naught is the fundamental frequency. Always what we understand, always we put omega naught only. But what should be in our mind? In our mind should be there that this omega naught is nothing but the fundamental frequency. Let's just say if x of t is having a Fourier series coefficient of Cn and fundamental frequency of omega naught, then what will be the Fourier series coefficient of x of t minus 3? So one thing you know, that fundamental frequency will be omega naught only. So here what I am going to put, Cn e to the power j n omega naught t naught, which is minus 3. So what is the answer? Answer is Cn e to the power minus j 3n omega naught, and fundamental frequency is omega naught only. So here what will come? The fundamental frequency of xt will come. That's it. Are you able to understand this point or not? Okay, a very good concept we are learning here. So let's go to the derivation again. Let's revise the derivation again. What we did, we need to find out the fundamental frequency of x of t plus t naught. So xt, this is how we write down. Yt, I am saying that this is my yt, which is having a fundamental frequency of omega naught only and time period of t naught only, but the Fourier series coefficient is dn. So this is how I can write down my yt as well. Now in place of t, if I put t plus t naught, what I will get? This particular expression I am getting, which is equals to yt only, because x of t plus t naught is equals to yt only. Now this expression is also of yt, and this expression is also of yt. So can I compare this with the dn? Yes. So dn I am getting cn e to the power j n omega naught. At least this you need to remember, e to the power j n omega naught, then whatever the factor is there, so t naught. Similarly, x of t minus 3, so cn e to the power j n omega naught, t naught is minus 3. There you go. Okay. What about x of t plus 2? Fundamental frequency this time is omega p. Fundamental frequency is not omega naught. Fundamental frequency is omega p. So what I will write down? Cn e to the power j n omega p into t naught, which is 2. And fundamental frequency will be omega p only. So what I will get? Cn e to the power j 2n omega p. Fundamental frequency is omega p only. So this is the answer. Are you able to understand the point? So here we will not remember omega naught. We will remember that this is just the fundamental frequency of xt. This is what we need to remember always. In this derivation as well, this was a very good derivation. So here what do we write down? Here we write down the fundamental frequency of yt, because we are defining the Fourier series coefficient of yt. So here what I am going to write down? Fundamental frequency of yt. And what is that fundamental frequency of yt? That is 2 omega naught. So that's why I have written 2 omega naught here. Are you able to understand the point? Then in place of t I replaced 2t. So this is what I got, and then I can compare x of 2t. What is x of 2t? X of 2t is yt only. So this is also expression of yt, and this is also expression of yt. So can I compare this Fourier series coefficient with this Fourier series coefficient? Yes. So from there what is coming? Cn is equals to dn. So signal which is a function of t can be written as Fourier series coefficient e to the power jn fundamental frequency into t. Right? Some very good question we are going to solve. Now try this question on your own. Okay. X of 4t is having Fourier series coefficient of Cn and fundamental frequency of omega naught. Then what will be the Fourier series coefficient of x of t plus 2? X of 4t is there. Okay. Use your brain. Use your brain here. I need to add some pages in between because, okay, it's fine, I guess. This will work. So x of 4t is having Cn omega naught. X of 4t is having Cn and omega naught fundamental frequency. Where I need to go? I need to go to x of t plus 2. So first I need to come to x of t, no? Then I can go to x of t plus 2. Are you able to understand this point? First I need to come to x of t. Then I can go to x of t plus 2. So first I will come to x of t. So basically, if x of t was having a x of t was having a Fourier series coefficient of Cn, then what was the Fourier series coefficient of x of alpha t? That was also Cn. Right? What is this? Let's just call x of 4t as yt. X of 4t as yt. Now, what will be your x of t? X of t will be y of t by 4. Say yes or no? Because in place of t, if you put t by 4, what you will get? Here you will get x of t only. Are you able to understand this point? Y of t is having a Fourier series coefficient of Cn. So what will be the Fourier series coefficient of y of t by 4? That will also be Cn only. No matter whatever the constant you multiply, whether it is 4 or 1 by 4, anything, it will be C of n only. But just let me know what will be the fundamental frequency. It will be omega naught by 4. Say yes or no? Because when you went from here to here, this was having Cn, this will also have Cn. But x of 40 have 4 times of it. X of 40 will have 4 times of this. 4 times of this. That is equals to omega naught only. Basically, previously it was x of 40. Now it is x of 40 by 4. This was having fundamental frequency of omega naught. So if this is divided by 4, so fundamental frequency will also be divided by 4. And time period will be multiplied with 4. Say yes or no? So this will also be divided by 4. So fundamental frequency has changed now. Fundamental frequency has become omega naught by 4. Next, what I need to find? X of t plus 2. So what I will write? X of t plus 2 will have Cn e to the power j n. Here what do we write down? Omega naught into t. What I should write down here? Omega naught or omega naught by 4? omega naught by 4, because x of t is having a fundamental frequency of omega naught by 4. So this was the important concept here. Say yes or no. Did you understand this point or not? A very, very important point. So what will be the final answer? Cn e to the power 2n omega naught. Oh, sorry. 2 by 2. Sorry. N omega naught by 2. N omega naught by 2. Are you able to understand this point? And what is the fundamental frequency of this particular x of t plus 2? That is also omega naught by 4 only. So from x of t to you are going to x of t plus 2. So what you will write down? Cn e to the power jn fundamental frequency of xt. What is that? Omega naught by 4 into this time, that is 2. This is the answer. And if x of t is having fundamental frequency of omega naught by 4, then x of t plus 2 will also have the fundamental frequency of omega naught by 4 only. A very important point, and a lot of people mess it up here. So scaling in time doesn't change the Fourier series coefficient, only the fundamental frequency gets changed. But now you are doing t plus 2, so this fundamental frequency you need to take in action, not omega naught. So never ever remember that c of n e to the power j n omega naught t. No, you need to remember c of n e to the power j n fundamental frequency into t naught. Say yes or no. A very important point. If I need to frame a good question, then this would be the point from where I will frame a good question in the examination hall. Next one is also very, very, very interesting. Okay. So how will I do it? So first we will understand the meaning, that how we need to proceed, and then we will develop a method. Method will be very easy. We will develop a method. From that method we will be able to solve all the problems. So let's start. So from x of t2 I need to go to x of minus 4t plus 3. So let's just assume I start from here. Okay, I am starting from here. So first x of t was there. X of t was having Fourier series coefficient of Cn and omega naught. Put your full concentration, otherwise you will not be able to understand. Next what I am doing, x of minus t. So what will be the Fourier series coefficient of x of minus t? That will be c of minus n, and fundamental frequency will not change. Right, this you already know, x of minus t. Just if you take the mirror image, then time period is not changing. If time period is not changing, that means fundamental frequency is also not changing. Next what I am doing, x of minus 4t. So c of minus n, this will not change. Are you able to understand the point? X of t, I am just multiplying t with 4. So this will not change, but fundamental frequency got 1 by 4 times. Because if x of minus t is having a fundamental frequency of omega naught, then x of minus 4t will have the fundamental frequency of 4 omega naught. Really sorry, it will have the fundamental frequency of 4 omega naught. Right? Time period will be 1 by 4 times, but frequency will be 4 times. All good. Now what you need to generate? Minus 4t plus 3. So what you will do? X of minus 4 t minus 3 by 4. Say yes or no. This is what I am going to do. Are you able to understand the point? X of minus 4 t minus 3 by 4. What that would be? X of minus 4t, then minus 4 plus 3. So x of minus 4t plus 3. Right? Now what do I know? That x of t, if x of t is having a fundamental time period of fundamental frequency of omega p and Fourier series coefficient of dn, then what will be the Fourier series coefficient of x of t minus 3 by 4? That would be dn e to the power jn. Here what you will write down? Omega p into minus 3 by 4. This will be the answer. Similarly, in place of t, what you replaced? T minus 3 by 4. What if I call it as yt? So what this would be? Y of t minus 3 by 4. Say yes or no. This would be, if this is your yt, then this would be y of t minus 3 by 4. Say yes or no. Similarly, I can just replace this x with y. So this was your yt, now this is your y of t minus 3 by 4. Y of t minus 3 by 4. So what you will do? C of minus n e to the power j n, fundamental frequency of x of minus 4t, or you can say fundamental frequency of yt. What is that? 4 omega naught into this t naught. What is that? Minus 3 by 4. And what will be the fundamental frequency? Whatever the fundamental frequency, this is having the same frequency it will have, because shifting will not change the fundamental frequency. So that will be 4 omega naught only. So what you are getting? C of minus n e to the power j, 4 and 4 get cancelled. minus 3 omega naught, and fundamental frequency is 4 omega naught only. So this is the answer. Wait a second. Yeah, n I missed here, no? Here I missed n, right? This n I missed. So 4 get cancelled, minus 3 j 3n omega naught. N I cannot miss, no? This n is there. So 4 got cancelled, minus 3 j n omega naught. Again I'm explaining, okay? Started with x of t, c n omega naught. X of minus t, c of minus n omega naught only. X of minus 4t, c of minus n only, but 4 omega naught. Now what I need to go? I need to go to x of minus 40 plus 3. I need to go to x of minus 40 plus 3. So what I will do? Minus 4, in place of t, I need to put t minus 3 by 4. Now, if I call the previous one as yt, so what this will be? Y of t minus 3 by 4. So yt is having a Fourier series coefficient of c of minus n. So what will be the Fourier series coefficient of what will be the Fourier series coefficient of y of t minus 3 by 4? That would be c of minus n as it is e to the power j n omega naught t naught. So t naught value is minus 3 by 4 and omega naught value is 4 omega naught. So what is the answer we are getting? C of minus n e to the power j n, 4 get cancelled, minus 3 n omega naught with the fundamental frequency of 4 omega naught. This is the actual concept. Now we will develop a process. So the next one will be process. This is just a process. It doesn't teach anything. So what I need to do? I need to go from x of t to x of minus 40 plus 3. So what we are going to do? We are going to follow the process, and now we will start from here. So what we are doing? We are just following the process now. This is the process. So I will start with x of t. Always start with x of t. Always journey will start from x of t only. Next, where I will go? X of t plus 3. So x of t was having cn. This will have e to the power j 3 omega naught, right? Basically, e to the power j n omega naught t naught. What is the value of t naught? T naught is 3. So what I can write down? E to the power j 3 n omega naught. E to the power j 3 n omega naught. Next, where I need to do? Where I need to go? X of 40 plus 3. So if I multiply anything here, that doesn't change the Fourier series coefficient. It remains as it is. It remains as it is. And then just I am doing a negative sign. So because of the negative sign, what will happen? N will be replaced with minus n. Right? Basically, because of the negative sign, what happens? N replaced with minus n. If x of t is having cn, then x of minus t is having c of minus n. Now in this particular example, you will not ask me any doubt. You cannot ask me any doubt because this is not representing anything. It doesn't represent anything. This is just a method. Actual concept was this, but this concept will be tough for some students. So that's why there is a method that how you draw the diagram. If I ask you to if I give you the diagram of x of t and I ask you to draw the diagram of x of minus 40 plus 3, how will you draw it? So I will start with x of t plus 3, then x of 40 plus 3, and then x of minus 40 plus 3. Same thing I am doing here. T plus 3. If you are adding something or you are subtracting something, then cn e to the power j n omega naught t naught. T naught value is 3. Then x of 40 plus 3. You are multiplying something with t. That means your time axis is multiplied with 4. What does that mean? Nothing will change. Fourier series coefficient doesn't change. From here to here, Fourier series coefficient doesn't change. What this was? This was shifting. This is known as scaling. And what is this? This is known as, what they call it? Mirror image. We take the mirror image. There is a name of this particular thing. What is that? I forgot the name. So shifting, scaling, should I write mirroring? Folding. Yeah, this is known as folding. Folding. We used to call it mirroring, so you can call it folding as well. In the books, folding word will be written. So in the books, this process will be given. X of t plus 3, x of 40 plus 3, x of minus 40 plus 3, and this is also taught everywhere. But this doesn't show a clear picture. The clear picture is shown by this, that how this came. C of minus n e to the power minus 3 n omega naught. C of minus n is e to the power minus 3 n omega naught. So you have developed a method here, that this is how I will be proceeding. So whenever I multiply anything here, that will not change anything. Are you able to understand the point? Well and good. Do we have more examples? Yes. So x of 2t is given. You need to find x of minus 3t plus 2. Okay, I will just copy it somewhere else. Yeah, so this is copied here. Now we need to solve this question. So in this question, we need to go to x of minus 3t plus 2, and x of 2t is given having Fourier series coefficient of Cn and fundamental frequency of omega naught. So there are two methods. One is the process and one is the core concept. So in the examination hall, mostly we will follow the process only, because here we don't need to use our brain. And this is what we like, right? We don't want to put much pressure on our brain. So in the examination hall, we will follow the process. So first we will follow with the process and then we will follow with the core concept. Okay. So method 1, process. Whenever we follow the process, we always start from x of t, right? This is the very important point. We always start from x of t. If you remember, in basics of signal, I gave you a question where I draw the diagram of x of 3t, and then I asked you to draw the diagram of x of minus 3t plus 4. Do you remember this thing? So there, how did we solve this question? From x of t to x of 3t, we went to x of t. Then we started here, x of t plus 4, then x of 3t plus 4, and then x of minus 3t plus 4. So always if I need to follow that particular process, that I will start from left hand side. If I need to follow this process, then first I need to get to x of t. Then only I can do anything. So first I will get to x of t. So how will I get to x of t? So x of 2t Fourier series coefficient is given. What will be the Fourier series coefficient of x of t? That will be c of n only. Fourier series coefficient will not change, but the fundamental frequency will be half. Because x of 2t is having omega naught, x of t will be half, right? Because time domain is divided by 2, so fundamental frequency is also divided by 2. So now from here I will start my journey to x of minus 3t by 2. So from x of t2 I will go to x of minus 3t by 2. Okay, a very important point will come here now. Okay, what that would be? From x of t, I will start from here. So from x of t2 I am going to x of t plus 2. So x of t was having a Fourier series coefficient of Cn. So here what I will write down, e to the power j n omega naught t naught. So t naught is 2. What I will write down here? Omega naught? No. I will write down omega naught by 2. Because what is the fundamental frequency of xt? That is omega naught by 2. So here what I will write down? Omega naught by 2. A very important point. A lot of people will just see this omega naught and they will write down omega naught here. A very important point, right? So e to the power j n fundamental frequency into t naught. So what we are getting? Cn e to the power j n omega naught. Next, where I need to go? X of 3t plus 2. So x of 3t plus 2, nothing will change. X of 3t plus 2, nothing will change. So Cn e to the power j n omega naught. Although here fundamental frequency got changed, but here I am not gonna do any changes. It's not that, sir, this fundamental frequency got changed, so that fundamental frequency I need to write down here. No, nothing changed. No change I will do here. No change. This is just a process. In the process, what did I tell you? That whatever the Fourier series coefficient is there, the same will be happening here, because t is multiplied with 3. Here t is multiplied with 3. So if your time domain is being multiplied with any number, the Fourier series coefficient doesn't change. So Cn e to the power j n omega naught. And next, what is the next task we are doing? We are just replacing t with minus t. So if you replace just here, if you add minus sign, so what will happen? Here also n will be replaced with minus n, because x of t was having c of n, x of minus t was having c of minus n. So this is just a process. What does the process says? That start with x of t. Start with x of t. Then proceed. X of t plus 2. That means you are shifting. So in the shifting, what will happen? E to the power j n omega naught. Sorry, in the e to the power j n omega naught t naught. So what is the value of omega naught here? Omega naught by 2 into t naught. So Cn e to the power j n omega naught. Now what is the next thing you are doing? You are multiplying your time domain with 3. That means nothing will happen. The Fourier series coefficient remains as it is, whatever the previous one was there. And then minus sign you are multiplying. So c of minus n e to the power minus j n omega naught. This was the process. This is the final answer. And what is the core concept? So let's get started with the core concept. So what does the core concept says? That x of 2t was having Cn omega naught. I need to go to x of minus 3t plus 2. So what seems like a easier path for me is that I get started to x of t. So I go to x of t. It will have Cn omega naught by 2. Next what I do? X of minus t. So x of minus t will have c of minus n omega naught by 2.
x of minus 3t I do. So x of minus 3t will have C of minus n only, but fundamental frequency will be 3 times, right? From minus t to minus 3t you are coming. So multiplying with 3. So this will also be multiplied with 3. So it will become 3 omega naught by 2. And next, minus 3t plus 2 you need to make. So x of minus 3t minus 2 by 3. Say yes or no? Right? T minus 2 by 3. Minus 3t plus 2. So 3 and 3 will get cancelled. Yeah, minus 3t plus 2. So what you will get? What you will get? C of minus n e to the power j n. T is replaced with t minus 2 by 3. But here what will come? Fundamental frequency will come. Into t naught. What is the value of t naught? Minus 2 by 3. C of minus n e to the power j n omega naught into t naught. Say yes or no? And fundamental frequency is 3 omega naught by 2 only. So what you are getting from here? C of minus n e to the power j n. 3 got cancelled, 2 got cancelled. So minus omega naught. This is the answer. These kind of questions you are not going to find anywhere in any notes. Okay? These you will find only on PrepFusion, neither in the textbook as well. And in the good examination, these kind of questions will come. They will give x of 2t. And a lot of students will mess it up. Here they will mess up. Because what is taught usually, this process is taught. This process will be taught in a lot of lectures. But in the process, the important part is what is this frequency? If you are going from x of t plus 2, then here you need to put the fundamental frequency. And fundamental frequency here is omega naught by 2. It is not omega naught. Actually, here you get the core concept. Here again, this is just a process only. Multiply with 3, nothing changes. Then multiply with minus sign, then n is replaced with minus n. So this is how you need to remember here. But this is the core concept. X of 2t, x of t, x of minus t, x of minus 3t, x of minus t minus 2 by 3. So if you follow in this manner, there is no chance that answer will be wrong in the examination hall. 100% it will be correct. So I would recommend in the examination hall, you do both of the things. Right? You can do both of the things in the examination hall. If these kind of questions are coming, you can do both of the things. You do this process as well, method 2. And you do this process as well, method 1 as well. Right? So have the patience in these kind of questions and solve it with good amount of patience and good amount of understanding as well. I hope this is clear to you. Right? Let's solve this question. Xt is having Fourier series coefficient of Cn and fundamental frequency of omega naught. F of t is having Fourier series coefficient of this thing. Okay? And fundamental frequency of 2 omega naught. You need to find ft is equals to alpha of x at plus b. You need to find the value of alpha a plus b. Alpha plus a plus b. This value you need to find. So x of t is having Cn. X of t is having Cn and omega naught. Now fundamental frequency is 2 omega naught. What does that mean? That certainly here 2 would have been multiplied. I don't know whatever b value is there. I don't care about this b value. But a value has to be 2. Then only fundamental frequency will be 2 omega naught. Say yes or no. So a value has to be 2. Along with that, you see c of minus n here. What do you see? C of minus n. What does that mean? That means certainly here negative sign would be there. Because only x of minus t can make c of minus n. So if there is minus n, so certainly here has to be minus sign. Are you able to understand this point or not? So till this point, what did you get to know? X of minus 2t plus b. Then this factor 1 by 3 is there. So this factor 1 by 3 is there. Basically, x of t, this we have already seen. X of t is having a Fourier series coefficient of Cn. Then what will be the Fourier series coefficient of alpha xt? That will be alpha Cn. Right? Just constant will be multiplied. Nothing else. And you can prove it as well. Very basic it is. You can write down x of t. That is summation n minus infinity to infinity e to the power j n omega naught. Now if you write down alpha xt, so alpha will be multiplied here as well. So this will become alpha Cn. So very simple proof is there. So if you multiply with the constant will be multiplied to the Fourier series coefficient as well. So this point we have reached. Right? From this is the point that we have reached. We need to find out the value of b now. So what will be the Fourier series coefficient of this particular thing? What do you think? Get started from here. Okay. 1 by 3 c of n e to the power, if I get started from here, e to the power j n omega naught, fundamental frequency is omega naught, into t naught, that is b. Then I will go to 2t plus b. 2t plus b will not change anything, and then I will go to the negative sign. So this n will be replaced with minus n, and this n will be replaced with minus n. Did you understand this point? Basically, I started with this x of t cn. 1 by 3 is a constant, let's drop it. Next I will go to x of t plus b. So e to the power j n, here omega naught I will write down, omega naught into b. Next I go to 2t plus b, nothing changes. So cn was there, cn e to the power j n omega naught b. Next I go to x of minus 2t plus b. So t is replaced with minus b, so n will be replaced with minus n. So I just followed the process and I reached here. C of minus n e to the power minus j n omega naught b, and 1 by 3 is outside, 1 by 3 is outside. Right? Now if I compare, and here what will be the fundamental frequency, that is 2 omega naught only. If I compare, then what did I get to know? N omega naught b, b value is 2 by 3. So from here what did I get to know is that b value is 2 by 3. So from here everything I understood. A is minus 2, b is 2 by 3, and alpha is 1 by 3. So what is the value of alpha plus a plus b? So that would be 1 by 3 minus a plus 2 by 3. So answer is minus 1. So this is the answer. Okay, good question. I would call it good question only. Well and good. Let's go to the next one. Let's go to this one. Here fundamental frequency is not getting changed. Neither you see the negative sign here, right? What I do is that I am changing the question. Okay, I am changing the question. I am putting the negative sign here. Now what will be the answer of alpha plus a plus b? So fundamental frequency, this is also having omega naught, this is also having omega naught. What does that mean? That this factor has to be t only. What I mean to say is that f of t will be alpha value, you can directly tell 3 by 2 x. This factor has to be t only, because there cannot be any factor. Why is that so? Because fundamental frequency is not changing. So if this is x of t, here also x of t has to be there, right? Next, can you see c of minus n? No, that means it has to be plus only. I cannot see c of minus n, I see c of plus n only. That means minus sign is not there, so this has to be x of t plus b. Say yes or no. And can you write down the Fourier series coefficient of this one? Yes. So 3 by 2 e to the power j n omega naught b. Right? What is the value of b now? If you compare from here, so value of b is minus 1 by 2. What is the value of b? That is minus 1 by 2. So value of b is coming out to be minus 1 by 2. What is the value of a? A is coming out to be 1. And what is the value of alpha? That is 3 by 2. Right? So these are the values. I hope you are able to understand the point. Alpha is 3 by 2, x, a is 1. A is 1. From here if I write down 3 by 2 e to the power j n omega naught b. That's it. Why a is 1? Because fundamental frequency is omega naught only here. So if fundamental frequency is omega naught only, so I will have to put a equals to 1. And I cannot see c of minus n here, that means a has to be positive, so it will be positive only. And from there b is coming out to be minus 1 by 2, so this is the answer we are getting. So what is the value of alpha plus a plus b? Alpha plus a plus b, that is 2, right? 5 by 2 minus 1 by 2 will be 2 only. So this is the answer. Can we frame another question from here? Yeah, we can. What I am gonna do is that I will just copy this page, or I will just copy this text, copy and paste it here. What I will do, I will change this as x of 2t. Okay, what I have done, x of 2t cn omega naught. Okay, then f of t is having this, also I am changing to 2 omega naught. Okay, then you need to solve this question, and another minus sign here, C of minus n. So let's start. So I need to go to something alpha of at plus b. So again, if I am following the process, I need to start with x of t only. So what will be the Fourier series coefficient of x of t? No matter any question I am solving, I will start with x of t, Cn omega naught by 2. Now this f of t is having 3 by 2, 3 by 2, c of minus n e to the power minus j n omega naught by 2 into 1. Can I write down in this manner? What do you think why I wrote down in this manner? Because what is my fundamental frequency now? It is omega naught by 2. Are you able to understand this point? So what should be my alpha value is 3 by 2 only. There is no doubt. X of fundamental frequency has got 4 times. Fundamental frequency has got 4 times here. So here what I will write down? 4t. And another minus sign I can see. That means it has to be negative. Plus b. Did you understand this point or not? 3 by 2, all fine. X of t was having fundamental frequency of omega naught by 2, but f of t is having fundamental frequency of 2 omega naught. That means fundamental frequency has got 4 times. And if it has got 4 times, that means here I need to put 4. And c of minus n also I can see, that means surely this will be minus 40 plus b. So now if I need to write down, so what I will write down, how I will start? I will start with c of n, then I will go to c of n2, I will go to, basically I need to reach to this particular point, x of minus 40 plus b. So I will start with x of t, then x of t plus b, then x of 40 plus b, then x of minus 40 plus b. So starting with cn, cn e to the power j n omega naught by 2 into b. Why is that so? Because this was having a fundamental frequency of omega naught by 2. So omega naught, and then this will not change anything. And what this will do? This will just take a negative sign. So from here, if I compare c of minus n e to the power minus j n omega naught by 2, so value of b is coming out to be 1, right? So value of b is coming out to be 1. And what is the value of alpha? Alpha value is 3 by 2. What is the value of a? A value is minus 4. I know these questions are not easy, but if these kind of questions are coming, then forget about the students. Even the educators will be getting it wrong. Really sorry to say this statement, but it is what it is. And I forgot to keep the microphones. Alpha plus a plus b. So alpha is 3 by 2 minus 4 plus 1. So what is the answer? Minus 3 by 2, right? 1.5, 2.5 minus 4 minus 1.5. Yeah. So this is the answer. So lastly, what is your f of t? F of t is coming out to be 3 by 2 x of minus 40 plus 1. And you can check as well, you can do the cross check that it would be same only, because c of n e to the power j n omega naught t 1 and then minus sign minus sign. Are we getting the same thing? C by 2? Yeah. And fundamental frequency is also 2 omega naught, because x of t was having fundamental frequency of omega naught by 2. So if you make x of 40, that will have 4 times, that means 2 omega naught. So this is the answer. Are you able to understand these questions? Are you able to appreciate this question? If this question is coming in the examination hall, will you have the patience and will you be able to get it correct? Like hardly 10 students will be able to answer in this kind of question in the examination hall. Hardly 10 students. Those who are studying, like at least I guess roughly around 150 students would be studying signal system from us, from this platform. So out of 150 students who have studied, out of those students as well, only 50% will be able to get these kind of questions correct in the examination hall. Those who have studied, okay, even they will struggle. So this happens in the examination hall, these kind of things happen. So you just need to have patience in these kind of questions in the examination hall, right? So all clear to you? Okay, then let's move to the next question now.
not next question, this is the next property. This is known as differentiation property. Okay, differentiation property. This is your differentiation property. So x of t is having a Fourier series coefficient of Cn. D by what I'm doing? I'm doing the differentiation of xt, that I'm calling as yt. So what will be the Fourier series coefficient of yt? That would be, let's just call it dn. Okay. So how do I define x of t? X of t is, if it is having a Fourier series coefficient of Cn, then I write down e to the power j n omega naught t. Now what I do? I do the differentiation on both of the side. Cn differentiation here, d by dt e to the power j n omega naught t. Why this d by dt came inside? D by dt should be here, no? Right? D by dt should be here because this is complete xt. This is complete xt. So d by dt should be outside, but that is coming inside. Why is that so? Because this is the limit of n. This is not the limit of t, and this is also Cn, which is a function of n only. Basically, only this is the function of t, no? So this will be differentiated. So what we are getting? Cn d by dt e to the power j n omega naught t. So here what will come? J n omega naught, right? E to the power j n omega naught t. That is equals to dxt by dt, which is equals to yt, right? Now yt is having a Fourier series coefficient of dn. So how yt will be defined? Yt will be defined as n goes from minus infinity to infinity dn e to the power j n omega naught t, right? So this is your dn, this is your dn, because this is also yt, this is also yt. So from dn what you are getting? J n omega naught Cn. So you have to remember this thing, that if you are differentiating, then what will happen? If you are differentiating, so d by dt will be replaced with j n omega naught. That's it. And again and again I will be using this property, so you will be able to remember. Okay, what I am saying, if you are differentiating, then you will add, then d by dt will be replaced with j n omega naught, and you will be able to remember, because in Fourier transform this d by dt will be replaced with j omega. In Laplace transform this d by dt will be replaced with s. So in Laplace transform you will get to know that s will be equals to sigma plus j omega, and if sigma is 0, so s will be j omega, and omega is replaced with n omega naught when coming to the Fourier series. Later on, when we are done studying all the transform, Fourier series, Fourier transform, Laplace transform, DTFT, DTFS, and jet transform, DFT, FFT. So all these, when we are done, I will relate all the transforms, Fourier series and all the transforms. So when we relate all these things, it should be clear to you. But this you will be able to remember. D by dt should be replaced with j n omega naught. Not tough to remember, right? Okay. Well and good. And what about the integration? What do you think? What will be the answer? What do you think? What will be the answer? In differentiation, if it was replaced with j n omega naught, so here in the integration it will be divided. Just the opposite process, right? So let's call it dn. Let's do the derivation. Let's call it dn. Okay. So how x of t is defined? N goes from minus infinity to infinity Cn e to the power j n omega naught t. What I need to do? I need to differentiate. So if I am doing the running differentiation with respect to t, then this will be replaced with x of 2. Now I am doing the running integration. So all these are function of n only. So where the running some integration will come? Here it will come. E to the power j n omega naught. Here I need to replace it with tau, because I am doing the integration with respect to t only. Right? So here what I am getting? N goes from minus infinity to infinity Cn. I am calling this as yt. So this will be my yt, and this is my yt. And what yt can be replaced with? Yt is minus infinity to infinity dn e to the power j n omega naught t. So with this we need to compare. So if I do the integration, what I am getting? E to the power j n omega naught 2 minus infinity to t
divided by j n omega naught. If I put the limit j n omega naught t e to the power minus infinity will be 0 only. So what we are getting? Summation n goes from minus infinity to infinity cn divided by j n omega naught e to the power j n omega naught t minus e to the power j minus infinity. So e to the power minus infinity is what? 0 only. So what we are getting? Summation n goes from minus infinity to infinity cn j n omega naught e to the power j n omega naught t. So what you can see, this is replaced with dn, right? So what dn you are getting? Cn divided by j n omega naught. There you go. This is your dn. All good? All fine? So here d by dt is replaced with j n omega naught, and here my d by dt, here integration is replaced with 1 by j n omega naught. Just the opposite process, right? Here it was multiplied with j n omega naught, here it is divided by j n omega naught. We will be using these properties somewhere, then you will be comfortable with these kind of properties. Okay? As of now, you just need to remember. But anyway, in the longer run, you will be able to remember it because we will be using it again and again. Right? Now, just a statement you need to prove that time shifting in xt does not change the magnitude of exponential Fourier series coefficient, it only changes the phase. What I mean to say is that x of t is having Fourier series coefficient of Cn. If I do the time shifting, what will be my Fourier series coefficient? Cn e to the power j n omega naught t naught, considering that this is having a fundamental frequency of omega naught. Okay, so this is my new Fourier series coefficient. If I take the mode of dn, what that would be? Mode of Cn e to the power j n omega naught t naught. So this is a complex exponential term, right? A e to the power j theta. What is the mode of that? Mode of a only. So mode of Cn e to the power j theta, what that would be? Mode of Cn only, right? But if I calculate the angle of dn, angle of dn will be angle of Cn e to the power j n omega naught t, omega naught t naught. So here what will come? Angle of Cn plus angle of this particular thing. What is that? N omega naught t naught. Basically, let's just say Cn was 2 e to the power j, Cn was 2 pi by 3. Basically, angle was pi by 3 and the magnitude was, or you have generally seen, angle was pi by 2. Let's just say angle was pi by 2. Cn was 2 angle pi by 2. That means Cn was 2j. So here the angle was pi by 2, right? And the magnitude was 2. So how I would write down? E to the power j pi by 2. Now what would be my dn? Dn would have been 2 e to the power j pi by 2. This is Cn e to the power j n omega naught t naught. So what is the total angle now we are getting? Pi by 2 plus n omega naught t naught. That is angle of Cn plus n omega naught t naught. So angle of Cn plus n omega naught t naught. So what I will write down here? Total angle will be angle of Cn. Total angle will be this, in this manner only I need to write down. Angle of Cn plus angle of n omega naught t naught. I hope you would have understood the concept here, right? If I am saying that Cn is having a magnitude of 2 and angle of pi by 2. So here dn will have angle of magnitude of 2 only, but angle of pi by 2 plus n omega naught t naught, pi by 2 plus n omega naught t naught. So this is proving our statement that time shifting in xt does not change the magnitude. Magnitude is same, but the angle is added with n omega naught t naught, which is very obvious here because this is coming in the complex exponential. That means it is just changing the angle, nothing else. So that's it about this video. In this video we have seen some good question or some good properties on Fourier series coefficient. So this was differentiation property, this was your integration property. More properties are there, certainly more properties are there, but we will see that properties, we will see those properties later on. Because if I just combine all the properties all together, then it will be very clumsy and you will be forgetting everything. So I know at which moment I need to teach which property and how to use that property so that you remember it in a longer run. Now what do you think? Are you ever gonna forget this property? Are you ever gonna forget this process?
Or are you ever gonna forget the core concept behind it? No, because we saw the property and then we solve the question. Now we have seen these property, integration and differentiation. With respect to these property, I am gonna solve the questions now. So now what will be the scene? You will be given a particular waveform. Okay, you will be given a particular waveform, and now with respect to this waveform, you need to find out Cn, An, and Bn. Till this point, what we were doing? Sinusoid, cosinusoids were there. Sin omega naught t, sin 15 omega naught t, sin 20 omega naught t, sin 300 omega naught t, cos omega naught t. So sinusoid, cosinusoids were there in xt. This was the expression is equals to some sinusoid and cosinusoid, and from there we were finding a and bn. But now we will apply those formula. Which formula? Cn is equals to x of t e to the power j n omega naught t naught. This minus sign also. So this formula we are going to apply now, and here divided by t naught as well. Basically, I am not writing the complete formula. I am just telling you that these formula we are going to apply now. Cn, An, and Bn formula we are going to apply. So next two lecture will be based on these kind of questions, which will require mathematics. Okay, and there we will use this property, integration property. We will use time shifting property. We will use, and once we are done with that, we will move to other properties, which are very less important. So those less important properties also we are going to see. So I hope the flow is clear, because this chapter becomes very difficult for a lot of students, because they think that there are a lot of things to remember, but we are minimizing the things to remember, right? We are building up the process, we are building up the concept as well. Everything is we are doing in a very good manner. So let's meet in the next lecture. There we will see some xt waveform, and with respect to that we will make an, bn, and cn. Okay, thank you very much. Hi everyone, welcome back. So in this video, what we are going to see, we are going to find out Cn value. Okay, we need to find out exponential Fourier series coefficient. Till now, what kind of expression we used to see? There is a constant plus a cos 2 omega naught t, let's just say, plus b sin 5 omega naught t. These kind of expression we were seeing, right? Apparently we could see sinusoid, apparently we could see cosinusoid, and apparently we could see DC value. More sinusoid, cosinusoid could also be there. So apparently in these expression we could see sinusoid and cosinusoid. Now this is a periodic waveform. This time waveform is given. Now in this waveform, can you apparently see sinusoid and cosinusoid? No. Although this is a periodic waveform, so certainly it is made from sinusoid and cosinusoid. But apparently we cannot see sinusoid and cosinusoid. They are inside it. So we need to pass it through the Fourier series. Once we pass it through the Fourier series, then we will get sinusoid and cosinusoid, or you can say complex exponential. So apparently we cannot see complex exponential here. So now we need to apply the formula. Which formula we need to apply? This formula we need to apply. 1 by t naught integrating for a time period x of t e to the power minus j omega t dt. Do you remember this formula? Similarly, there was a formula for an as well. Similarly, there was a formula for bn as well. Yeah, so these formula we need to apply, but in this lecture we are just talking about Cn. Okay, we will talk about An and Bn as well, but in the next lecture. In this lecture we will talk about only Cn, and if you know the value of Cn, can you find out An? Yes, that would be Cn of Cn plus C of minus n, and what would be Bn? J Cn C of minus n, right? So now what is our target? The wave, this time the xt expression is not given. We are given a waveform. So using that particular waveform, we need to find out our Cn value. What we need to find out? We need to find out exponential Fourier series coefficient. So for that we need to apply the formula, and the formula says C of n 1 by t naught. You need to integrate for a time period x of t e to the power minus j omega naught t dt. How did I ask you to remember? T and t. If both t are together, then minus sign would be coming. When we are used to write down the expression of x of t, then summation n goes from minus infinity to infinity, Cn e to the power j n omega naught t. So this t is here, this t is here, so no minus sign. But two t's are coming together, then there is a minus sign. In this manner you can remember it. That's it, nothing else. So this is the formula we need to apply. But one thing I want to tell here is that this lecture will be a bit mathematical. Okay, here we need to use mathematics. And you will feel like that, sir, how we will do these kind of mathematics in the examination hall. So in the examination hall, you will not be using this method which I am teaching here. The method that I am teaching in this lecture, that method you are not going to use in the examination hall. In the examination hall, you will use a very easier method. Within 2 steps, you will be able to write down the answer. You will just see the waveform and you will be able to write down the Cn expression. But that method you will learn after studying Fourier transform and Laplace transform. As of now, you need to do the mathematics, and that mathematics is also necessary because that can help you in the examination hall. Okay, so it's not that you should ignore this lecture. This lecture is very important. This mathematics will also be used in some places, in some questions that kind of mathematics will be used. So don't ignore this lecture. Just if you feel like that, sir, there is too much mathematics, how will I do the mathematics? So you are following me for a very longer time, you know that I don't focus on mathematics a lot. We will develop a method after studying Fourier transform and Laplace transform, that if these kind of waveforms are given, then how will we write down our exponential Fourier series coefficient in a very short time. But that will happen after studying Laplace transform and Fourier transform, because I will relate Fourier series with Laplace transform, then I will relate Laplace transform with, I will relate Fourier series with Fourier transform, then I will relate Fourier transform with Laplace transform, and then Laplace transform will be related with Fourier series again. So when all three are interrelated, then we will develop a method, and with that particular method you will be able to write down exponential Fourier series in a very easier method and in a very short time as well. Okay, so this lecture would be mathematical, but you need to have some patience. So we will come to this question, but before that let's see a simple concept. If x of t is having a Fourier series coefficient of Cn, then what will be the Fourier series coefficient of x of t plus 4? This you need to tell. Okay, x of t plus 4. All these things we have already seen. If x of t is having a Fourier series coefficient of Cn, then what will be the Fourier series coefficient of x of minus t? That would be c of minus n. What would be the Fourier series coefficient of x conjugate t? That would be c of minus n conjugate. What would be the Fourier series coefficient of x of alpha t? That would be c of n only. What would be the Fourier series coefficient of x of t plus t naught? That would be cn e to the power j n omega naught t naught, right? And what would be the Fourier series coefficient of alpha x of t? That would be alpha cn. All these things we have already seen. Now if I add a DC value, then what will happen? So can I write down my xt in this manner? Xt is DC plus c1 e to the power j omega naught t plus c of minus 1 e to the power minus j omega naught t plus c of 2 e to the power 2 j omega naught t plus c of minus 2 e to the power minus 2 j omega naught t, and in that manner it will keep on going. Now I am calling this as yt. So what is my yt? Yt is xt plus 4. And what is xt? Xt is this much value, right? Xt is this much value. All these things plus 4, plus 4. So what is this? This is the constant value. And what is the constant here? This is the constant. So this plus 4 will be added in the constant only. C naught plus 4. So what do you see here? Only DC value got changed. In yt only DC value changed. DC value changed. Rest C1, C of minus 1, C2, C of minus 2, C3, C of minus 3 all remains same. What I mean to say is that in x of t plus 4, C1, C of minus 1, C2, C of minus 2, C3, C of minus 3 all remains remain the same. Are you able to understand this point? What do I mean to say is that if your x of t is having a Fourier series coefficient of Cn, then x of t plus 4 will also have the Fourier series coefficient of Cn only, but considering n is not equals to 0, right? And for n equals to 0, what will happen? For n equals to 0, what will happen? Only the DC value will change. Only that DC value will change. Same goes for a and bn as well. If I write down this as c naught plus a1 cos omega naught t plus a2 cos 2 omega naught t plus a3 cos 3 omega naught t plus b1 sin omega naught t plus b2 sin 2 omega naught t plus b3 sin 3 omega naught t plus. And then I add a DC part. So basically if I am shifting up the waveform, then what is happening? all the sinusoid, cosinusoid, all the exponential are also being shifted up. That's it. Nothing else got happened. A periodic waveform was made from sinusoid, cosinusoid or complex exponentials. If I shifted my periodic signal, adding a DC means I shifted my periodic signal upward. So my sinusoid, cosinusoid or complex exponential also got upward. So nothing else got changed. So in any question, if I need to analyze a particular waveform plus DC, then what I will do? I will ignore the DC part and I will analyze this waveform only. And in the end, when I need to write down C naught, then what I will do? I will just calculate the DC value. We will see these examples, you will feel very good after that, okay? What I mean to say is that whenever I feel like that some DC component is coming, so I will ignore that DC component, I will analyze the rest of the waveform and then I will add up the DC part in the end. So is that conclusion clear to you? Let's move on to our questions now, okay? So till now what we have seen is that this lecture will be mathematical, easier way we will learn, and here one conclusion we have made that if I add a DC, then my exponential Fourier series coefficient is not getting changed, right? Only DC value is getting changed. So whenever I see a particular waveform with the DC value, then I will ignore the DC value and later on I can take care of that particular DC value. Is that okay for you or not? And all these conclusions also we have seen, which are very, very, very important. Say yes or no. Well and good. Let's move on to our questions. Have the patience and solve it. So what is the periodicity here? T naught only. Periodicity is T naught only, right? What is your time period? Time period is T naught. So what will be the value of omega naught? Omega naught will be, 2 pi by T naught. 2 pi by T naught, right? Now I need to integrate it for a time period. So can I go from 0 to T naught? If I go from 0 to T naught, what will be the issue? Look, if I go from 0 to T naught, then I can say that at 0 as well there is an impulse. At T naught as well there is an impulse. So I want to ignore the boundary. This 0 is a boundary, no? This T naught is also a boundary. So I want to ignore the boundary. What I need to take? I need to take a window of T naught. I need to take a window of T naught. That's why I always write T naught here. In this manner I write down. I never ever write down 0 to T naught. I never ever write down like this. I always write down the window of T naught. That means can I take from minus T naught by 2 to plus T naught by 2? Why I am taking in this manner? Because the impulse is coming in between. So there is no issue. But if I take from 0 to T naught, then impulses are coming at the boundary, which is creating an issue. Right? So that's why I am taking from minus T naught by 2 T naught by. Let's just say I take from 0 to T naught, then someone would be saying that, sir, why we are including this impulse? Someone will be saying that, sir, why we are including the impulse at boundary? So I will always ignore the boundary. That's why I am taking from minus T naught by 2 to plus T naught by 2. Okay. So minus T naught by 2 to plus T naught by 2 will be equals to 1 by T naught minus T naught by 2 to plus T naught by 2. In between what is there? A into delta T, right? A into delta T. Between minus T naught by 2 to T naught by 2, what kind of impulse is there? A into delta T, right? E to the power minus j n omega naught T dt. A is constant that can come outside. Delta T into e to the power minus j n omega naught T. So what is the property of delta T? This 0 goes here, right? So that will be equals to delta T e to the power minus j n omega naught. In place of T minus 0, in place of T what you will put? 0 here. So e to the power 0 is 1. So that would be equals to delta T. So this particular portion will be equals to delta T. So what we are getting? Cn is equals to A is coming outside, A by T naught minus T naught by 2 to plus T naught by 2 delta T. Basically this particular portion, delta T e to the power minus j omega naught T is replaced with delta T dot dt. Delta T is defined at 0. Basically if you take the integration of delta T in this range, then what it will throw? 1. What will be the value of this integration? What will be the value of this integration? That would be equals to, this value will be equals to 1. So what you are getting? Cn is equals to A by T naught. So this is our Fourier series coefficient. Fourier series coefficient. It is not depending on n. Basically for everywhere the Fourier series coefficient will be A by T naught. everywhere the Fourier series C of n is always a by t naught. Here also a by t naught, here also a by t naught, here also a by t naught. Always it will be a by t naught, a by t naught, a by t naught, a by t naught. So your Fourier series coefficient is a by t naught. Say yes or no. Okay, always it is a by t naught. And this we should remember. This waveform should be there in our mind. This waveform should be there in our mind, and this should also be there in our mind. C of n should also be there in our mind. Can I write down this waveform as x of t as delta of t minus n t naught, where n goes from minus infinity to infinity? Say yes or no. Delta of t minus n t naught, where n is going from minus infinity to infinity. Put t equals to 0, what you will get? Delta t. Put n equals to 0, you will get delta t. Put n equals to 1, what you are getting? T minus t naught. Put n equals to 2, what you are getting? 2t naught. Put n equals to minus 1, what you are getting? Put n equals to minus 2, what you are getting? That means impulse is there at t equals to 0, impulse is there at t equals to t naught, impulse is there at t equals to 2t naught. In that manner, minus t naught, minus 2t naught, 0, t naught, 2t naught, 3t naught, minus t naught, 2t naught, sorry, minus 2t naught. So can I write down my xt in this manner? Yes, in this manner I can write down my xt. So this is how I have written down my xt. From here what you will understand, that my exponential Fourier series coefficient is 1 by t naught. A very, very important conclusion. Here if I multiply by a, so it will be a by t naught. Otherwise you remember it will be 1 by t naught. Okay, if it is multiplied with the factor of a, then it would be a by t naught. So this should be remembered. Okay, this particular waveform will have this particular Fourier series coefficient, a by t naught, everywhere. At omega naught, at 2 omega naught, at 3 omega naught, at 4 omega naught, at 5 omega naught, always it will throw a by t naught. So basically your x of t can be written as a by t naught summation n goes from minus infinity to infinity. Basically we used to write down Cn here, but Cn is a by t naught, which is not depending on n, so it is coming outside, right? I hope you are able to understand this point. Basically we used to write down Cn e to the power j n omega naught t. This is what we used to write down. But Cn is a by t naught, which has come outside. Why it has come outside? Because it is not a function of n. So that has come outside, and here I am just writing e to the power j n omega naught t, right? So this is how you can write down your xt. A very, very important conclusion which I will be using in sampling theorem. Okay, when we study sampling theorem, I will be using this particular waveform again, and there I will be saying that your exponential Fourier series coefficient was a by t naught. You should remember it. With the help of this particular thing, we are going to learn a lot of new things. Okay, and this year there was a question on this particular topic only. So we will learn that. Yeah, let's move ahead. For this question, you need to find out Cn. Again, you know one thing. What is Cn? 1 by t naught. For one time window, I need to do it. X of t e to the power minus j n omega naught t dt. So target is t naught and omega naught. So what is the value of t naught here? What do you see? This particular waveform is being repeated, right? So here directly I can see that t naught value is 3 minus 1 minus 3 minus of minus 1, t naught value is 4. T naught value is 4, omega naught value is 2 pi by 4 divided by pi by 2, right? So C of n 1 by 4. Window I need to take, so what I can do, I will take from minus 2 to 2. This is also one window, no? Basically I am taking from minus t naught by 2 to plus t naught by 2. Mostly we will take minus t naught by 2 to plus t naught by 2. Why I am not taking minus 1 to 3? Again there is a boundary, right? Again at minus 1 there is a boundary, at 3 also there is a boundary. So I will ignore the boundary. 1 before, 1 before. So that means minus 2 to 2. I am taking minus 2 to 2, right? X of t e to the power minus j n omega naught t dt. But it is non-zero between minus 1 to 1 only, because from minus 2 to minus 1 it is 0, 1 to 2 it is 0. So this limit will change from minus 1 to 1. So Cn is equals to 1 by 4. This limit will change from minus 1 to 1. Between minus 1 to 1 it is a e e to the power minus j n omega naught t dt. All these calculation you should be doing with me. Okay, just don't look at the screen. Use your pen. If you are not using your pen, then you will be sleeping, you will be not understanding anything. You need to use your pen. Minus j n omega naught, because there is nothing, this is just a simple calculation, nothing else. You are not learning anything new here. This calculation you need to do, and if you just look at the screen and you feel like that, okay, I will be able to do the calculation in the examination hall, then you will not be able to do it. So you have to do the calculation with me. So I just integrated e to the power minus j n omega naught t, in the denominator minus j n omega naught will come. Then this j can go upward, so ja by 4 e to the power minus j n omega naught minus e to the power plus j n omega naught divided by n omega naught, right? What I can do now, minus j by 4 n omega naught minus j by 4 n omega naught, minus sign I am taking common, e to the power j n omega naught minus e to the power minus j n omega naught divided by 2j and multiplied by 2j. Why I did so? Because I need to make sinusoid from here, right? So what I am getting, j minus 1, so here I am getting, and this is 2, so what I am getting here is that a 2 n omega naught. Say yes or no? This 2 and 2 n omega naught minus j into j will be plus 1, so a 2 n omega naught into sine n omega naught. Say yes or no? So what I am getting, this 2 I am keeping here, and then n omega naught here. So what I am getting, a by 2 sampling of n omega naught. Are you getting this point? So my c of n is coming out to be, this is my c of n, so my c of n is coming out to be a by 2 sampling of n omega naught. This is my c of n. So this was a square wave, this is known as square wave. The exponential Fourier series coefficient of a square wave is a by 2 sampling of n omega naught, which is a sampling function. This kind of function it would be. Although we will make the waveform, but I am just telling you this kind of waveform we are getting. So this was the method 1 of calculating exponential Fourier series coefficient. This was the method 1. Okay, let's develop the method 2. Let's develop the method 2. For that, what I am gonna do, I am gonna copy this waveform. So now we will see the method 2, and then we will make the waveform as well. Which waveform? We will make the waveform of c of n. Here we made the waveform of c of n, no? This waveform of c of n. So similarly for this graph, for this particular signal as well, we will make the waveform of c of n. But let's develop a second method. The second method will be using the differentiation. Why I am using the differentiation? Can anyone think of it? Why I am using differentiation? Because I know that if I differentiate this particular function, what I will get? Impulses. Differentiation is always done from minus infinity, right? So differentiation, let's do the differentiation. So here this will not be used. As of now I am calling it yt, okay? I am calling it yt. Okay, let's call it yt. Why I am calling it yt, you will understand. I am calling it yt. Why I am calling it yt? Because previous waveform I have called xt. Previous waveform is xt. So this waveform I am calling as yt. So this is my yt. So what I am doing? I am doing the differentiation. Because when I differentiate, what I will get? Impulses. And for impulses, I remember a particular formula. So just see it, okay? Just see the method, the way I am proceeding here. So differentiation is always done from minus infinity. So this is a constant value. At minus 3, what you will get? At minus 3, what you will get? A downward impulse. From a to 0 you are going. That means you are dropping down by minus a. So impulse you will get which has an area of minus a. Then 0, 0, 0. At minus 1 you are increasing the value from 0 to a. So there is a jump. That means you are increasing the value from 0 to a. So at minus 1 you will be getting an impulse of the area of plus a, impulse of the area of plus a. Then at 1 you are dropping down with the impulse of area of minus a. Then at 3 you are again going up. Then at 5 you are again dropping down. At 5 you are again dropping down. In that manner you are proceeding, right? This is the way you are proceeding. Here what did we show? Only positive impulses. In this one, what did we show? Only positive impulses. Here what is the time period? Time period is 4. Here what is the time period? Positive impulse. Again the positive impulse is coming at 3 only. Again time period is 4 only. Here two kind of waveform we are seeing, right? Can I break down this particular dyt by dt? What I am doing? I am breaking down this particular dyt by dt. How will I break it down? I am breaking it down into two functions. I am breaking it down into two functions. What is that? At -1, 3, and then at 7, -1, 3, and at 7 again I will have a positive impulse. So where you will have the positive impulse? At -1, at +3, at +7, and previously at, this is -1, so at -5 you would be having a positive impulse, right? Because this would have been the waveform. This would have been the waveform. So here again there is a jump. So this would be -5. You are understanding all these things only if you have studied basics of signal in a good manner. There I told you about differentiation, integration, everything. So that was the most important chapter. So -5, -1, +3, +7. So these impulses are there, right? So these impulses are there. -5, -1, +3, +7. And another impulses will be not -3. Sorry. -1, -5. This was -5. Okay. Yeah. So negative impulses are there at -3, +1, +5 in that manner. After 4, 4, 4, 4. After the gap of 4. So -3, +1, +5 in that manner. So here it is -3, +1, +5. This has an area of -a, -a, and -a. Can you write down this waveform as, okay, what I am saying, this is your xt, this is your xt, this is your xt, okay. Can you write down this waveform as x of t, where it is shifted backward, x of t plus 1 with the time period of t naught equals to 4. Here the t naught was 4, okay, let's just say t naught was 4, and then you shift it by 1. If you need to draw the waveform of x of t plus 1, what you will do? You will just shift it by 1 towards the left hand side. So what will happen? This 0 will come to -1, this 4 will come to 3, this 8 will come to 7. Say yes or no? So what is happening here? -1, 3, 7. Are you able to understand this point? Are you able to visualize it? And here what is the scene? All these are having impulses of A, right? So let's remove this t naught here. And what you will write down this will be your -a x of t minus 1. You are shifting the impulses ahead, and also you are taking the amplitude to be negative. Already we are taking amplitude to be plus a there, so only minus sign would work. Because in this particular question, in this particular waveform, we are already taking the amplitude to be a, so only the minus sign would work. Only the minus sign would work. Is that clear to you or not? One is shifted backward, one is shifted ahead. So here I am writing minus x of t of -1. -1 means shifted ahead, shifted towards the right hand side. And then I need to multiply with the -1 sign as well. Is that clear to you or not? And when I add both of them, what I am getting? When I add both of them, I am getting dyt by dt. In the examination, you will not have to make this waveform. In this lecture only, we will do so much of practice that in the examination, without making these waveform, you will be able to write down the answer. You will just see, okay, impulses, impulses. Although in the examination, you are not going to follow this method. You will just find out the Fourier transform of this particular waveform, and then you will replace omega with n omega naught, and then divide by t naught. That method you are going to follow in the examination hall. But that method we will develop after studying Fourier transform and Laplace transform. So as of now, we are learning the differentiation property. Here we are using the differentiation property, shifting property, everything we are using. So what we got to know, that our dyt by dt is equals to x of t plus 1, x of t plus 1 minus x of t minus 1. Right? Basically, you need to add both of them. If you add both of them, which kind of waveform you will be getting? This waveform again you will be getting. So one is shifted ahead, one is shifted backward, and the one which is shifted ahead, that is multiplied with the negative sign as well. Say yes or no. So what is this? This is your impulse train shifted t plus 1. What is the meaning of t plus 1? T plus 1 means shifted left with amplitude a naught and time period equals to 4. This is also impulse train shifted right with amplitude a naught and time period equals to 4. So what will be d by dt replaced with? J n omega naught. What will be the Fourier series coefficient of yt? That I am calling as Cn. This Cn we need to find out, right? What I have done, I have write down dyt by dt in terms of x of t plus 1 minus x of t minus 1. Then my d by dt, if yt is having a Fourier series coefficient of Cn, if yt is having a Fourier series coefficient of Cn, then what will be the Fourier series coefficient of dyt by dt? That would be j n omega naught Cn. So now what I am writing? I am writing the Fourier series coefficients. Fourier series coefficient. Now what will be the Fourier series coefficient of this particular thing? So Fourier series coefficient of simple impulse train was a by t naught. Amplitude was a naught, a naught. So a by t naught. What is the value of t naught? That is 4. E to the power j n omega naught into 1. Why I am doing so? Because x of t was having a c of n as a by t naught. So x of t plus t naught will have it as a by t naught e to the power j n omega naught t naught. So what is the value of t naught? That is 1. So that I have written. Minus a by 4. Again x of t will be having a by 4 only. T naught value is 4. What is the t naught value for this one? That is 4. What is the t naught value for this one? That is also 4. And what is the t naught value for this one? That is also 4. A very, very important point, the most important point and the most ignored point by a lot of students and by a lot of educators as well, that whenever I am applying all these things, always note that these should be equal. The time period should be equal. All of them should be equal. T naught equals to 4, T naught equals to 4, T naught equals to 4. Look, this lecture will be extensive, but I will tell you a lot of point where a lot of students do the mistake. So have the patience and just follow it. E to the power minus j n omega naught t naught. T naught value is 1. So what we are getting? A by 4 into j n omega naught. Here we are getting Cn e to the power j n omega naught minus e to the power minus j n omega naught divided by 2j multiplied with 2j. Right? So what we are getting? A by j and j is getting cancelled. 2n omega naught sine n omega naught. So from here we are getting a by 2 sampling of n omega naught. Are we getting the same thing? A by 2 sampling of n omega naught. A by 2 sampling of n omega naught. You are saying, sir, this method was much easier. Why you are wasting time like this? This method will help you a lot in a lot of problems. Okay. So that's why I have wasted the time here. That's why I explained this step by step. Every single thing I have explained step by step. So a by 2 sampling of n omega naught, right? So this is our Cn. So let's analyze Cn now. Let's analyze the Cn. So Cn is a by 2 sampling of n omega naught. So what is the value of omega naught? Omega naught is 2 pi by 4, that means pi by 2. Omega naught is pi by 2, right? So I can write down this as sampling of n pi by 2, or this can be written as a by 2 into sine n pi by 2 divided by n pi by 2, because sampling of theta is equals to sine theta divided by theta, right? Now you find out what is the value of C of 0. C of 0. So a by 2 sine 0 divided by 0. So do you remember what is the value? 1, right? Limit x tends to 0 sin x by x. What do we find out? It was equals to 1, right? Because 0 by 0 L'Hopital rule we apply. Then cos 0 is 1. That's it. So this particular thing will go to 1, right? So what will be the value of C of 0? C of 0 will be a by 2. What will be the value of C of 1? C of 1 will be a by 2. Sin pi by 2 is 1 only, divided by pi by 2. So what we are getting? 2 and 2 get cancelled, a by pi. C of 1 is a by pi. What about C of minus 1? So sampling function is always even. So that would also be a by pi. What will be the value of C of 2? C of 2 you put sin 0 is at this place you put n equals to 2. So sin pi is 0. C of 2 is 0. What is C of 3? C of 3 will be a by 2 into sin 3 pi by 2. Sin 3 pi by 2. What is sin 3 pi by 2? That is minus 1. Sin 3 pi by 2 is minus 1 divided by 3 pi by 2. So what we are getting? Minus a by 3 pi. Same goes for C of minus 3 as well. That will also be minus a by 3 pi. Now if we find the nulls, if you remember the null, can we find out the nulls? Basically, at what value of n when Cn will be 0? Basically what I need to find when Cn will be 0. So then I will put this equals to 0. So what you will get? Sin n pi by 2 is equals to 0. That means n pi by 2 should be equals to m pi. Basically when sinusoid is 0, when your sinusoid is 0, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0, sin 4 pi is 0. So sin m pi. So sin n pi by 2 is equals to sin m pi. Sin m pi. So from here what you are getting? N pi by 2 is equals to m pi. This and pi is getting cancelled. So n is coming out to be 2m. What does that mean? Value of m could be plus minus anything. So basically at n equals to 2, basically C of 2, C of 4, C of 6, you put m equals to 1, C of 2, put n equals to 2, C of 4, put m equals to 3, C of 6. All these will be 0. Along with that, C of minus 2, C of minus 4, C of minus 6, all these will also be equals to 0. So all these will be 0, right? So at n equals to 2, 4, 6, minus 2, 4, minus 4, minus 6, those values will be 0. That means Fourier series coefficient will be 0 for all these things, right? So can I draw the graph? Here, what was the value of C of 0? That was a by 2. What was the value of C3? That was minus a by 3 pi. Minus a by 3 pi. This was also minus a by 3 pi. Very simple mathematics, nothing else. It will be discrete, right? C of n is discrete. Basically, it is defined at omega naught, 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught, 6 omega naught. So all these will be discrete. So here the value was a by pi. Here the value was 0. Here the value was minus a by 3 pi. Here the value will be more lesser than more lesser in the same manner. Right? Here the value was 0, lesser, and in that manner we will get the values. So this is the C of n graph we are getting. This value is a by pi. This value is minus a by 3 pi. What this would be? A by 5 pi. You can check here. If I put sine 5 pi by 2, what that would be? Sine 5 by 2 will be 1. So a by 2 into 1 5 pi by 2. So this and this get cancelled. A by 5 pi. So a by 5 pi. A by 5 pi. Basically we are getting a by n pi when n is equals to odd, and 0 when n is equals to even, and when n is equals to 0, at that time we are getting the value to be this. I did not even show. This value is a by 2. This value is a by 2. When n is equals to 0, the value is a by 2. But here at 3 we are getting the negative value, so I should not write n pi here, or whatever it is. Let's ignore the expression. Okay, you can denote the expression in any manner, just keep it like this only. Okay, this is the expression that we are getting. C of n is equals to n a by 2 sampling of n by 2. Again I will be using it somewhere when we start studying about our Fourier transform. When we start studying our Fourier transform, we will start from here. So what I will do, there I will make this waveform. What I will do, I will make this waveform, and then I will make C of n. So I am not asking you to remember the complete diagram, or I am not asking you to remember the complete expression, but it should be there in your mind that if there was a square wave, then C of n was discrete function, but it was kind of sampling. It was kind of sampling function. Okay, whenever we took the square wave, the C of n came as sampling function. Okay, C of n came as sampling function. Again we will see the example, again we can derive it, no need to worry about that. But it is important to understand the meaning of Fourier transform. So as of now, what we have seen two examples. Started with the impulse. I told you a by t naught, you need to remember. A is the amplitude, t naught is the time period, right? And it is the impulse is made at 0. Now it can be used that in some of the problem, when we apply differentiation property, we can get shifted impulse. What we can get? We can get shifted impulse. So here first we solved by the conventional approach, just simple. I am doing the integration, nothing else. So I got the answer very easily, very smartly. I got the answer. Then I applied method 2, differentiation. So I am getting the impulses. Why I did the differentiation? Because I know that if I differentiate, I am getting the impulses, and for impulse I already know the expression. So one is shifted backward, one is shifted ahead. The one which is shifted ahead, that is having a magnitude of minus a. So in that manner I can write down directly in the examination hall. I will write down this step directly. I will not do all this process, because in the mind only I will see, okay, impulse, negative impulse, shifted backward. So directly I can write down this step. We will develop that kind of practice. We will see more example here. So we will develop that kind of practice. Let's try for this one. So conventional approach you can do. What you will do? What is the conventional approach? This is also I am calling y of t. So what I need to find? C of n I need to find. So 1 by t naught. What is t naught here? You can directly see t naught is 2. So 1 by t naught. Then I need to integrate. Let's integrate from minus 1 to 1. You can integrate from 0 to 2 as well. Basically you can integrate from 0 to 2 as well. But why I am integrating from minus 1 to 1? Because in this integration you get this waveform. Here if I integrate from 0 to 2, what will happen? Here and here different waveforms are there. So that I want to ignore. If I integrate from minus 1 to 1, I am getting only one waveform. So that's why I am integrating from minus 1 to 1. Okay, x of t e to the power minus j n omega naught t dt. What is the value of omega naught? 2 pi by t naught, that is pi. Well and good. What is x of t? X of t is equals to t in the range from minus 1 to 1. Why is that so? Why it is equals to t? You can see what is the slope. Slope is 1 minus 1, 2 divided by 1 minus minus 1, 2. Slope is 1. So calculating slope, all these things we have seen in the basics. So slope is 1. So slope is 1, and where it is cutting on y-axis? Cutting at 0 only. So y equals to mx plus c. C value is 0, m value is 1. So y equals to t. This waveform is y equals to t, which is very simple. So what you are going to do, you will put t here and then you will solve. You will put t here put t here, and then you will solve. What you will have to do? You will have to apply that Eilert formula, that keeping first as it is, then integration of the second, minus differentiation of the first, then integration of the second, then integration of whole, and in that manner you need to solve. Tougher calculation, right? Very tough calculation. So basically I am writing solve. If you want to solve, you can solve. But in the examination, we are never going to use this method. Never ever we are going to perform these kind of integration. In any question, we are never going to apply any Eilert formula. What do you think? What should I do? Differentiate. Because what this will throw? Slope of 1, constant value of 1. Differentiation, constant value of 1. Differentiation, constant value of 1. Differentiation, constant value of 1. What this will throw? You will start the integration, you will start the differentiation from here. That means going down, going down, going down, going down. Starting the differentiation from the left hand side. So goes up, went down, goes up, went down, goes up, went down. What is the slope here? 1. Slope here, 1. So always it is giving a slope of 1, but differentiation, in the differentiation what you are doing? You are going from 1 to minus 1. That means you are losing the amplitude by 2. So you will be having the impulse of area minus 2. Are you able to understand this point or not? So at minus 3 I will be having the impulse, at minus 1 I will be having the impulse, at 1 I will be having the impulse, at 3 I will be having the impulse of area minus 2. So can I draw the waveform? What kind of waveform I will be getting? So where I will be having the impulses? Minus 3, minus 1, 1, 3. Minus 3, minus 1, 1, 3, 5, minus 5. In that manner I will be having the impulses. So this is my dyt by dt. What I am writing down? Dyt by dt. But along with that, it will have a dc value as well, right? It will have a dc value as well. So dyt by dt I will write down here. Why I am writing down here? Because it will have a dc value of 1. Slope is 1. Slope is 1. I hope you know how to do these kind of differentiation. Look, if you don't know these kind of differentiation, then you need to study basics of signal, or at least you need to revise basics of signal. So slope is 1, 1, 1, 1, 1. Everywhere the slope is 1. So everywhere there will be a dc of 1. There you go. This dc of 1 is there. But what did I tell you? Always you can ignore the dc. Now you will be having the impulses. Impulses of area 2. Impulses of area 2. Minus 2 you can say. Impulses of area minus 2. Impulses of area minus 2. So these impulses you are having, no impulse at 0. Okay. And what is the time period? Time period is 2 and area is minus 2. So what I can write down my dyt by dt as? So my dyt by dt is coming as x. What do you mean by x? The first waveform. This impulse train. This impulse train. This impulse train. What I will write down? Instead of writing all these things, impulse train with amplitude, although I am writing amplitude, but this means area, but impulse train with amplitude minus 2, shifted where? Shifted right or left? You can take anything. You can take right as well, you can take left as well. Basically, if someone was saying that this was at the origin, so someone is saying that it is shifted left by 1, or someone will be saying that it is shifted right by 1. So anything you can take. Basically x of t minus 1 or x of t plus 1, anything you can take. Both will give you same answer. Okay. So we are saying that it is shifted right. Shifted right by 1. Shifted right. What do you mean by shifted right? X of t minus 1 I will be taking. Right. Shifted right by 1. Time period of 2 plus some dc, which I will be ignoring, because I told you you can ignore the dc part. If I am ignoring the dc part, that means I am finding, now I will find c of n, y of t. What I will find? I will find c of n, but n is not equals to 0. If I am ignoring the dc, that means I am ignoring the c naught value. C naught value I am ignoring. Always you can ignore the dc part. Wherever you get dc, just ignore it. That means you are ignoring the c naught part. If this waveform is given, can you let me know if I am saying that yt is having a Fourier series coefficient of cn, Can you let me know just by looking at the waveform what will be the value of C naught? What is C naught? C naught is the DC value. What is C naught? C naught is the DC value. And what is the DC value of this particular waveform? Positive area, sorry, negative area, positive area, total area is 0. So what is the value of C naught here? 0. So now I don't need to care about any DC value. Basically, y of t is having C naught value equals to 0. Now I don't need to care about C0. That means I don't need to care about this DC value. So I will always ignore the DC. For finding the DC, I will just look at the waveform and I will find out C0 value. Now I am just ignoring the DC. I will just care about the impulse train. Right? So Jn omega naught Cn. What I am saying, Yt is having a Fourier series coefficient of Cn. So Jn omega naught Cn. Impulse train of area 2. That means value of A is minus 2 divided by the time period. What is the time period? That is also 2. Right? Minus 2 divided by 2. It is shifted by 1. Shifted by 1. Shifted right by 1. That means e to the power Jn omega naught minus 1. Say yes or no. Is that clear to you or not? Impulse train in the mind, what you are thinking? Impulse train, area minus 2. So A by T naught minus 2 by T naught. T naught value is also 2. Minus 2 by T naught. Shifted right by 1. Shifted right by 1. That means if I shift right, then I need to add the negative sign. Shifted right by 1. So e to the power minus j n omega naught T naught. T naught is minus 1. What is the value of omega naught? Omega naught is 2 pi by T naught. T naught value is 2. So this value is pi. One more thing, always the most important part is, everywhere here the time period was 2. Here also the time period was 2. So whenever I differentiate, my time period should not change. Time period is 2, I am happy. Here also time period is 2, yeah, it is matching, then I am doing it fine. In one of the problem, I will take one question where this will change. This is having 2, this will have 1. So how will you solve that kind of problem? There also I will tell you. And I will ask you to use your own brain there. Okay. So time period should not change. This is the most important condition. Omega naught value is pi. So what we are getting from here? Do we have the page? No. So anyway, we need to add the page. So let's add a page. So Jn omega naught is pi into Cn. Jn omega naught is pi into Cn is equals to minus 1. Here this will be minus 1 e to the power Jn omega naught is pi. Omega naught is pi, and then multiply with minus 1. So this is minus 1. From now onwards, you will remember one thing, e to the power minus j n pi. What that would be? E to the power minus j pi n. Right? What is the value of e to the power minus j pi? Minus 1. Right? E to the power minus j pi. What that would be? Cos pi minus j sin pi. Sin pi will be 0. Cos pi will be minus 1. So minus 1 to the power n. So e to the power minus j n pi whenever you see, or you can see e to the power j n pi as well. What that would be? E to the power j pi to the power n. What is the value of e to the power j pi? That is minus 1 to the power n. So this will also be minus 1 to the power n. Minus 1 to the power n divided by j n pi is equals to Cn. So this j goes upward, this will become plus j. So Cn is equals to j minus 1 to the power n divided by n pi. So this is the value of Cn, but this is not always true when n is not equals to 0. So what did we get to know? That our Cn is 0 when n is equals to 0, because C0 is 0. And when n is not equals to 0, it is coming out to be j of minus 1 to the power n pi. Say yes or no. Here it was not having any angle, right? Here we find out the value of C0, C1, C2, C3, C, and C of minus 1, C of minus 2, C of minus 3. So basically angle of Cn was 0. So here mode of Cn was equal to Cn only. Here I draw only one graph. Here I draw only one graph, Cn versus n. But here there is an angle, no? There is an angle. Or here also I could have drawn the graph of I should not say mode of Cn, angle of Cn is 0. Why is that so? Because what will be the angle of C3? Angle of C3. Negative value, no. Positive value has an angle of 0 degree. Negative value have an angle of 180 degree. Or you can say minus 180 degree. So angle will be minus pi here. Or you can write down pi. Either you write down minus pi or you write down pi. Here the angle is 0. Here what is the angle? 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 Angle is 0. But here what is the angle? Angle is pi or minus pi, whatever you can write down. Okay, so I should not have written that angle of Cn is 0. I could have drawn the graph of angle of Cn versus n as well. Angle of Cn versus n. Okay, that graph could also have been drawn. Angle of Cn versus n. So at n equals to 1 it was 0. At n equals to 2 also it was 0. At n equals to 3 it was pi. At n equals to 0 it was 0. Minus 1 it was 0. Minus 2 it was 0. Minus 3 it was 0. So at these angles it was pi and pi. Okay, so this could also have been done. And if I take mode of Cn, then this negative value will become positive value, right? Here what we are doing? Here we need to draw two graphs, right? So let's find out the value of C of 1. What is the value of C of 1? So minus 1 to the power 1. Here also 1. So what we are getting? Minus j by pi. Minus j by pi. So what is the magnitude? 1 by pi. And what is the angle? Minus 90 degree. Because minus j will throw minus 90 degree, right? Magnitude is 1 by pi, angle is minus 90 degree. What about C of minus 1? So C of minus 1. Minus 1 to the power minus 1 will be minus 1 only. Minus 1 j divided by, here also minus 1 you need to put. That would be equals to, this and this will get cancelled. So 1 by pi, angle of pi by 2. What about C? This was C of minus 1. What about C of 2? C of 2. This will become minus 1 to the power 2. That will be 1 only. So j by 2 pi. J by 2 pi. So magnitude is j by 2 pi. Angle is pi by 2. What about C of minus 2? C of minus 2. So j by minus 2 pi. So magnitude is 1 by 2 pi and angle is minus pi by 2. In that manner we are proceeding. So C of 1 is having a magnitude of 1 by pi. C of 2 is having a magnitude of 1 by 2 pi. C of 3 will have a magnitude of 1 by 3 pi. 1 by pi, 1 by pi, 1 by 2 pi, 1 by 3 pi. So 1 by 3 pi, in that manner the magnitude is coming. And what about the angle? C of 1 was having angle of minus pi by 2. Minus pi by 2. C of 1 was having angle of pi by 2. C of 1 was having angle of pi by 2. C of 2 was having angle of pi by 2. C of 2 was having angle of pi by 2. C of minus 2 was having angle of minus pi by 2. In the similar manner, C of 3 will have angle of minus pi by 2, and then C of minus 3 will have angle of plus pi by 2. So in that manner you can draw the graph as well. So these kind of things can be asked. Well and good. So you find out the expression for this particular waveform. Which waveform? This waveform, by using the differentiation property. Otherwise this would be very difficult to solve. So we just did the differentiation and we got the answer. What was the important part? We ignored the DC part. So C naught value we wrote down here. Ignore the DC part, then this impulse train we know how to solve. So very easily we are moving ahead. Do this one on your own. Okay, use your brain here. Here also some good concept will come out. Differentiation, again we will use differentiation. Otherwise you can go with Cn. This also you can go, right? What you will do? 1 by T naught. This differentiation will not be that tough. Sorry, this integration will not be that tough. X of t e to the power minus j n omega naught t dt. So what is T naught? You can directly see T naught is 1. What will be the value of omega naught? That will be 2 pi. So this integration is very easy. What is x of t? You will take the limit from 0 to 1. Why is that so? Because waveform is same. In 0 to 1 the waveform is e to the power minus t. So 1 by 1 you will take the integration from 0 to 1 e to the power minus t e to the power minus j n omega naught t dt. Omega naught value is 2 pi. So here 2 n pi I am writing. So that is 0 to 1 e to the power minus 1 plus 2 n pi 1 plus j 2 n pi into t dt. So this integration is not tough actually.
So e to the power j 1 plus 2n pi into t. Is there minus sign? This was e to the power minus t. This was also negative sign. So negative sign was there. Sorry, negative sign was there. So in the denominator, what will come? 1 plus 2n pi. Although negative sign would come, but what I am doing is that I am interchanging the limit. In the denominator, negative sign would come, right? Minus j would come. How will you integrate e to the power at? E to the power at. So that would be e to the power at by a. What is the value of a? Minus 1 plus j 2n pi. Minus 1 plus what I am doing? Minus 1 plus j 2n pi. Minus 1 plus j 2n pi. J 2n pi. So in the downward, what will come? Minus 1 plus j 2n pi. So this minus, I am interchanging the limit. Limit is going from 0 to 1. So what I am doing? 1 to 0. So this minus sign will be eaten up. Is that clear to you? Why I am doing so? Because e to the power 0 will, e to the power, if t is 0, then it will all be 0. So e to the power 0 will be 1. Right? Minus e to the power minus t. In place of t, what you need to put? T equals, in place of t, you need to put 1. Divided by 1 plus 2j n pi. Just in place of t, I have put 1, nothing else. E to the power minus t, e to the power minus j 2n pi t. So minus sign I took common, 1 plus j 2n pi t. Then this is how we were getting, I interchange the limit. So 0, 1 minus, this is how I have written down. So let's see this one. E to the power minus 1 plus j 2n pi. So that can be written as e to the power minus 1 into e to the power minus 2j n pi. So this will be 1 by e to the power 2 pi to the power n. What is the value of e to the power minus j 2 pi? E to the power minus j 2 pi. That would be cos 2 pi minus j sin 2 pi. What is the value of sin 2 pi? 0. What is the value of cos 2 pi? 1. So 1 to the power n. Always it will be 1 only. So this particular value is always 1. This particular value is always 1. So what you are getting? E to the power minus 1. So this can be reduced to e to the power minus 1. So this is what you are getting. 1 plus 2j n pi. So this is C of n we are getting. There you go. Is that clear to you? But you will do it with differentiation property now. Use your brain, something very good you will find out from here. Use the differentiation property here. Use that differentiation property. I want you to use the differentiation property here. Okay. So I will take a pause, drink some water because it's been roughly around 1 hour. You try doing it with respect to differentiation property. Well and good. Okay. So let me take a, yeah, welcome back. So let's do this question with the property of differentiation, right? So we will differentiate. So tell me one thing, you will start differentiating from minus infinity, right? So when you differentiate here, there is a jump, right? From e to the power minus 1 to 1, there is a jump. Here also there is a jump. Here also there is a jump. There is a jump. So there will be a positive impulse, right? What about this waveform? What is this? This is your e to the power minus t. What is this? This is your e to the power minus t. When you differentiate e to the power minus t, what you are going to get? Minus e to the power minus t. What is that? Minus xt. So when you are differentiating your xt, what you are getting? Impulses of amplitude 1 minus e to the power minus 1. Impulses of amplitude 1 minus e to the power minus 1 and minus of xt. Are you able to understand this point? Let's take this waveform. If I am differentiating this particular waveform, so what I am getting? I am getting impulses, right? I am getting impulses. In that manner, I am getting impulses. What is the amplitude of the impulse? The amplitude of the impulse is 1 minus e to the power minus 1. I should not say amplitude, this is area. 1 minus e to the power minus 1. And
when I differentiate e to the power minus t, I am getting minus e to the power minus t. That means this plus 1 will become minus 1, this plus e to the power minus 1 will become minus e to the power minus 1. Basically this kind of waveform I will be getting, this kind of waveform. Then again here it goes downward, then again it goes like this, then again it goes downward, again it goes like this. Here as well, first here at this particular point, this 1 will become minus 1, this e to the power minus 1 will become minus e to the power minus 1. So this point is minus 1 and this point is minus e to the power minus 1. So from minus 1 to minus e to the power minus 1 and then goes downward. Same goes here, minus e to the power minus 1, then again goes downward. In that manner, this kind of waveform we are getting. So what is this? This is your minus xt, right? I am representing by xt only. So this is your minus xt. And what is this? This is your impulse train. And what is the time period? Time period is 1. So what you are getting? This is the differentiation. So dxt by dt is equals to impulse train area or amplitude, whatever you want to write, that is 1 minus e to the power minus 1. Time period is 1, no shifting, plus minus of xt. Say yes or no. So what will be the Fourier series coefficient of this one? Jn omega naught Cn, right? Here I am saying that xt is having a Fourier series coefficient of Cn. So this will have Jn omega naught Cn, right? And what is the value of t naught? T naught is 1. One more thing you need to check. This is having a time period of t naught. This is also having a time period of 1 second. This is also having a time period of 1 second. And this is also having a time period of 1 second. Basically, all the time period are 1 second, 1 second and 1 second only. So no issue there. So all the time periods are 1 second, right? So omega naught value is 2 pi. Omega naught value is 2 pi. What will be the value here? What is the amplitude? 1 minus e to the power minus 1. Or you can say area divided by the time period. What is the time period? Time period is 1. Amplitude divided by the time period. That's it. There is no shift. This is simple impulse train. So A by T naught. Amplitude is 1 minus e to the power minus 1 divided by the time period. And what this would be? Minus sign, minus of Cn. Are you able to understand this point? Is that clear to you? Now what will happen? J omega naught Cn. Sorry, Jn omega naught Cn. Jn omega naught 2 pi into Cn. Then minus Cn goes here. This becomes plus Cn will be equals to 1 minus e to the power minus 1. 1 minus e to the power minus 1. Cn is equals to 1 minus e to the power minus 1 divided by 1 plus j 2n pi. Are we getting the same thing here? Yes. So this is the Cn we are getting. Within seconds I will be able to write down in the examination hall if I just notice one thing, that it is e to the power minus t. Differentiation will be minus e to the power minus t. So directly I will be writing down this step. I don't need to do all these calculations in the examination hall. I will see impulses and minus of xt. So directly I will be writing down this step and within 1 second without even doing anything I will be getting this answer. Say yes or no. Okay. So this is your Cn. Now you can calculate mode of Cn. What this value will be? This will be 0.632, right? Yeah, 0.632 and here the amplitude will be under root 1 plus 4n square pi square, right? What will be the amplitude of this one? A square plus b square, under root a square plus b square. So a is 1, a square plus 4n square pi square. This will be the amplitude. What will be the angle? Angle will be generated from here only because this is a constant value. So what will be the angle? Minus tan inverse 2n pi. This will be the angle. Okay. So you can check the values. What will be the value of C of 0? C of 0 will be 1 minus e to the power minus 1, that is 0.632. 0.632. In that manner, what will be C of 1? C of 1 will be 0.632 divided by 1 plus j2 pi. Right? So you can calculate these values basically. Everything you can calculate. So this kind of graph you will be getting. This is the graph of mode of Cn versus n, and this is the graph of angle of Cn versus n, right? At n equals to infinity, basically what will be the angle of C infinity? If I write down angle of C infinity, what will be the angle at infinity? Minus tan inverse infinity, that would be minus pi by 2. And what will be the angle at C equals to minus infinity? That will be minus tan inverse minus infinity, so minus can come out, it will be plus pi by 2. So when you go to infinity, the angle will be plus pi by 2. Just angle will keep on increasing in this manner, it will go till plus pi by 2, here it will go till minus pi by 2. And what about the amplitude? What will be the amplitude at infinity? So if you put n equals to infinity here, this will be 0. And what will be the amplitude at minus infinity? That will also be 0. So amplitude will keep on decreasing like this and it will go to 0. Here also it will keep on decreasing like this and it will go to 0. Is that clear to you or not? All these concept, everything is crystal clear? Say yes or no. It was on the easier side only. One important thing was I was getting the same thing here. I was again getting my xt. Well and good. Let's go to the next question. This one. You should be able to do this one on your own at least. Again we will differentiate, but we will differentiate it twice. What is the slope here? What is the slope? M equals to minus 1. What is the slope here? M equals to 1. What is the slope here? M equals to minus 1. Slope here 1. No discontinuity anywhere. There is no discontinuity, right? Minus 1 plus 1 minus 1. So from minus 1 to 0, plus 1 will come, then minus will come, plus 1 minus 1 plus 1 minus 1. This kind of waveform will come. This is your dx by dt. But here again I did not get the impulses. But one thing I know that now again I will differentiate positive impulse, negative impulse, positive impulse, negative impulse, positive impulse, negative impulse, positive impulse, negative impulse. In that manner I will get. And what is the T naught value here? T naught value is 1. Sorry, not 1, sorry. T naught value is 2. What is the T naught value? T naught value is 2. Right? This T naught value is 2. So now I will differentiate. So what I am getting? So here positive impulse, at minus 3 positive impulse, at minus 2 negative impulse, at minus 1 positive impulse, at 0 negative impulse, at 1 positive impulse, at 2 negative impulse, at 3 positive impulse. Right? So here the area is 2, area is minus 2, area is 2, area is minus 2, area is 2, area is minus 2, area is 2. So what is this point? This point is minus 1 and this point is 1. This point is minus 3, this point is minus 2 and this point is 0, this point is 2, this point is 3. So again two kind of pulse train are there. Here there are two kind of pulse train. This is having a time period of 2 and the other one is also having a time period of 2. So two impulse trains are there. One is shifted by 1, one is shifted backward by 1. And sorry. One is there at the origin itself. One is there at the origin itself. Are you getting this point? What I mean to say is that d square xt by dt square is having a impulse train of area minus 2 and which is not shifted. This impulse train is not shifted. Only this impulse train is shifted. So one is there as it is. Are you able to understand this point? Impulse train. What is the area? Area is minus 2. Area is minus 2. What is the time period? Time period is also 2. No shift. Plus another impulse train is there. What is the amplitude? Plus 2. Amplitude is plus 2. Someone will say that sir it is shifted by 1 left or someone will say that sir it is shifted 1 by right. Both are true. We will take right shift. Okay. So T naught is 2 only. Shifted right by 1. Right by 1. So what I am gonna write down here? Area 2 divided by 2. No shift. Jn omega naught. Yeah, this I forgot to tell actually. Basically, xt is having a Fourier series coefficient of Cn. So dxt by dt will have a Fourier series coefficient of Jn omega naught Cn. Then again you are differentiating, no? Again you are differentiating. So again what you will add? Jn omega naught into Jn omega naught into Cn. So what you are getting? Jn omega naught square Cn. Are you getting this point? So if I differentiate for the k times, if I differentiate for k times, what I will be getting? Jn omega naught to the power k Cn. Is that clear to you? Very basic thing. There in the property I only told one differentiation. If I do it twice, that means Jn omega naught again come. Then if I do it thrice, then 3 times it would come. And if I do it k times, then k times it would come. So here what I will do? Twice C of n plus amplitude is 2, time period is 2, but it is shifted. So minus Jn omega naught t naught, that is minus 1. T naught will be minus 1 because it is shifted right. What is the value of omega naught here? What is T naught? T naught was 2. So what will be omega naught? 2 pi by 2, that will be pi only. So omega naught value is pi. Omega naught value is pi. So here omega naught is equals to pi. Right? So what we are getting? Here why I am writing n? It would be square. So what I am getting? Minus n square minus omega square. J square will be minus 1. N square, omega is pi. Omega square Cn minus 1 plus this is 1 only. What this would be? A to the power minus j n omega. Omega naught value is pi. So minus 1 to the power n. This I have already told. Because e to the power minus j pi is minus 1. Minus 1 to the power n. So 1 into minus 1 to the power n. So what I am getting? Minus n square pi square Cn minus 1 plus minus 1 to the power n divided by this minus n square pi square. From here I am dividing it. So this minus 1 can go upward. So C of n is minus 1 to the power n minus 1. Sorry. This was already plus. So 1 minus 1 to the power n divided by n square pi square. This is what we are getting. This is the final answer. Say yes or no. So this is the Cn we are getting. Are we having any page? No. But C of 0, if I put 0 here, then it will not be defined. If I put 0 here, what will happen? It will not be defined, right? It will be the form of 0 of 0. Here, let's add a page. C of n, you have understood what we are getting C of n. So C of n is coming out to be 1 minus 1 to the power n divided by n square pi square. C of 0 if I put, so 1 minus 1 to the power 0, that would be 1 only, 1 minus 1 divided by 0 square into pi square, that would be 0, 0 by 0, again not defined. So what I will do? For C of 0 what I will do? This I am not gonna take. For C of 0 what I can do is that I can simply integrate. Right? For one time period I can integrate and then divided by the time period. So what is this area? What is this particular area? That is half into base into height. So this area is 1 divided by the time period, that is 1 by 2. So C naught value is 1 by 2. Basically divided by the time period is 1 by 2, and the area half into base into height. So what is the C naught value you are getting? 1 by 2. So this is the value of C naught that you are getting. C naught value is 1 by 2. What about C of 1? C of 1 will be, here if you put 1, so what that will become? Minus 1 to the power 1, that would become 2. 2 by pi square. Are we getting the same thing? Yes, 2 by pi square. What will be the value of C of minus 1? C of minus 1 will also be same only, because minus 1 to the power minus 1 will be minus 1 to the power minus 1 will be minus 1 only. So 2, and here minus 1 will come. So 2 by pi square. What will be the value of C of 2? Minus 1 to the power 2. That would be plus 1. So 1 minus 1 will be 0 only. And what will be C of minus 2? That will also be 0. What will be C of 3? That would be minus 1 to the power 3 minus 1. So this will be 2 by 9 pi square. And C of minus 3 will also be the same. 2 by 9 pi square. In that manner we are getting the values. So this is the graph we are getting, right? So directly you can see here 2 by pi square, 2 by 9 pi square, then 2 by 25 pi square, and these values will be 0. So C of 2, C of minus 2, C of minus 4, C of minus 6. So only for even values it is defined. Sorry, only for odd values it is defined. Only for odd it is non-zero. And here also you can check. For even it is coming out to be 0, for odd it is coming out to be non-zero. So this is how I can tell my C of n. Say yes or no. Let's go to the next one. This one, a very good question. Think of it. Look, by the formula if you go, then what you need to do? Large calculation. Basically, 1 by t naught in the time window t naught xt e to the power minus j n omega naught t dt. Time period directly I can see. Time period is 1. What is the value of omega naught? Omega naught value is 2 pi. Right? Omega naught value is 2 pi. This we can directly see. From here, what will be the time period coming? 2, but it would be half since there is a mode. So t naught is 1. Or directly in the waveform also you can see t naught is 1 only. This t naught is 1 only. So omega naught will be 2 pi by t naught, 2 pi. Right? Now what I can do? 1 by t naught is 1 only. Then goes from 0 to 1. In 0 to 1, what is the value of this particular function? That is sin pi t only. So sin pi t e to the power minus j n 2 pi t dot dt. You solve this integration. What you can do? You can convert sin pi t into e to the power j pi t minus e to the power minus j pi t divided by 2j. And then you apply the formula and all these things you can solve. Okay, it would not be that big, but surely it will be bigger. Solve and you will get the value of Cn. What if I differentiate? So what is this portion? Sin pi t, right? This portion is sin pi t. This portion is also sin pi t only. Are you getting this point? Minus of sin pi t, I would say. This portion is minus of sin pi t. Basically, what will be the graph of sin pi t? This will be the graph of sin pi t. This is the graph of sin pi t. 0, 0, 1, and same graph will be happening here as well. 0, 1, 2, 3. So I can call this graph is sin pi t, right? This graph is also sin pi t only. This is the graph of sin pi t. So this I will call as sin pi t only. Because what is the value of, let's just say 3 by 2, sin 3 pi by 2. What is the value of sin 3 pi by 2? That is minus 1. Yes, this is true. But what value I am actually getting? That is plus 1. That means I am multiplying this particular lower value with the minus sign. So it will become plus. So this is minus sin pi t. Are you able to understand this point? This is sin pi t. This is minus sin pi t. Basically, whatever the differentiation you will get here, the same differentiation you will get here as well. So if I just differentiate this waveform, then will I be able to write down the differentiation of this waveform? Will I be able to write down the differentiation of this waveform? Yes. So forget about all these things of sin pi t, sin minus pi t. Don't get confused. Just you need to differentiate this particular waveform. So if you differentiate, what you are getting? Look, in the examination, within minutes or within seconds, you will be able to write down the Fourier series coefficient of this one by the help of Fourier transform. Very easily you will be able to write down. But as of now, you need to learn this process. Okay? As of now, you have to learn this process. But in the examination, very easily you will be able to write down. But if you are learning this process, you are going to learn something good. So what is the differentiation of sin pi t? That is pi cos pi t. Right? So what kind of graph I will be getting? Pi cos pi t. That means at t equals to 0, my value will be pi. At t equals to 1, my value will be minus cos pi. Basically, if I do the differentiation dxt by dt, this differentiation is very good actually. Okay. So I am differentiating this particular waveform. What I go to know, it will be pi cos pi t. That means at t equals to 0, I will be getting pi. At t equals to 0, I will be getting pi. And at t equals to 1, I will be getting, if I put t equals to 1 here, what I will be getting? Minus pi. So at t equals to 1, I will be getting minus pi. I will be getting minus pi. And you can see here, no, if I differentiate, what is this slope? This slope is positive. Then the slope becomes 0. And then the slope becomes negative. So slope was positive. then it became 0, then it became negative. Are you able to understand this point? Positive, 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 then it became 0 and then it became negative. What this point will be? This point will be half. Basically at this particular point my slope will become 0, so this point will be half. So positive, 0 and negative. What will happen next? Again it goes here, again it goes here, again it becomes positive, then 0, then negative, right? So again what will happen? There you go. Again I will reach at pi, because this portion will also have pi sine pi cos pi t. Again the differentiation will be the same, positive, 0, negative. Again at this particular point it will throw pi, then at this particular point it will throw minus pi, then again the same cycle goes on. Are you able to understand this point? So basically from 1 to 2 the same cycle goes on, because the waveform is same, so differentiation will also be same. So between 1 to 2 the same cycle goes on, right? And in that manner the cycle keeps on going. A very good differentiation we are learning. This is just clearing your mathematics as well. So similar thing is happening here as well. Negative, 0 and positive. So this was your minus 1. So at minus 1 it was positive. At minus 1 it was positive, positive, 0 and then negative. So in that manner we are getting it. Okay. So just I am keeping it like this. Minus 1, this is minus 2. So what is this waveform? If I just call this waveform, that is pi cos pi t. This waveform is pi cos phi t, and in that manner we are getting. If I differentiate again, what I am doing? D square xt by dt. If I differentiate again, what I will see? Jump, 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 jump and jump. Jump of 2 pi. I will be getting impulses. What about this one? If I differentiate d by dt pi cos pi t, what I will get? Minus pi square sin pi t. And what is sin pi t? Xt only. Basically what kind of waveform I will be getting? Always there is a negative impulse, no? Always there is a negative slope. Always there is a negative slope, negative slope. So what kind of waveform I will be getting? Minus pi square sin pi t. That means at t equals to 0, if I do double differentiation, so at t equals to 0 I will be getting the value 0. At t equals to 1 I will be getting the value 0. So here also there is 0 slope, here also there is 0 slope, but in between the slope is negative. So in between the slope is negative. At 1 by 2 what is the value I am getting? Minus pi square. Minus pi square. At 1 by 2 I am getting the value of minus pi square. Are you able to understand this differentiation? Along with that there are impulses at 0, 1, 2, 3. In that manner there are impulses. Why I am doing the differentiation? Because I know that if I differentiate sinusoid twice, I will again get the sinusoid. That's why I am doing the differentiation. Again I am telling, this thing you are not going to do in the examination hall. Only for now you are doing it for learning purpose, because who knows in the examination you need to use differentiation of sinusoid, not in the problem of Fourier series. Who knows you need to use it in the problem of analog electronics or in the problem of mathematics, anywhere it might be used. That's why I'm just building up your concept for the examination purpose, not for signal system. If I wanted to teach for signal system only, then I could have completed it within 2 minutes. But all these build up your concept for your examination, right? So we are learning the differentiation. So when we differentiated, we got to know that here the slope is changing. That's why there is discontinuity. In the differentiation, there is discontinuity. And when you differentiate at discontinuity, impulses come. So what will happen? Impulses are coming. Impulses are coming. In that manner, impulses are coming. Are you able to understand this point? So this is 0, 1, 2, 3. 4, and then another impulse is there. Right, in that manner. So -1, -2, and then again impulses are there, again impulses are there. And what is the length? 2 pi, or you can say what is the area, that is 2 pi. And what is this? This is minus pi square sine pi t. Basically this is your just negative of the given function. So this is your minus pi square xt. Are you able to understand this point? Because given function is just sine pi t, this is just the negative of that. So I can write down in this manner. This is your minus pi square xt. Say yes or no. So what you are getting? D square xt by dt square is equals to impulse train area or amplitude, whatever you write, that is 2 pi. Time period t naught is, time period did it change? T naught equals to 1. It was 1 only. Here also it was 1 only. Time period did not change. So I am happy. T naught is 1. Right? Is there any shift? No. There is no shift. It is starting at 0 only. So there is no shift. There you go. Plus pi square minus xt. Pi square minus xt. Is that clear to you or not? Are you learning something pretty good? Yes. Differentiation, and then in that manner differentiation. Well and good. So what this would be? J n omega naught square. What is the value of omega naught? That is 2 pi. J n omega naught square Cn, amplitude is 2 pi divided by T naught is 1, right, minus pi square Cn. We just wrote down the Fourier series coefficient of this particular thing. Impulse train, amplitude 2 pi divided by T naught. There is no shift. There you go. So what I will write down here? N square omega naught square, that would be 4 pi square, and j square would be minus 1. So omega naught is 4 pi square, j square is minus 1, is equals to 2 pi minus pi square Cn. Okay. So here what I am getting? Pi square into 1 minus 4n square Cn is equals to 2 pi. Pi square Cn, 4 pi n square Cn. Yeah. So what is the value of Cn? That is 2 by pi into 1 minus 4n square. So this is the value of Cn that we are getting, right? Do we have the waveform? No. So this is the value of Cn we are getting, right? What will be the value of C naught? C naught will be 2 by pi, because if I put 0 here, or I can check from here as well. Do you remember the area of this particular thing? Do you remember the area of this particular thing? That was 2 Vm by pi into this width divided by the time period. What you are getting? 2 by pi only. Are we getting the same thing? Do you remember the area of this lobe? That was 2 Vm by pi into alpha into this width. So what is this width? This width is 1. And then I need to calculate the average. That means I need to divide by the time period. So what is the time period? What is the average we are getting? 2 Vm by pi. So what is the average? 2 Vm by pi. Vm value is 1. So 2 by pi. This is the value of C naught. What will be the value of C1? C1 will be 1 if I put minus 2 by 3 pi. What will be C2 or C of minus 1? C of minus 1 will be equals to C of 1 only, because if you put minus 1 here, that would be same. So this would be equals to C of minus 1, right? Here you can see that if I put minus 1 here, that would become the same only, because in place of n, if you put minus n, it will give the same result. What will be the value of C2? That would be equals to C of minus 2. If you put 2 here, 16. So minus 2 by 15 pi. Minus 2 by 15 pi. Right? So all these things we are getting. Say yes or no. Well and good. Okay. So this is the answer we are getting, right? Let's do the next one. Try doing it on your own. Try doing it on your own. Apply the differentiation property and try doing it on your own. Here, keep notice towards this particular thing. Time period same, time period same. Are you getting the time period same? Okay. I will drink some water and then I will solve this question. Okay. So you try doing it on your own. There is something different. In this question, there is something different. And that you need to think what is different. Okay. Yeah. Yeah, so let's start. Let's do this question. So here amplitude was not given, which I have written, that is 1. Okay. So what is this graph? This graph is sine t. Why it is sine t? Because at sine 0 you are getting the value 0, sine pi you will get the value again 0, at sine pi by 2 you will get the value to be 1. So this is sine t, and you can think as well, right? What will be the graph of sine t? You can make in this manner, that this period will be 2 pi. This part is already not there, only I need to write down this part, so that is sine t only. So what you will do? This part is sine t. Well and good. What I need to do? I need to differentiate. So d by dt sine t, what that would be? Minus, sorry, not minus, cos t. That means at t equals to 0, I will get the value to be 1. At t equals to pi, I will get the value to be minus pi. Sorry, minus 1. At t equals to 0, I will get the value to be 1. At t equals to pi, I will get the value to be minus 1. And you can check as well. Positive slope, 0 and negative slope. Positive slope, 0 and negative slope. So I need to differentiate. So what I am doing, dxt by dt I am writing. So cos t I will be getting in this particular region. Here what will be the slope? Differentiation will be 0. Again here cos t, the same waveform I will keep on getting. What is the time period of this particular thing? Time period is 2 pi. What is the value of omega naught? That is 1. Time period is 2 pi, omega naught is 1. Okay, so let's do the differentiation, that is cos t. So cos 0 is 1, cos pi is minus 1. So starting from here, 0 and 1. So cos 0 is 1. Cos 0 is 1 and cos pi is minus 1. Right? In the similar manner, 1 and minus 1. In the similar manner, wait a second, sorry. Between 1 to 2, really sorry. Between 1 to 2, it is 0, no? Between 1 to 2, the slope is 0. Or you can say between pi to 2 pi. This is not 1, sorry. This is pi. So between pi to 2 pi, the slope is 0. Between pi to 2 pi, the slope is 0. And then again it will rise up. Then again it will follow the same procedure. Between pi 2 pi to 3 pi. 2 pi to 3. Positive slope 0 and negative slope 2 pi to 3 pi. Then again it is 0. And in that manner it will keep on going. 2 pi to 3 pi. Similarly here as well. Between 0 to minus pi. Between 0 to minus pi, the slope is 0 only. Right? But here the slope is negative, here it is positive and then 0. So positive, negative, 0. Sorry, positive, 0, negative. So what is the scenario here? Starting with positive. Positive is there at minus 2 pi. So starting with minus 2 pi. So positive, 0 and then negative. So basically the same waveform is being repeated. Right? So you feel like that it is like the old question only. Now again I will differentiate, so I can see that jump, and then there is a jump. Here also when I go down there is a jump, and then there is a jump. So again there is a jump. What is this amplitude? This is 1 only. This is 0 and this is minus 1. So jump are there of 1, minus 1 to 0, 0 to 1, minus 1 to 0, 0 to 1, minus 1 to 0. So jump are there of 1, 1, 1, 1, 1. So here I will have the impulses. What about this one? What this was? Cos t. So if I differentiate d by dt cos t, what I will be getting? Minus sin t. Right? Basically, here the slope is 0, here the slope is 0, all negative. All the slope is negative. Or you can check, sin 0 will be 0, sin pi will be 0, in between negative slope will be there. So between 0 to pi, this is pi, this is 2 pi, 2 pi to 3 pi, and here what will be the slope? Here the slope will be 0 only. So between 0 to pi, negative slope, and then 0, then negative, then 0, 0 to minus pi, negative, oh sorry, 0 to minus pi, 0 slope, then minus pi to minus 2 pi, again negative slope. If you are listening to me, then only you are understanding, otherwise you are not understanding anything. And what will be this amplitude? This amplitude will be -1. You have to listen. A very important point is about to come now. Now let's make the impulses. So impulses are there at -2 pi, minus pi, pi, 2 pi, 3 pi. So here there is an impulse, here there is an impulse, here there is an impulse, here also there is an impulse, here also there is an impulse, impulse and impulse. What is the area? Area is 1 only. Now for this particular function, what is this function? This function is just the negative of xt. So what is this? This is your minus xt. And time period of this minus xt is, what is the time period of this minus xt? That is 2 pi only. What was the time period here? That was also 2 pi. What is the time period of this impulse train? What is the time period of this impulse train? That is pi. Time period of this impulse train is pi. And this I don't want. What did I say? Whenever you write down, if I write down d square xt by dt, what I will write down? That there is an impulse train, right? Amplitude 1. Till this point everything is fine. No shift, but time period is pi. Here minus xt. Time period is 2 pi. You cannot add them up now. What was the time period here? Initially, that was 2 pi. Here initially the time period was 2 pi. So now you need this time period to be 2 pi. This impulse train, we need time period to be 2 pi. We need time period 2 pi only. This is our target now. We need time period to be 2 pi. So what I can do? I can break this impulse train into two impulse train. One impulse train will be this one, having a time period of 2 pi. This will be one impulse train, and the another impulse train will be this one, having a time period of 2 pi, but shifted. Are you able to understand the point or not? What I am doing? I am breaking down the impulse train into two parts. Because I need the time period to be 2 pi. So I will have to consider two impulse trains. One. This is how I am breaking the impulse trains. Then another impulse will be in between. Right, so this is the impulse train 0, 2 pi, 4 pi, minus 2 pi, minus 4 pi with the area of 1. And what is this? Pi, 3 pi, 5 pi, minus pi, minus 3 pi. If I add both of them, what I will get? Again the same impulse train I will get. Basically in this differentiation I am having three functions. One is this one, another one is this one, and another one is minus xt. And why I broke down in this manner? What is the issue? The issue was with the time period. Here time period was coming out to be pi, but I needed the time period to be 2 pi. Now what I can write down? What I can write down? I need to add a page now. So now what I can write down? d square xt by dt square. At least 2-3 pages I need to add. Another page. So d square xt by dt square is equals to, there is one impulse train with amplitude of 1 only, time period of 2 pi. Then there is another impulse train with amplitude of 1 only, or you can say area of 1, time period of 2 pi, but
shifted by 1, shifted by pi, shifted by pi to the, you can shift backward as well, you can shift ahead as well. Shifted by, I am saying it is shifted pi ahead. So shifted by pi right, right shifted by pi, and then minus xt. This is the scenario now. So here what I will get, Jn omega naught square Cn is equals to impulse train of amplitude 1, time period 2 pi. Impulse train of amplitude 1, time period 2 pi, e to the power j n omega naught into pi, but right shifted, so minus pi, right shifted, so minus pi, j n omega naught minus pi. Are you able to understand this point? And what is the value of omega naught? T naught is 2 pi, T naught is 2 pi, so omega naught is 1. So that we will write down, and here minus Cn. So omega naught is 1. So what this will become? Minus n square Cn. Omega naught is 1. So j square will be minus 1 minus n square Cn is equals to 1 by 2 pi plus 1 by 2 pi e to the power minus j n pi, and omega naught is 1 only, into omega naught is 1 minus Cn. So this minus Cn goes here, 1 minus n square Cn. What this would be? What is the value of this one? Minus 1 to the power n. This I have already told. So 1 plus minus 1 to the power n divided by 2 pi. And sorry, this was minus n square Cn plus Cn. So this would be 1 minus n square into Cn. So what is the value of Cn I am getting? 1 plus minus 1 to the power n divided by 2 pi into 1 minus n square. So this is our Cn. Are you able to understand this point or not? Right? Is that okay for you? But more things are there. Let's analyze this Cn. So Cn we have got out, and it was a very good concept. We started with the differentiation, everything was going smooth, but the impulse train that we were getting, that was having an issue, because if I am adding up both of the, if I am adding up these two, that means I need to make the time period same, then only I can add them up. So this was having 2 pi, so I made this one also as 2 pi, and here also I was having 2 pi only, because here I need to replace j and omega naught, no, so here also I need to put 2 pi. Basically omega naught is 1, our time period is 2 pi, so omega naught is 1. So here also I need to put the same thing, here also, so everywhere I need to put the same thing only. So for that I broke down my impulse train into 2 impulse train. This is what I thought, that one is as it is, other one is shifted, so 2 impulse trains are there. So this is how I am breaking it, this is how I am breaking it down, and from there I get the expression of Cn. So let's write down the expression of Cn. I need to analyze this expression more. 1 plus minus 1 to the power n divided by 2 pi 1 minus n square. So what will be C of 0? That would be 1 plus minus 1 to the power 1, 2 pi n square, 0 square will be 0 only, so this will be 2 by 2 pi, that means 1 by pi. So C of 0 is 1 by pi, that you can already see from here as well. From here as well. What will be the value of C naught? This area, what will be this area? 2 Vm by pi into alpha divided by the time period. So what we are getting? 1 by pi. All these things I have taught in a very good manner. Okay, I have spent a lot of time. How to write down the area, how to write down the area of square, Vm square by 2 into alpha divided by the time period. All these things we have taught. So 2 Vm by pi, in 2 Vm by pi, this is the lobe, into alpha. Alpha is pi here, divided by the time period. So C naught is 1 by pi. Wait a second. Yeah, C naught is 1 by pi. Are we getting the same thing here? We are getting the same thing. What is the value of C of 1 here? So C of 1 is creating an issue. C of 1 is coming out to be 1 plus minus 1 to the power 1 divided by 2 pi into 1 minus 1 square. And the same issue will be created by C of minus 1 as well. Basically, we are getting 0 by 0. So from here, we cannot make any conclusion. So C of 1, I need to calculate. What I am saying, C of 1, I have to calculate.
What will be the value of C of 2? C of 1 I have to calculate, and C of minus 1 also I have to calculate. So let's keep it here only. What will be the value of C of 2? So 1 plus 1, 2 divided by 2 pi, 1 minus 4. So that would be 1 by minus 3 pi. And the same value you will get for C of minus 2 as well, because you will put minus 2 here, that will give you the same result. What will be the value of C of 3? Minus 1 to the power 3, that would be 1 minus 1. Whatever that is coming here, I don't care. Minus 1 to the power 3, what that would be? Minus 1 only. So 0 divided by anything would be 0 only. So C of 3 will be 0. C of minus 3 will be 0. In the similar manner, C of 5 will be 0. And C of minus 5 will be 0. C of 6 will be 0. Sorry, not C of 6. C of 7 will be 0, because minus 1 to the power 7. If minus 1 to the power odd is there, what this will make? 0 only. So here if I say my n is odd, so my C of n will be 0 for n equals to odd, except n equals to 1, because at n equals to 1 what we are getting? Undeterminate form. So for C1 I need to calculate separately, so that I will do, but Cn is equals to 0 for n equals to odd. And if n is equals to even, then what will happen? C of n will be 1 plus, this will also become 1 only, no? Because minus 1 to the power even, minus 1 to the power even, minus 1 to the power 2, minus 1 to the power 4, minus 1 to the power 6, what that would become? 1 only, divided by 2 pi, 1 minus n square. So 2 divided by 2, what we are getting? 1 by pi into 1 minus n square. So if n is even, what we are getting? C of n is 1 by pi 1 minus n square, right? So a lot of conclusions we are making. Let's go to C of 1 now. So C of 1 is creating an issue, so I will solve it with the basic concept. What does the basic concept says? That what is the basic formula of C of n? Basic formula of C of n is 1 by t naught integrate for a time period x of t e to the power minus j n omega naught t dt, right? What is the time period? 1 by 2 pi. Then you integrate from 0 to 2 pi. You see this waveform, you see this input waveform, you integrate from 0 to 2 pi. What I need to do? I need to put n equals to 1 now. So n equals to 1 I need to put. T naught window 0 to 2 pi only. X of t and e to the power minus j, n equals to 1. What is the value of omega naught? Omega naught is also 1. Omega naught is also 1. N is also 1. So e to the power minus jt dt. Now xt is non-zero between 0 to pi only. Xt is non-zero between 0 to pi, and that is sin t only. So xt is non-zero between 0 to pi, which is equals to sin t e to the power minus jt. So here we need to do the mathematics. There is no other way. 1 by 2 pi, what I will do? 0 to pi e to the power jt plus e to the power minus jt divided by 2 into e to the power minus jt dt, right? So what we are getting? This and this will be orthogonal, no? E to the power jt and e to the power minus jt. And really sorry what I am doing here. Sin t is replaced with divided by 2j. So e to the power jt and e to the power minus jt will be orthogonal. Say yes or no? Can I say like that? They will be orthogonal only, but let's solve. Let's solve. So what I am getting? 1 by 2 pi, 0 to pi. This 2j comes outward. This will become 1 by j 4 pi. Basically this will throw pi only, I can see it. The result will throw pi only, but I have to solve anyway. So 1 minus e to the power minus j2t dt. So what will be the integration? 1 by j 4 pi. Now this is dt, so this will throw pi, minus e to the power minus j2t, and that is being integrated for one cycle. what I mean to say is that basically this one integration will throw t, 1 dot dt will be t, then e to the power minus 2jt divided by minus 2j going from 0 to pi. So minus j by 4 pi. Here what I will put pi plus e to the power minus j2 pi divided by 2j minus 0 minus what is e to the power 0, that is 1 by 2j. Or here it is plus. So e to the power j2 pi, e to the power j2 pi and then minus sign, what that would be? It would be 1 only, no? Cos 2 pi minus j sin 2 pi, sin 2 pi will be 0, cos 2 pi is 1. So that would be 1 only. So this is 1 by 2j, this is minus 1 by 2j. 1 by 2j minus 1 by 2j. So this and this will get cancelled out and pi will get cancelled out. So what is the value of C of 1 I am getting? That I am getting is minus j into 0.25. Minus j into 0.25. Say yes or no? And now we need to calculate C of minus 1, right? So we can do the same process for C of minus 1, or what we can see that our x of t is real, right? X of t is real. This is what I can see, that my x of t is real. This is a half wave symmetric sinusoid. So x of t is real. So can I say x of t is equals to x conjugate t? And can I say C of 1 will be equals to C of minus 1 conjugate? And if I take the conjugate on both of the side, C of 1 conjugate will be equals to C of minus 1. So C of minus 1 will be equals to C of 1 conjugate, that would be J 0.25. So this will be your C of minus 1. Without doing the calculation, I got the value. So J 0.25 is C of minus 1, C of 1 is minus J 0.25. For n equals to odd, it is coming out to be 0. For n equals to even, this is what it is coming out to be. So basically, what we can write down, what we can do is that we can add a page and then we can comment on C of n. What that would be? That comment would be that at 0 you are getting the value to be 1 by pi. 1 by pi when n is 0. Okay. And when n is 1, it is minus j 0.25. When n is minus 1, it is j 0.25. It is 0 when n is odd. Odd means plus minus 3, plus minus 5, plus minus 7 and so on. And it is equals to 1 by pi divided by 1 by pi, basically this is 1 by pi into 1 minus n square when n is even. You can say even at 0 this will work, right? At 0 plus minus 2 plus minus 4 plus minus 6, there you go. And always that condition is followed, that C of n is equals to C of minus n conjugate. Always it is followed. You can check, because this part is always real. So C of n will certainly be equals to C of minus n conjugate. Why is that so? Because if you put 1 by pi 1 minus n square, C of minus n 1 by pi 1 minus n square will be n square only, and then you take the conjugate of this. This is a real value only, so conjugate will be the same. So C of n is equals to C of minus n conjugate is always followed, and it has to be followed. Why is that so? Because xt is real. Here also it is followed, and here also it is followed. C of 0 is equals to C of 0 conjugate, right? So it is always followed. So this is the summary of C of n. Although in the examination within seconds you will be able to write down the value of C of n within seconds. We will just write down the Laplace transform of this one, then we will replace s with j n omega naught. That's it. But that will come after Laplace transform. All these things are also necessary so that you build up a good concept. Here a very good concept we got to know. This one. What is that concept? That time period is different. Based on that only next question is framed, which is this one. A very good question. MSQ. Okay. It is an MSQ. You need to find Cn. Cn of this particular function. So what is this? This is an impulse train with the time period of half, and this is an impulse train with the time period of 3 by 2. How? You will put m equals to 0, delta t. You put m equals to 1, delta t minus 1 by 2. You put m equals to 2, delta t minus 1. You put m equals to 3, delta t minus 3 by 2. You put m equals to minus 1, delta t plus 1 by 2. You put m equals to minus 2, delta t plus 1, then delta t minus 3 by 2. So basically, there is an impulse train. Two impulse trains are added. One is having a time period of 1 by 2, other one is having a time period of 3 by 2. Is that clear to you or not? 0, 1 by 2, 1, then 3 by 2. Then ahead, in that manner it keeps on going. Here also the same thing, minus 1 by 2, minus 1, minus 3 by 2, and then it keeps on going. So half I need to add, 0, half, 1, 3 by 2, 2, 5 by 2, 3, minus half, minus 1, minus 3 by 2, minus 2. And the other one is also an impulse train, 0, 3 by 2, 3, minus 3 by 2, and in that manner. But both are having different time periods, so you cannot add them up. Although you can add them up, but for purpose of calculating Fourier series coefficient, we are not going to add them up. So minus 3 by 2, 0, 3 by 2, and 3. So what you can write down? Your x of t is impulse train. Amplitude is 1 only, no? Amplitude is 1. Impulse train, amplitude 1. Impulse train it is, amplitude is 1. What else you can tell? Time period is 1 by 2. No shift. Plus impulse train, area or amplitude, whatever you call it, is 1. Time period is 3 by 2. So there you go, there is an issue. 1 by 2 and 3 by 2. So you cannot make 3 by 2 as 1 by 2, right? 3 by 2 as 1 by 2 you cannot make. But here what you can see? 3 by 2, another 3 by 2, and another 3 by 2. So I can break it down into 3 impulse train of time period 3 by 2. One will be at the origin, one will be shifted by 1 by 2, another one will be shifted by 1. There you go. Say yes or no. Right? So this can be broken. This can be broken. Again, we need to add a lot of pages. So this can be broken in impulse train, amplitude 1 and time period of 1 by 2, plus impulse train, amplitude 1, time period of 1 by 2. Now this is what I am talking about. This is what I am talking about. This impulse train I am talking about. Not this one. 1 by 2 and then shifted backward by 3 by 2. That means this impulse train I am talking about. Are you able to understand this point? So this impulse train is shifted ahead by 1 by 2. Can you say this? Shifted ahead by 1 by 2. Right? So shifted right by 1 by 2. Shift. Oh, sorry. Time period of 3 by 2. Sorry. Time period of 3 by 2. This is also time period of 3 by 2. Shifted right by 1 by 2. Plus again impulse train, amplitude 1, T naught is 3 by 2, shifted right by 1. Which impulse train I am talking about? This one. 1. Then 1 plus 3 by 2, this. Then here, this impulse. Right? This impulse. So 3 by 2 gap is there. So basically here I could see that after every 1 by 2 there are impulses. So I broke it down. How I broke it down? This one, this and this. Then this and ahead. And then this and ahead. In that manner I broke it down. Because I needed the time period to be 3 by 2. So 3 by 2, another 3 by 2, another 3 by 2. So shifted 1, 3 by 2, shifted half, 3 by 2 and 1 at the same point. So this is how it is broken. This is how it is broken. This is how it is broken. And then another one, impulse train with amplitude 1 and T naught is 3 by 2. So what you will see, these two are same only. What I mean to say is that amplitude 1, T naught is 3 by 2. Here amplitude is 1, T naught is 3 by 2, just it is shifted by half. But I will put the negative sign because it is shifted right. And here what I will put? Shifted right by 1. And here what I will put? So this is 2 by 3 into 2 by 3, that would be 4 by 3 plus 1 by 2. What is the value of omega naught? Omega naught, T naught is 3 by 2. So what is the value of omega naught? 2 pi by T naught. That would be 4 pi by 3. 4 pi by 3. So e to the power minus j n, 4 pi by 3 divided by 2. That would be 2 pi by 3 plus 1 by 2 e to the power minus j n 4 pi by 3 plus this is 2 by 3 and then this is 2 by 3. This was 2 by 3 and added with 2 by 3, that became 4 by 3. So this is the answer we are getting. Option 1 is matching. 4 by 3 plus 2 by 3. 2 by 3 is okay. Sorry. 1 upon 3 by 2, that would become 2 by 3. No, what I am doing. This would become 2 by 3. 2 by 3. So option 1 is matching. What we are getting? This was our C of n. C of n. So C of n is coming out to be 4 by 3 plus 2 by 3 e to the power minus j n 2 pi by 3 plus e to the power j n 4 pi by 3 minus 4 pi by 3, right? Minus 4 pi by 3. Now one thing you will always remember, here what we are getting minus 2 pi by 3, here we are getting minus 4 pi by 3. Always try to make plus 2 pi by 3 here. Anyway, try to make plus 2 pi by 3. Because here I am having minus 2 pi by 3, so here I will try to make plus 2 pi by 3. Why is that so? Because I can see the option cos 2n pi by 3. That means anyhow I try to make 2 pi by 3 here. How can I make it? What is 4 pi by 3? What is 4 pi by 3? 4 pi by 3. Can it be written as, although there is a negative sign, but I am ignoring the negative sign as of now. What I mean to say, e to the power j 4 pi by 3. Can it be written as e to the power j 2 pi minus 2 pi by 3? Right? This can be written as this. Can this be written as cos 2 pi minus 2 pi by 3 plus j sine 2 pi minus 2 pi by 3? Cos is in fourth quadrant. Cos is in fourth quadrant. Positive. Cos 2 pi by 3. Sine is in fourth quadrant. Negative. Sine 2 pi by 3. E to the power minus j 2 pi by 3. Right? So e to the power 4 pi by 3. E to the power j 4 pi by 3 is replaced with, this was your e to the power j 4 pi by 3 is replaced with e to the power minus j 2 pi by 3. So from here what formula I am developing? E to the power j 2 pi minus theta. What that would be? E to the power j 2 pi into e to the power j minus theta. What is the value of e to the power j 2 pi? Cos pi plus j sin pi. Cos pi is 1. Sorry, cos 2 pi plus j sin 2 pi. Sin 2 pi is 0. Cos 2 pi is 1. So this value is 1. So e to the power minus j theta. Same thing we are doing here. 2 pi minus 2 pi by 3. So e to the power j, what is the value of theta? Minus 2 pi by 3. Sorry, e to the power j 2 pi minus theta is equals to e to the power minus j theta. Basically this will come minus j minus theta. So what is the value of minus theta here? Minus 2 pi by 3. So e to the power minus j 2 pi by 3. So this is what we have developed. Right? So this formula you will remember. It can be used in some of the expressions. So e to the power minus j 2 pi by 3 I can write down here, and another minus sign is there. We wrote it down for the positive. Another minus sign is there, so it will become 4 by 3 plus 2 by 3
e to the power minus jn 2 pi by 3 plus e to the power jn minus 4 pi by, here e to the power j 4 pi by 3 is there. If I multiply minus sign, then another minus sign could come here. If I multiply here minus sign, then another minus sign would come, it will become plus. There you go. Option, this also matched. And then I divide by 2, multiply by 2. What I do? Divide by 2 and then multiply by 2. 4 by 3 plus 4 by 3 cos 2 1 pi by 3. 4 by 3 1 plus cos 2 1 pi by 3. This is equals to C of n. So 4 by 3 into 1 plus 4 by 3 into 1 plus cos 2 1 pi by 3. This also option is also matching. Are you able to understand this point or not? So always in the examination we can do something, we have to go by the options. That's why I have given the options in this particular question. Option are given. This is the reason options are given. Okay, so if these kind of things are coming, we need to keep our brain active, that we can interchange. Although these questions will be very tough in the examination hall. This will be counted in a tough question only. Okay, so but we need to try to give our best. This is a question from standard book only. Although this answer was given directly, so I picked it up, I made 3 options and in that manner I proceed. So these kind of questions can be asked anyway. Any time in the future, these kind of questions can be asked. Now the next question, this is also very good. You will say that it is very easy, but again this is not MSQ. Here A, B, C and D options are there. So one of them is true. Everyone will be able to find out this one, but I want you to find out this option. So whenever you find out sine A divided by sine B, basically if you get A by B form, then you need to be aware you can get that A by B form. In the options, if you get A by B form, that means numerator divided by denominator, then you have to be aware. What kind of awareness would be there? Let's solve this question and you will understand. So mode of Cn and angle of Cn graph is given. From there can you find out the values, and here I have just made the dot, which is actually wrong. Here all these are 0. Okay, all these are 0. All these are 0. So C of 0 is 1. Mode is 1, angle is 0. Cn is equals to mode of Cn, angle of Cn. So what is C0? Mode of 0 is 1, angle is 0. So 1, angle 0. What that would be? 1 only. So C0 is 1. What about C of 1? So mode of C of 1, angle of C of 1. So what is mode of C of 1? Mode of C of 1 is 1 and angle is pi by 2. So 1 angle pi by 2. That can be written as e to the power j pi by 2, and that is equals to j. So C of 1 is j. What about C of minus 1? C of minus 1, angle is minus pi by 2, mode is 1. Angle is minus pi by 2. Angle is minus pi by 2. So this will be minus j. What about C of 2? Again mode is 1, angle is pi. Mode is 1, angle is pi. That means it is minus 1, because angle pi means minus 1 only. And C of minus 2, again the mode is 1, angle is minus pi. Pi and minus pi both are same thing only. So C of minus 2 is also minus 1. Now you will solve it. What you need to find out? X of t. So x of t will be C naught plus C1 e to the power j omega naught t plus C2 e to the power minus j omega naught t plus, C of minus 1, really sorry, C of minus 1 e to the power minus j omega naught t, C2 plus e to the power 2 j omega naught t plus C of minus 2 e to the power 2 j omega naught t, but there minus sign. So C naught is 1, C1 is j e to the power j omega naught t minus j e to the power minus j omega naught t. Then here minus 1 e to the power 2 j omega naught t, and then minus 1 e to the power minus 2 j omega naught t. Then what you need to do? 1 plus this j comes common, e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j multiplied with 2j as well. So here I will multiply with 2j as well, right? Then minus 1 comes common here, e to the power 2j omega naught t plus e to the power minus 2j omega naught t divided by 2 and then multiplied with 2. So what I am getting, this will become minus sign, j and j will become minus 1. So xt is 1 minus 2 sin omega naught t plus minus 2 cos 2 omega naught t minus 2 cos 2 omega naught t. This is the answer of x of t. 2 sin omega naught t minus 2. Options are matching or not? Yes. Minus 2 cos 2 omega naught t minus 2 sin omega naught t. So this answer we are getting. But what about the option A? Whenever you get A by B, there will be a GP for sure. What do I mean by that? So x of t you will write down. C naught is there as it is. What was C naught? C naught was 1. So let's start from C of minus 2. Let's start from here. Okay. Let's start from minus 2. So here what was the angle? Angle was pi. Angle was pi. E to the power j. Angle was minus pi was written. So let's write down minus pi. Then this was the value of C of minus 2. Again I am writing down all the values. What was C of 0? That was 1 only. What was C of 1? That was e to the power j pi by 2. Right? E to the power j pi by 2. Now I am not solving it. What was C of minus 1? C of minus 1 was e to the power j minus pi by 2. What was C of 2? C of 2 was e to the power j pi. And what was C of minus 2? That was e to the power minus j pi. The way it was given, I am writing as it is. So what will be your xt? C of minus 2 e to the power minus j pi, e to the power j 2 omega naught t minus 2 omega naught t plus C of minus 1. What was C of minus 1? E to the power minus j pi by 2, e to the power minus j omega naught t plus C of C naught plus C of 1, e to the power j pi by 2, e to the power j omega naught t plus C of 2, e to the power j pi, e to the power j 2 omega naught t. Right? So what we are getting? E to the power minus j pi plus 2 omega naught t plus e to the power minus j pi by 2 plus omega naught t. Yeah, okay. Pi by 2 plus omega naught t, then plus 1, then e to the power j pi by 2 plus omega naught t, then e to the power j pi plus 2 omega naught t. Right? Can I see one thing? That this is half of this angle. Are you able to understand this point? If I say this is my e to the power minus j theta, what this would be? E to the power minus j theta by 2. What this would be? 1. What this would be? E to the power j theta by 2. And what this would be? E to the power j theta. What is theta here? Pi plus 2 omega naught t. So whenever these kind of things are given, these kind of options are given, then there is high chances that this kind of GP will be made. Isn't it a GP? If you multiply e to the power j theta by 2, this is what you will get. If you multiply e to the power j theta by 2, this is what you will get. If you multiply e to the power j theta by 2, this is what you will get. If you multiply e to the power j theta by 2, this is what you will get. With a common factor of r, number of terms are 5. A is e to the power minus j theta. So this is a GP. And do you know the summation of GP? Yes. What is the summation of GP? A r to the power, what is r? E to the power j theta by 2, r to the power n, number of term is 5, n minus 1 upon r minus 1. Look, these kind of questions will not be there in any notes. You might feel like that, sir, this is tough or anything. These kind of things are not even taught. That's why things becomes easy. There is one particular platform, I am not taking the name of that platform. They only teach easy things. Okay.
They will teach easy things and people will think that, student will think that, okay, we are learning everything. This is the best teacher. This is the best platform. I'm not talking about the educators. I'm talking about the platform. This is what happens. But here we are going to take the pain. Okay. At least in the lecture, when you are learning, when you are preparing, have the pain. This is the thing that I tell to students again and again. Solve the problem without watching the solution. Do it, have the pain. If you are having the pain, that means you are preparing. And if you feel like that everything is going smooth, then you are not preparing. I am solving the DPP, I am able to solve everything. I am solving the PYQs, I am able to solve everything. Then I go to test series and I am not able to solve anything there. Everything, and then nothing. And in the examination hall also nothing. So whatever the material that you sold, you took least pressure there. If you take the maximum pressure in the preparation, then least pressure will be there in the examination hall. Okay, so have the pain. And this kind of mistake you would have done in JEE as well, that you did not have the pain. You were just learning on surface level, and that costed you your seat in IITs. But this mistake you are not going to do here. Okay. So e to the power j 5 theta by 2. Although this is not tough, this is just mathematics, nothing else. Then e to the power j theta by 2 minus 1. Now here what we can see, theta by 4 is given. So anyway, if I get this kind of expression, I would know that if I take e to the power j theta by 4 outside, then I can make e to the power j theta by 4 minus e to the power. What I mean to say is that this is e to the power minus j theta. I am solving the denominator. E to the power j theta by 4 if I am taking outside. What I will be left with? E to the power j theta by 4 minus e to the power j theta by 4. Or you can take inspiration from the option as well. Right? Now what about this one? What I need to take outside here? I need to make the symmetry, right? Anyway, I need to make the symmetry. So what I am getting here, e to the power j theta by 4. These should be cancelled, right? These should be cancelled. Then only I will get both sinusoid. No, basically nothing should come here. What does that mean? That I need to take e to the power j 5 theta by 4 outside. Basically half of this I need to take outside. E to the power j 5 theta by 4. Because what will be left then? E to the power j 5 theta by 4 minus e to the power minus j 5 theta by 4. So what you are getting? This would be 5 theta by 4 minus theta, that would be e to the power j theta by 4. Here also e to the power j theta by 4. What this would be? E to the power j 5 theta by 4 minus e to the power minus j 5 theta by 4, right? Divided by 2j. Why I am dividing by 2j? Because I need to make sinusoid. And in the downward as well, e to the power j theta by 4 minus e to the power minus j theta by 4 divided by 2j. So this and this is getting cancelled. What I am getting? Sine 5 theta by 4 divided by sine theta by 4. And what is the value of theta? Where theta is pi plus 2 omega naught t. Here what we consider? Theta is pi plus 2 omega naught t. The same thing we are getting. So this is what we are getting. This is the answer, where theta is pi plus 2 omega naught t. So theta value you can put on your own. Pi plus 2 omega naught t. So always whenever you get A by B type of option in the question, what you will do? You will always try to make a GP there, because there is very high chance that GP could be made there. Okay. So there is a chance of GP. In that manner GP will be made, and very easily you will be able to write down the answer in the examination. So whatever the angle is given, just keep those angle as it is. Don't convert it into j and minus j. If you convert it into j and minus j, then only numerator will come. But if you need to make denominator, that means I need to make GP. And if I need to make GP, then this is what I need to do. And this is the end of this lecture. This was extensive problem solving, I know. But now you felt like that, sir, how we will be able to do all these things in the examination hall? So the purpose was not to make you learn for the examination hall. The purpose was not to make you learn for the examination hall for these particular questions, because these particular questions will be like this one was lengthy, but this one will be answered very easily in the examination hall. But if you take attention here, then this kind of question you will be able to solve in the examination hall. Which kind of question? This kind of question, if you take attention here. So that's why I say every lecture is important. In the examination, you might not be solving this problem in this lengthy way, but whatever the learning you are taking, that is important. So in the whole lecture, there are a lot of learning, like this differentiation. This is also a learning, right? and then using the differentiation property in a very good manner. Who knows, in examination, in any question, you need to use the differentiation. You need to use the differentiation property. Whatever, anything can happen, right? Anything can happen in the examination hall. Say yes or no. So that's why this lecture was important. I hope you would have understood a lot of things. More properties of Fourier series coefficient are left. That also we will see. But in the next video, we will learn about symmetricity in trigonometric Fourier series coefficient. So now we will be moving our attention to trigonometric Fourier series coefficient. And then we will again come back to Fourier series coefficient, exponential Fourier series coefficient. So this is how we are moving, and I have made the flow. Okay. Just I don't want the things to be clumsy, so that's why few things property, then again moving to trigonometric Fourier series, then again coming back to property. So this I have thought of it. That's why I am teaching the properties separately. Otherwise I could have taught properties in one go only, and then it will be all clumsy. But now you are not taking the pressure of property, you are understanding the property in a very lenient manner. Well and good. Let's meet in the next lecture. Thank you very much.